Okay, start. All right, welcome to NixCon 2024, day 2. I see not everyone has woken up yet. I hope you're all well rested. I'm not, but that's okay. We'll start with the Nix Constitutional Assembly panel, and I'm just gonna hand off the mic to Ron. Let's welcome everyone on stage.
Awesome. All right, so, am I on? Yep, 1, 2, 1, 2. It's okay, I'm like beta tester for every morning. This is what I do. All right. Beta tester for the morning. Again, welcome everybody. Super excited to see you all here. 9 a.m. on a Saturday is a prime time. I'm sure everyone's pumped, caffeinated, really ready to go. That's why we have like the most exciting piece of the day right now. So we're going to start with the NCA panel. First of all, Silvan is going to do a short presentation about the NCA, and then we're going to go into it. So think about your hardest questions that you want to hit people at 9:05 in the morning, and do that. They won't like hold it against you. One of the things I did want to call out is, again, super excited to be here. We had the State of the Union panel yesterday, and actually, I did want to call out that during the financial slide statement, I wasn't sure how explicit it was that the folks on the bottom line are all sponsors of our community, right? So that includes Flying Circus and Fastly and a few folks on that line. So again, that's a huge shout out to them. So thank you to those folks that are making a lot of these things happen, specifically also Flying Circus on the discourse. So with that said, we're going to kick off with Silvan. I'm going to skedaddle over to the right, and you'll see me in a minute.
All right. Oh, and this is already working. Very nice. Also, I prepared this at 4 a.m. tonight or so. So don't expect like something perfectly polished, but I try. I didn't really expect to present something like this year, but I guess here we are. So it's not a technical talk compared to pretty much every other one. And you might not have thought much about these things, community values and project governance, but they've always been there, just very implicit and very kind of underspecified. As projects get established, these are very implicit at the start. So like your initial community might be just you and your colleague working on a project. But as the community grows, you need to be more explicit about this. You might need to evolve governance over time to ensure long-term sustainability. And so, that's kind of why we need this now. And right, so over like the past couple years, we've really noticed this, where there's like some decisions are lacking. We need to improve some things on governance, on how decisions are made, things like that. And so a couple months ago, the board appointed us, the Nix Constitutional Assembly. 6 of us are here right now. 1 person is missing. To rework governance of the Nix project and establish a community-based governance structure for that. Now we're almost done with this mission, and they're here to talk about our work. So I've been selected to make this introduction. We're going to do questions, but you can also ask us throughout NixCon as well, or after NixCon as well. And we're not going anywhere. We have a repository where there's kind of all about us. But before we actually look at governance, we kind of identified the need to kind of really establish and write down the values of our community. And what are our values? What are these useful for? They can be used for guiding decision making, making sure that everybody is moving in the same direction. And so like the idea would be that anybody in the entire community can invoke these and get decisions to be reevaluated if they don't align with the values, without regard to their rank or title, so really anyone should be able to do that. And thanks to Krertel, I'm not sure if I pronounced that correctly, we have these values on the NixOS homepage now. It's in a, you can go to nixos.org. There's a tab at the top as well. I'm going to go through them fairly quickly here, but there's more to them. So please go check them out, get familiar with them, share it around, and make use of them. Yeah, so I go briefly through this. It might be a bit, it's a lot of things, but I'll try to get the gist of it. So respect and civility, it's a very basic thing. It's about conduct. It's that we respect everybody, no matter their identities, circumstances, what their contributions are, what their status is. Everybody should respect everybody else, and everybody has the right to be respected. That kind of idea. Sometimes also you need to. Well, civility is a hard thing to define. Kind of something that we came up with is to say that sometimes we need to prioritize project health over our individual interests as well. Yes. Yeah, and also another part of this is that people in like leadership, there's higher expectations in these positions as well. But yeah, you can read about that more on the website. I'll move on here. Another kind of core value, these are headers, but the statements under the headers have kind of the same weight, so this isn't the entire value. But yeah, so we are here as individuals, and we can gain trust by doing work, and trust and status by doing work. Organizations can gain prestige by funding individuals, and our priorities working together with a vibrant community and a diverse community as well. And so that's like, I guess an example would be if someone just comes along and is like, hey, I want to work on this thing, picks it up and does a good job maintaining it, then we can trust this person with this component and they can take ownership of it and yeah, kind of that evolution. Another one is free software and choice over lock-in. So that's, I mean, these should be, the goal of these is to be fairly generic, and so nobody should be like super surprised about any of these, I hope. But yes, and Nix projects should always remain free software. We also want to work with the wider free software community, but also we need to respect that like packages and Nix packages are sometimes not always free, and we don't want to disallow that. That's something we do value as well. Another one is distributing decision-making very widely. Like we are a community or various overlapping communities as well. There's not a single centralized place where decisions get made. We need asynchronous communication. We need clear ownership, very local decision-making empowerment. Yeah, and there's also one kind of interesting aspect here is that sometimes we have different goals, but we should try to still work together on our shared goals. If we have independent goals, we can work on these independently in a non-conflicting way as well. But let's try to get to work together on the things we can work together on. Yeah, that's that. Another one is automation over process and toil. We are a large project. Contributors have very limited time, limited energy, and so we need to build automation to make things go smoother and to unblock people's time, let the computers do the work for us. And I've talked a bit about this yesterday in the State of the Union, where I'm working on a bunch of automation things, that kind of thing. Yeah, another one is stable evolution over stagnation or chaos. So like this is how Nix came to be. Like a lot of great ideas have been made, and this is why we're here. But also it needs to be a good balance because you can't just evolve and experiment the whole time. You also need these stable components. Like you experiment and then you try to figure out what works well and stabilize that thing so it's reusable and stable so people can rely on it. Yeah, that's. Oh, and this also goes a bit not just into code, but also into like the leadership and contributors. So like leaders have a duty to find new contributors, to promote them, to support them, and eventually step aside for them. That's also an evolution of, I guess, the people kind of running the thing. Yeah. But yeah, these are the 6 kind of headers of the values. Yeah, and with this done, the next thing we kind of focused on was the actual constitution. So it's called a constitutional assembly because we should write the constitution. And so that's what we did. And we used these values to inform ourselves about what it should look like and things about that. So it's really quite like there's a lot of details in the constitution. So this is like a super short overview. But the basic thing here, the new thing here, is the steering committee. And so the steering committee, a group of 7 people that get elected by the contributors of the official projects. And in turn, the steering committee then governs these official projects. So they're empowered to do things like change processes, change teams, things like being an escalation point, the final escalation point for conflicts, and more. You can read about all of that in the Constitution, which is here in our repository. Yeah, but the SC should delegate as many things as possible. They shouldn't really do a lot of work, but rather just ensure it gets done. Yeah. Then the Foundation Board will keep supporting the official project as it has always done, but we have this new kind of dynamic where the board members will be approved by the steering committee as well. Yeah, I think that's the basics of it. And yeah, how do elections work? So we're running an election right now. So that's the 2024 one. We have a separate repository, which is all about the election. So we have 800 voters based on a criteria we determined based on the number of commits. This was determined we needed a way to automatically figure out a good heuristic for the contributions. But also we had an exception process where people could say, oh, this heuristic doesn't really count me well, but I've contributed that amount. Yeah, so we had a nomination phase of about 3 weeks. We ended up with 23 candidates. You can also look at them at the link here. Then we had a voting phase. Well, we should be here now at the first steering committee, but our voting platform has kind of decided to have a data loss for our entire election. So we broke their 18-year record of no data loss. So thank you. But yeah, so we had to start it over. Unfortunately, the plan was to have the steering committee, the first one, just before NixCon. That didn't happen. So now we just have to add another 2 weeks for the voting phase. But yeah, like a week after NixCon, we should have the first steering committee. We'll need to mess around a bit with CIVS still to figure out the results, but not looking forward to that, but it's going to be fine. Yeah, and that's it for my short presentation before the panel. Yeah, thank you, and we'll take some questions.
Awesome. Thank you, Silvan.
Yes.
All right, cool. So we have about 15 minutes before Berber is literally going to lift me off stage. And the main thing that we wanted to do is kind of really open Q&A. I will do a quick, I won't do like a really deep introduction of the NCA panel themselves just because we're slightly out of time. So I will test you guys if you can, you know what, I won't test you guys. We have Danielle, Edith, Ryan, Sarah, Lassulus, and Silvan up on stage with us. We're going to say virtually hi to Michael, who's been also spending an insane amount of time to make this happen. And I'll just kick us off. So the way this is going to work is that we asked folks if they have questions online yesterday and the few days before that. There was a few questions that got votes, but I'm just warming you up so you have ideas of how hard to hit the NCA with really tough ones. No, I'm kidding. Ask the questions that are meaningful, right? Be obviously courteous and maybe listen to some of the things that Silvan had on stage earlier. So one of the first things I think that folks were wondering from the community in general is how did things operate internally inside of the NCA? Obviously, you guys kept it very transparent as much as you could, but at the end of the day, I personally know that there were 4-hour-long meetings that no one actually wanted to sit in. How did it work?
I'll do this as sort of the outsider because it was a very fun experience going into this as an outsider. So we had 4 hours of meetings each week, and there were lots and lots of discussions about what the community looked like, what the community aspirations were, what the history of the community had been, where inflection points were in the community. Where we thought different groups and different overlapping communities might have tension, and that led us to start with a conversation about values and what is really important and what do we anchor this work on. But generally, I think the conversation we have to say a huge thank you to Silvan, who did a lot of the organizational, operational, keeping us moving, and then the rest of us were working to. Consider how people moved in this organization and try to help build the minimum rules we needed to bootstrap and get started a community governance that then would have the gravitas and support of the community as it begins to take off with the steering committee and begins to start changing the things that we've started, because everything we gave was a starting point. Everything we talked about was, let's start here and we'll see how it works. This is an experiment, and you all will end up owning this through your engagement with the new steering committee.
Thank you.
I can be long-winded. So.
Anyone want to add anything before I move on?
This is a lot of people to try and get 4 hours a week of overlapping calendar time in. Not to mention the amount of time we all spent talking to like random contributors from all over the world. And I just want to be like, wow, we did it.
Very cool. So yeah, I can definitely attest to the fact that Silvan is a beast note taker. I don't know how that happens, but it's phenomena. Anyways, all right. So the next question we had, and I hope you guys are warming up. I know, again, it's 9:18, so we're all awake. One of the other questions was kind of, maybe, I don't know if it's a controversial one, but can you kind of share some of the larger disagreements that happened before they ended up being resolved? Like, what were they?
I mean, I can talk about it. I feel like for any major, I feel like we didn't really have a major disagreement. For any disagreement, we just talked about it more, and we're figuring out where is our disagreement really? Did we misunderstand something? Do we have a different view of the community? Does someone know a perspective that we haven't seen before? And through that, we ended up not really. I don't think we had an internal decision procedure for if we struggle with making a decision, we do a 5-7 or 5 supermajority vote or something like that. I don't think we ever ended up using that because in the end we always resolved things just by talking. So yeah, I'd say none, but I don't know, maybe that's unbelievable, but I feel I think so.
Yeah, I agree. It was all very much consensus building as opposed to sort of binary disputes. I think, the reaction that I saw from the internet and the community when we posted the values was to some extent okay, that's boring and obvious, right? But this represents maybe, I don't know, 200 hours or 300 hours of work from us to arrive at that. And so some of the disagreements we had as they were not so much I think A and Silvan thinks not A, right? It was more each of these values exists on a spectrum or in a multidimensional space, right? And we all came to it with a slightly different point in that space. And how do we find the ideal spot on the spectrum that really represents where the community was? And I think we were all pretty aligned on the idea that this was not about us sort of choosing the best point on the spectrum, but it was about us trying to suss out, like, where does the community stand? Like, how, when we talk to so many people to try to understand this, but like, you know, what exactly, how do we thread the needle on like open source versus closed source software? You know, with that value, we came to the conclusion that, like, you know, you look at Nixpkgs and it does support people installing and using unfree software, but we also don't want Nix itself to become unfree. So there were some details, but I think the disagreements as they existed were mostly in the weeds. They were in the details, which we spent a lot of time on. We tried to get that right, but we didn't have any big disagreements.
And a lot of where we had those disagreements turned into actually finding the point that we thought reflected the community. Like, there are various points that we had like long conversations about direction and so many hours talking about specific words. But I think in the end it worked out for like representing where people are.
Yeah, and I can say as like the board member sitting in and trying to, right, like be external but helping out, I think this was the perfect example, and I'm sure that we could have been even more perfect, but right, we're all kind of starting off at a certain phase where I saw this as kind of like the microclimate between different folks with very different views, different backgrounds, coming in and trying their best to think about themselves, think about where they're coming from, think about the community, and think about the folks that are different than them inside of the community. So for me, at the end of the day, while there was a lot of discussions, you could probably, if we like AI'd and data science this, you can see like the things that we talked about the most probably were the things that we invested the most into. I think that was more of a norming and forming mechanism where it was like everyone comes in with their opinions and slowly this Play-Doh ends up looking like something after an X amount of time.
I'll jump in with one further bit. Our ultimate goal was how to get many people with very different opinions, perspectives, outcomes, interests to be able to work well together within this community. And so the structure, again, was minimum structure to help give enough guidance that you all will be able to mold what you need going forward, but you can do it by working together as opposed to pulling against one another in different ways.
Thank you. So I'm going to just mention we have about 8 to 10 more minutes. If folks like raise their hands, I'll notice you, and then I'll make sure to call you out for the questions when we are doing that. But I can keep asking questions from the interwebs. Kristen.
Can we do a test on the value thing? I read it on the website. So something I have on my bucket list of where we need to do something technical later, where the value thing could be coming in, would be the stable evolution stuff, where having to make decisions about what backporting, et cetera, et cetera, et cetera. And there are a couple of examples where suddenly packages disappear from the stable tree because they're insecure. Is that a moment where I should be invoking the, hey, stable evolution is a core value, we should be using that here?
Ooh, that's a great question. I love that. Thank you.
My unpopular opinion is yes.
No, it's more popular. 100%.
But like less tongue-in-cheek. It's the kind of thing where you should be able to have a conversation about those values. And if the decision goes against like a naive reading of them, explain why. Because at the end of the day, as long as everyone comes to as long as there is consensus on something, sure, that's a decision. But like, it is a thing that you should be able to go back to those values and go, well, we say we care about this as a community, why are we diverging from that?
And I can also attest to the fact that for us, when this started, when we were talking about values, it was very important that these values are not something that we plaster on the wall to make us feel good about having values plastered on the wall. Values for us are very actionable. Values for us are hopefully the things that the community can use in a conversation, to Christian's point, to sway the discussion in a way that we feel that the community aligns with more. Right, so it's actually an actionable item.
I think I also want to say that I feel like these values aren't like you can just slap it on anything and to get something you want to tilt in that direction. There's like a lot of, like every decision has a lot of arguments, pro and contra, and sometimes it just makes a lot of sense to make a decision that might seem to disagree with a value, but you have a ton of arguments for actually doing it that way. I feel like these values are more like a tilting thing. When you're like very close to, I'm not sure if if we should do this or we shouldn't do it, then you can look at the values and be like, oh, well, the values say that, so we should do this.
Or maybe use it as a default.
Yeah.
It's like a guideline, right? It's like some baseline to the ingredients that we're all going after. So it just hopefully helps more folks, new and veterans, kind of get a vibe for it.
Right. It helps us all keep moving in the same direction and sticking together, right? And to Ron's point about the values being something that we actively use, that's something that we thought about a lot on the NCA. You know, we wanted to make sure that the values were something actionable. And so one of the metrics for our own success that we thought about during this process was like, are people actually bringing up the values in real decision making? And we had a interesting interaction that happened a couple of weeks after we put the values out, where somebody in a GitHub thread, you know, brought up the values to counter one of Silvan's points, and we all talked about that at the next meeting, and we thought it was great. It was really the values being put into action.
So we removed that value.
Yeah.
Great. I don't see hands, so next up, hand. Oh, wow, you're making Berber run. But he's rested after picking up 500 shirts, so it's fine.
Hey, I feel that in any large, especially growing and evolving organization, when the values aren't clear, I've seen that as people join and leave and join and leave, small, tiny little arguments, maybe in a discussion thread, just happen. And if both people agreed about some single value or explicitly agreed, that wouldn't happen. Could you just maybe attest to the efficacy of your value list, the Constitution, say that this happens often, or are there examples that you can bring up? What are some specific ones, even random?
We spent about 2/3 of our time getting to the point of writing that values document. And after we had agreed on like what our like foundational principles of doing everything else was, it all just kind of fell into place. So, yeah,
I think the other thing I think is that this is all like day one, right? So it's weird. We're a community, 23 years, but I think I mentioned yesterday how many first times we're having like right now live with all of you in the room and all of us kind of in the ecosystem online. This is the first time. And I think this is what the NCA was trying to establish, is just like some baseline that can allow all of us to move forward together. So if we come in a week, 10 weeks, 3 years, and we notice that there's a different value that aligns better with us or a value that aligns less, then I think that's like the whole forming process of making it better.
To Danielle's point about spending about 2/3 of our time on the values, I've generally seen in big open source communities, if you can establish values, or even in big communities broadly, if you can establish values and the values move most slowly in their change, then that gives you a really good anchor for how the governance and the conversations and the technical choices move around them. So yes, we would love to have people agree with the values and participate in the values and even challenge the values, but those should move much more slowly than participation in a steering committee and changing potentially even parts of the Constitution. Or how we do the next election. We may learn a ton from this election. We're learning a ton from this election, let's be clear. We'll learn a bunch, and the next election committee will have some new changes to make. So the values, I think, will be the most slowly evolving thing, but all of this was written with the idea that it will evolve over time. It needs to, in order to keep this community fresh and alive and delivering what you all want out of it.
And we made it really annoying to change the values.
We did make it really annoying for this reason.
Yeah.
It's almost like one of our values is stable evolution.
It's recursive.
Thanks much.
Of course. So as we wait for another question, I think, we already have another question. Great. I don't even need to be here.
Hey, I don't fully understand how the steering committee works alongside with the foundation. Like, is the graph said the steering committee approves new members of the foundation, but who removes members from the foundation?
So there's
How long
definitely
is the mandate for the foundation? Because steering committee, the mandate is 1 year, if I understand correctly.
Maybe. So like there's, I mean, the Constitution goes more into detail about how that exactly works. In short, it's that we decided to introduce terms for board members, and after the terms, it's I think there's like some like back and forth where like the steering committee can like reapprove some.
I can kind of expand a bit on that, and obviously also evolving because most of the focus for the NCA was really the steering committee, and one of the things that we wanted to do as the board was to ensure that there's like an overlap and there's still not like some entity that sits on the side, and that it's kind of like a triangle. I like triangles this week. So the way that we're expecting it to work is that once the steering committee comes in place, I'm going to be working, as the board, with the steering committee to go and define the specific roles that the foundation need, because the foundation is a bit more situational in terms of like, we technically, need someone in treasury and we need someone in partnership. So there's like specific needs that we need coming in. And once we define those needs, we'll definitely share them very publicly. Again, everything is transparent. And then we'll do kind of like a call for nominations. And then that would work between the board and the steering committee to kind of like help draft up the first ever rotation of the foundation. And again, then we have the term limits and everything, so that will start becoming its own mechanism that operates. But the way we've been imagining it is like at all times there's 2 steering committee members that are actively participating in board functions, especially things like board elections. So it kind of keeps a very cohesive ecosystem with the board and the community and the steering committee.
Well, that's not in the Constitution, but yes, that
Yeah.
might be how it works. But maybe like to answer very specifically, there is, so I mean, I don't want to like kick it around. There is no way for the steering committee to force a removal of a board member. They can request removal. They can be very public about it, that we don't want this board member anymore. But the board can also block that again. It's in the Constitution defined like that. But so the idea is kind of it's kind of a two key system where steering committee is on equal footing with the board, and that's kind of the idea.
I think we'll have to more or less cut you off.
Awesome. All right. Again, thank you, everybody. We're all around for the rest of today and a huge part of tomorrow, so thank you for coming in super early. I know that wasn't easy, and we have all not been drinking late last night, so hope you have a really successful, good second day. We are going to do the inaugural NixCon photo at some point in the afternoon, so keep that in mind if you want to be part of that packed room that gives everyone else FOMO. Ask us what time. I'll figure it out with the ground crew here. And have a good first day. And thank you to the NCA for joining us.
One, two, 1, 2. Okay, let me remind everyone we still have a few open slots for our ad hoc lightning talks. If you want to do a lightning talk today, please send us your slides to 2024cfp@nixcon.org. And yeah, it's first come, first serve.
Ready to go.
All right, welcome back. Let's get ready for the next talk, becoming a Nixpkgs contributor. Give it up for Jacek and Tom.
Good morning, everyone. Actually, I'm just going to start off and say, do a little intro. This is Jacek. I'm Tom. I'll let him run through that. I think the idea here was that I get asked a lot, how do we contribute to Nixpkgs? Usually someone shows up to the community or they get exposed to Nix and obviously they love it. And then they go, what can I do? Or how can I start getting my things into this ecosystem? And we thought we'd kind of answer some of those just how do you get started questions. But yeah, I'm Tom Bereknyei. I work at Phlox.
I'm Jacek. I'm the CEO of Nix Academy.
Okay. So I'll just kind of jump right into it. First off, what are the things, how to get started? It's kind of, just read the manual is, maybe not the nicest thing to say, but in the end, that's a big piece of it. So, yeah, what manual should I read?
Yeah, so there's like the contributing.md file, like linked here. It's, yeah, as you said, a boring document, but it's very easy to understand, like concrete steps, what to do, what not to do. When I open a pull request, how does the title of the commits look like, of the pull request, stuff like that. And yeah, just read it. It will be very, very helpful to you. And that's the starting point.
What about, what kind of other resources can I use?
Mm-hmm. Yeah, so in the Nixpkgs manual, I mean, mind there are 3 manuals, Nix, NixOS, and Nixpkgs, right? In the Nixpkgs manual, there's this contributing part, and that together with the contributing MD will give you I think it will answer 90% of your questions already, and be also very instructive, concrete with steps to this and that, right?
Okay.
Of course, we also have our videos, blog posts, office hours, forums, chat, where I would go to the discourse of the NixOS community, and there you can see, especially the office hours are announced there, and I think this is very good list of everyone will find something that appeals to them to get into this topic. All right, Tom. So where should I start if I read all this stuff now and still have questions or feel insecure about how to do this?
Well, start small, right? That's the easiest way to get started. Start with something that you like doing. Either that's you have some problem or some itch you're trying to scratch. Probably not start with the biggest thing or the most complicated thing, large services, large, complicated, involved things. Either something small. So either something that you have a particular interest in, some sort of passion, something you're trying to learn about, and fix a small bug, bump a small version, something along those lines. That way you can kind of use that as a way to understand how the ecosystem works and what it is that you're doing. This is probably, one aspect here, though I do sometimes caution is your first thing might not be creating a brand new package, because usually if it's open source already and it's easy to package and popular, usually that means someone's already packaged it. And so might end up finding a situation where if it's, one of those three isn't true, you're gonna be kind of a lot harder, especially when you're first starting out. If you're interested in the NixOS model, hey, go look at the services. There's always documentation. Another thing you can do is you can help review PRs, right? So as a committer, it's like really helpful if I go, hey, someone who's passionate about some piece of software has already looked at it and they're like, yep, it works the way it's supposed to and we like it. And that really helps. So review PRs, and also that gives you an idea of how other people are updating things and how the community works, and it just gets you involved. So go review things. But then, where is all this stuff? Where is all this stuff I need to look at, or what do I review? How do I, where is the next step of getting started?
Yeah, so if you want to find certain packages, the best first spot to look at is in the Nixpkgs repository, like the big GitHub repository, right? Inside that, there's this packages and by name subfolders, and most new packages go there anyway. There's this other path, like the neighbor of this path contains all the other packages, but look into the packages by name first. And package Nix and default Nix, these are the files inside that folder. Just look at them and you will get a feeling like, how is it all added? How would I add a new package there? Or when I want to patch a package, where is it actually? You will find it there by just Control-Fing through the file, right? And then study whatever you're going to take care of here, and then get your first pointers on how to change it. Of course, the package definitions also contain names of the maintainers. So if you have like questions, how would I do this with this package? I want to do something, but I don't know how to approach it. Of course, you could find the maintainers and ask them, and I'm pretty sure they will be happy that someone tries to help. So, sorry.
Yeah. I start contributing. One problem that's come up often is, well, what if we all of a sudden ping everyone? How do we stop that?
Right. So one thing is, like, as Silvan already explained yesterday, that is kind of being fixed, right? So that is a relic of older times. Of course, so what really happened was you do something wrong, and then 100 people get a notification on GitHub. Some of them are really annoyed, and you don't want to be that person. Maybe that's kind of embarrassing to trigger that. So don't fear, it's kind of less likely to happen now. So it's less dangerous now to open a pull request, thanks to Silvan. But still, you would like to ping only as few and as relevant people as possible. So you should generally rebase your pull requests. So when you have a commit that fixes something, and then open a pull request to master, ideally rebase to master first, so that we have a very nice and short change history, so to say. And this way, anyone who is like pinged automatically will be just in the set of the relevant people here. So, Tom, how do I bump a package? I just want to update anything, not fixing anything else. How do I do this?
Excellent way to get started. Let's kind of break it down. There's only a few things you usually need to take a look at. So you go to one of those like package.nixes or default.nixes, depending on where it is. There's usually a few things you got to do. You want to update the version of something, update the source reference, update a hash. It's pretty easy. There's different ways you can go about doing this in terms of like updating the hash. There's like tools that can help you with that. You can kind of like prefetch things. You could just do the whole tofu and see what shows up. But like basically the idea is like as you do an update, you're just trying to make sure that, hey, does this thing still work? So some things to take a look at is, hey, you have a commit message to say, hey, here's how I bumped the thing. All this is documented in the guidelines, but I just want to give you a little analogy of, or just a visual that like there's not that much to do. All right, cool. I bumped a version, minor version, and then a hash changes. It's pretty nice. If I have to keep doing this, though, that's a little bit annoying, so just be aware of there's also ways to make this automated, right? And then that way you have tooling that kind of will start to do this for you. So this is going to go into a place called pass-through update script. This is where like the Ryan TM automation is going to help out. And there's some links up here to kind of where to get started, how to take a look at that. But it's actually not that bad to do it manually. Again, if you want to start doing this every day over and over again, and we end up with thousands and thousands of PRs, you want to start to use that automation. All right, so cool. I did a small change because I care about it a lot. It's up there. But now I'm just waiting. What now?
Yeah, so it can happen that you open your first pull request somewhere, not necessarily on Nixpkgs, maybe any other open source project, and people just ignore it. And then 1 week later, you're like, hey, can we merge this? And then no one answers. It's easy to feel like, oh, they don't like me, they don't want to do anything with me, or I did something horribly wrong, and people even feel embarrassed to explain why or something. Be assured, most of the time it has nothing to do with you. People are busy as you are, right? And most of the time, if you have like 1,000 tasks in front of you, you will try to ignore as many as possible and only do the most burning ones. And open pull requests from strangers are never a high priority, right? So this is, please understand this, but also try to be like polite and at the same time persistent. Like you try to help people help you, right? So please explain, like, look, I need to get this in because of this and that. If there's anything wrong, please just tell me what to do and I will fix it. And the thing is that when you stay polite and at the same time persistent, and you express like your offer to help for helping you, then the people who ignore you feel embarrassed about ignoring you. And this is kind of a soft but also polite way to, drive people into helping you, because you are helping them essentially, right? So this is a different way to communicate. Try to be polite to people who ignore you, which might not feel like completely natural, but this typically works with a little bit of patience too. Also, you don't have to only like write one polite message every week until someone finally feels embarrassed enough to pick it up. Of course, that's not how it should work all the time. You can also go into the forums, into the chats and whatever. Together with a list of the maintainers of a package, you could just communicate with them directly. And typically people answer faster if you talk to them directly. I think that's similar to like WhatsApp groups when you ask in a friend circle like, hey, who wants to do something? No one answers. But if you talk to them directly, everyone answers immediately. You get the same effects in the open source community. But also when you are communicating with people, like if you ask a question in a forum, how to get this through or how to do this, you should aim towards not looking like, can you help me do my homework? Because this is something that people find annoying. And of course, there are many very helpful people out there who love to help you, but you need to reflect that you already tried hard, right? And then ideally explain what you tried already, how it looked like when it didn't work, and that you basically ran out of ideas or something, because that is something that people like to pick up and help. So it's all about how you ask for help, and your question should already reflect some effort, because people like to help other people who already invested some effort. So that's, in my experience, that generally works great. And yeah, the maintainers are nice people, just mind that they are busy. So I want to do reviews, as you said, right? Reviewing is already helpful. Do I have tools to help me? Because it's just walls of text, and is there anything that could be done like automatically?
Absolutely. Automation is helpful. Sometimes doing a whole bunch of repetitive work is toil. Let's remove some of that. So there's some really good tooling for this. The one I like to use is Nixpkgs review. It's great. Workflow is pretty easy. I just say, hey, Nixpkgs review PR. I throw a number in there, and things start happening. Things start building. It figures out what actually the change is, and it gets me started, which is great. Common things I tend to do with this is I say, hey, okay, I'm going to review the thing. I kind of poke around. If it looks pretty good, everything's been looked at, then I can post the result. Other people can share from seeing the fact that, okay, I took a look, I built it, and I kind of did the once-over that this thing is pretty good. Command line also lets me do things like approve or like show the comments and things that are in there. I can merge from there, so that's really helpful. You got to put in your GitHub token, but there's ways to do that, so that can be done. Highly recommend it. Use it. It's great. Some other things, if you're going to be doing a lot of work with packages and updating packages, like learn all the Nix commands, learn how to go evaluate certain things, go learn how to modify things. Those are good ways to kind of check out packages. Modules are sometimes a little bit harder because, like, well, I mean, you don't want to be constantly applying it to your own system and everything. So a good thing is to like try to build these things and test them. Hopefully, they come with VM tests, but you could also build VM tests. And then other thing I'd like to use is a NixOS container. That's a good way to kind of stand up a system with some sort of a service that you don't want to like be running anywhere else and take a look. Like, does this thing actually function as expected? Does it do the right things? But yeah, Nixpkgs review. It's a good way to get started. But like, what about pitfalls? What are some pitfalls we might have?
Right.
Yeah, what might I see?
So it could happen, and don't worry, this is not necessarily something that you would have to know in advance. If you open the pull request and it triggers like 1 million rebuilds. So, okay, that's bad because even if people like your pull request, it's hard to see if all the packages that depend on your package, which is the reason why there are so many rebuilds, will they still work? So although we have like many tests in the Nixpkgs repository, like integration tests with VMs and without and stuff like that, it's not like they are all always automatically executed because of the hardware resources that would consume. But the CI will see, okay, so there are like more than 500 or more than 5,000 rebuilds. It will look like on the screenshot here, and your pull request will be tagged by this. And that communicates that, okay, let's review the package normally, but we cannot merge as is because it will trigger so many rebuilds. What you can do then is, can still, like, it's relatively easy, simply move the pull request to not target the main branch, but the staging branch. That should be done with a little bit of discussion in advance. So you go to the matrix room staging in the NixOS space and ask people how to approach this. So I want to, for example, upgrade CMake, and all the packages depend on CMake, like nearly all of them, how to approach this. And then people who have more experience in that will help you. That's again, like, it depends how you ask, right? But then people will be really helpful. And generally the approach is that your pull request would then, when it's accepted, merge to the staging branch, which leads to the rebuilds being actually done. And then when there are problems occurring there, then it's nice to have not merged it to main, right? Because then all the main users will still experience a working branch. And when then that stuff works, it will at some point find its way into the main and the other branches. And it just means that we need more patience getting this stuff in. But it's a very good approach. It also helps you not to look like the one who broke stuff, right? So, what's this other stuff that I see in GitHub, Tom? I open a pull request and all the things pop up. Is this good or bad?
Well, if they're green, they're good. And if they're red, they're bad. That's usually a good common universal thing. Yeah, this is checking for things. It's checking for, is like the formatting right? It's going to check for whether things are evaluating. There's going to check, make sure all the conventions and idioms we're expecting to happen in Nixpkgs are there. So some ideas here, some things to use. Use NixFMT. It's being worked on, it's being improved, and it might even yell at you if you start changing the format of a file that's already been formatted. There's some links up here about like of Borg and like learning about how this like evaluator works, what it does, what the purpose is, how do I control it a little bit to even kind of tell me, hey, I made some fixes, go reevaluate, or like go build this thing. So that's a great piece of automation that we have. And also recently we're having the auto merge bot. This is the way that you can, even without having commit rights, if you're a maintainer for a package, you could still say, hey, I want to merge this thing because I've reviewed it as the maintainer. And then this thing kind of does the actual merging process for you. So like use this stuff. This is kind of the other things you'll see out there in the world. Okay, so this is happening. But like, what can I do? Like, how do I test this thing?
Right. So
what do I do?
Exactly. So if a test of a function is like a predicate function that says after we did some changes, does it still work in the ways that it ought to work, right? Maybe there are 1,000 use cases that somehow need to be protected because you don't want to be the one who broke someone's use case after updating the package. But I don't even know the people who use this. How could I anticipate what use cases I might be breaking, right? That's kind of the idea behind testing in general, right? So you just pile up all the tests that kind of protect all the past use cases that should still work. And how do we mix this with Nixpkgs? So the first solution is, of course, the check phase of a package build, right? We have the unpack phase, the patch phase, the configure phase, the build phase, the check phase, and then the install phase. The check phase is one of the few phases in Make derivation that is not enabled by default. I guess that is because so many projects don't have good tests, but hopefully yours does. And in the check phase, you would simply run the unit tests and whatever tests it has, all the per package tests, so to say. And if those tests fail, that means that your package doesn't build at all. So it cannot be merged if your package is basically red, right? So this is the best and most dominant way to test one package. Then there are other tests. Post-install too. So if you are testing the installed package, there's kind of just a different way to test this. In the Nixpkgs documentation, you will find more information about these two. Then how does your package work with other packages? You want to test not only your package but with others together, for example. Where do I put such tests? Maybe they already exist, but I want to connect them to my package so that if someone else changes this package, that my tests are executed too, so everyone can have their tests covered, right? There's this attribute passthrough.tests inside your package definition. And that is one attribute set where you can simply pile up all the tests that you want to have. And you can have version tests. When I execute the package with --version, does it actually execute or does it crash on that step already? Because that could always happen. If the unit test during the package build went green, but something is wrong with the binary in the end, then this is a simple test. And in packages.testers, there's a lot of these. You can also add NixOS integration tests there, or other derivations. You don't need to. Sometimes you can have a packages.run command test that simply does a few things with maybe example inputs, and then if that looks like you expected, then this is a good test already, right? Sometimes you want to test NixOS modules, like you mentioned earlier. You would need to build a full NixOS system and test if the module behaves correctly. And if your package is part of such a module, you essentially need that, right? So yesterday we had the workshop about NixOS integration tests. Unfortunately, it wasn't recorded or something. Hopefully we'll have some recording of this in the future again. But the NixOS integration test driver is a very powerful tool to simply spin up multiple VMs with certain configuration, let them play with each other, and then shut down the test if everything went well. Such a test can take below a minute, depending on the software you test. And if you have tests like this, push them into the passthrough.test sub-attribute set, then it does not only document to others, like what tests may be to run before they do the pull request, but also to the automatic CI, which will ensure that this is all running in green. Testing is still a complicated topic, but I hope that this is a good starting point for you to look at what are the existing tests of a package and which tests, where do I add tests to my packages. Okay, Tom, so I heard being a maintainer is cool. Why? What is the point of being that?
One, it's fun. And you get to kind of take a little ownership of the things that you're actually passionate and care about. So yeah, we talked about the merge bot. We talked about how to make this better. You get notifications, things like that. So it's a good idea. So use these things. Thanks to Lassulus and Mick, right? You can now also be a part of the merging process without having even normal commit rights. So it's fun and it's great. All right, so let's say I did merge this thing. What now? What do I do?
Oh, okay. Yeah, so the thing is, if you merge to main or master branch, then your package is generally available on the latest and greatest commit of Nixpkgs, right? But that doesn't necessarily mean that it's on one of the other branches, which are already cached by the NixOS cache. And so your changes need to be merged into the other branches too. And there are tools which we linked to here. PR trackers. A PR tracker works like this. You throw in your PR number and it tells you in which branch your change is already available, from which you know if it's already cached or not. Very easy to use.
Yeah.
So what if I make a mistake, Tom?
Don't worry about it. Everything's fixable.
Okay.
It's not going to be that bad. Everything can be figured out. We want to encourage people to try. That's the main idea. All right. What about once I've done this a whole bunch of times, now I want to start being more involved. What do I do? What's next?
Right. So maybe I became a maintainer of a few packages and so on. It would be annoying to like always ask other people to please merge stuff. Maybe some other people do pull requests that I review and I find them great, and I'm the maintainer of this package anyway, so it would be helpful to be able to merge too, right? And that would release the pressure on all the mergers because there are more of them, right? How do I get this commit bit? So there's this committers list for which you can nominate yourself, but you can also be nominated by others if you don't like to nominate yourself. Typically, they ask for a little bit of reasoning. Why should this person have the commit bit? Ideally, you already have a track record of effort that you demonstrated that helped the community. So people will feel like, okay, if this person has the commit bit, then this will help the community. Great, let's do this. So don't do this as the first thing. Do a little bit of contribution for some time and then ask for the commit bit in this nomination process, and then you will get it and will be able to merge stuff. Tom, how can I update packages over time?
There's automation for this. It's documented, but we're gonna go keep moving here. And yeah, so that's pretty much the idea. Go look at the documentation and run through that. And then how much time do we have?
More or less 0.
More or less 0.
Well, I mean-
All right. Well, we were going to do some sort of a live review, but how about this? If people have any reviews and things while we're here at NixCon, come talk to one of us, and we'll either like help you through it or guide you through it or see if we could get unblocked and try to cut down on that count of open PRs. How about that?
Okay, I'm really sorry. I don't think we really have time for questions. I hope that's okay.
Yep,
but of course, I bet these folks are okay with questions during the convention, right?
Absolutely.
Of course.
Great. Let's thank the speaker. Well, didn't we just thank you? I don't know.
Thank you.
Okay, everybody, the next talk is not going to be recorded or streamed, so to all the people in the restreams, if you want to listen to this talk, you got to come to the auditorium. They don't? Okay, I'm going to repeat what I said before because the stream didn't hear it. The next talk is not going to be recorded. So, therefore, the restream won't be able to see this. So, for everyone who's watching the restream, please come to the auditorium if you want to listen to the next talk. Okay, our next talk is about Nix as a static site generator. Let's welcome Patryk.
Hi, yeah, so first a couple of things about me. I'm Patryk Wychowaniec, the surname is difficult, don't bother with it. I've got a blog at pwi.io, and I'm mostly a Rust programmer, but I've been into Nix for like 4 years now, and I like to experiment a bit. And my recent experiment is about using Nix to actually generate my blog. And I guess the easiest way you could, create a blog is, upload WordPress or, whatever's hype right now. But I had this different idea that instead of using Nix the easy way, in which case you would create a derivation which just, copies, like you would use Hugo or whatever else is popular right now. You would use Nix to just copy the files, run Hugo build or whatever. It produces some HTML files as the output, and then you copy them out. So I think that's the easiest way. And I wanted to experiment a bit, and I wanted to show you, how it turned out, some pros, some cons. And basically, the idea is that if we have some basic Nix derivation, like Nix derivation, the output of it can be like, usually it's like, directory with like binaries and whatnot, but it can be actually just a tree of arbitrary files. And before I go into the actual source code of my blog, I want to give you like high-level idea of what we'll be dealing with, and then I'll just jump you to what I produced over the last 2 years. And basically the idea is that you need to know just 2 functions from Nixpkgs. One is called write text. It takes 2 arguments, and we can imagine it like, we can say that we pretend it generates a text file, HTML file, and we call Nix build. It produces some derivation that is basically just this text file. And on its own, like we got just this result. It's not actually a site you can open. I mean, I guess you could sort of open it, but it's in the web browser, but it's called result, not index.html. And you have just one file instead of a directory tree. And the second important function you get to use is link farm, which basically allows you to generate a tree out of some, directory out of a couple of derivations such as those. And we can imagine that we would do something like this. So we have some index file, index page. And now we want to have, as a result, not this single file, but like a full directory. And it should be something like this. Now, if we rerun nix build, it works. As a result, we get now a directory. And the basic idea is that you chain those two, so write text and link farm, to generate, a whole, the whole subsite. So, for instance, we can imagine that we have some post. We have some post. I don't know, let's call it just post A, post B. And then to generate a directory of posts, you just call this link farm. Oh, it's supposed to be path. And now to link it back to the final output, we might imagine we have something like this, path, posts. And this should generate basically the whole tree. And this is the gist of it. So, well, obviously the site doesn't do much. You don't have links and so on, because it's not like for our workshop on how to create sites in Nix. I wanted to give you a highlight idea of those two building blocks that you can then use to actually make a fully fledged website. And what we are aiming towards is like a normal website. And what Nix allows you to do, well, allows me to do, but maybe you'll pick up the idea and you'll like it. What allows you to do is that I have my website in here. And the basic idea is that I have two main directories, one with content, which is like pure metadata about my stuff. So like I gave some talks and I have like metadata of the talks I've given, like title, tags, whatever, without any like CSS styling, without any HTML generation, like rendering facilities. And the same with posts. I've got some posts and they just contain some metadata. And then I have the whole framework that takes stuff from this directory, all of the posts, and basically generates stuff like the whole website using this, more or less, this pattern. So for instance, when we have, let's say, well, first of all, let me run it locally. So we can perform some actual changes live. Address is already in use. One sec, probably haven't run in somewhere, yeah. Let's start. Right, yeah. So the basic idea is that we can, having this whole derivation that builds this whole website, which is just, just a directory, we can actually very easily sort of self-host it locally using Python. So I don't actually write Python that much, but apparently it contains like self-hosted simple HTTP server. And the most important stuff is that it allows you to sort of run the server locally when you point it to a directory. And in this case, I have this whole derivation that builds this whole tree of my website, all of the index HTMLs and whatnot. And if you point it to this directory, you can then use it to run it locally. The same you can do with Nginx or Caddy or what have you. But Python is nice for local development. And we can run it. We can run the whole site locally. And now we can make some changes. Like I don't know. We have like we have this sort of post. I can change its title. And now one of the drawbacks is that it doesn't have live reloading. So if you're like used to Hugo or whatever, they sort of reload it automatically. In this case, we have to do either Nix build to force Nix to rebuild the site. In my case, Nix rerun, and we get it built. And well, as I said, the gist is that we have all of the content stored in here. And then framework takes care of generating, for instance, this tags page. So for instance, what it does is that, yes, it follows this link farm pattern. So we have a directory called tags. And then we use basic Nix functions such as just map, such as just built-in array mapping to actually go through all of the tags. And then do something with them. In this case, for each tag, we first generate the index site, which is basically just Nix used as a templating engine. So if we would look, this would be this site. So we have some UL that goes through all of the tags and basically calls some functions that render actually the tag. So like this single piece of data. Then what this Nix expression generates is that we have those tags, corresponds to this one, and then basically using the built-in map functionality and then converting back to string, we go through all of them and generate some pages basically on the fly, because within the content directory, I do not have actually any page that lists all of the tags. So some sort of data is implied from the content. And this allows you to, so using Nix as a templating engine is both great and sort of a curse, because like it's great in the sense that it's mostly readable. Like we generate some link with some string variable. Some pieces take a bit more to understand. But eventually, I think I'm pretty satisfied with the setup. And basically, I learned Nix using, building Nix this side, because, expressions like this, they kind of look scary, but actually, for instance, what this function does is that it takes, in this case, types, so let's like post or a tag, because both can have tags, and then, finds all of the posts and tags, and then just counts them. So for instance, this function counts, returns all of the posts that contain this specific tag, and this corresponds to, I don't know, this part of the site. And after time, it actually becomes very simple, and I'm rather satisfied with the setup. I wanted to go through, highlight some pros and cons I have written down. And right now, no, one more thing, because before I go straight to pros and cons, is that a Nix superpower, which I use in here, is that you can actually extend. You can use any arbitrary code, well, any arbitrary in quotes, as a Nix function. For instance, when I write my posts, I write them actually in sort of HTML-ish language. So if we open like one of those posts, whatever. This is mostly HTML, but this is actually fake HTML, because I do have invented one, well, now that I think about it, a couple of custom tags. Like I wanted this whole site to be generated on the fly without any JS dependencies during the runtime. And I do like to have like snippets of code that I wanted to have highlighted. So what I've done is that I invented a custom HTML tag that uses sort of HTML-ish syntax. So it uses a comment to actually have the proper, so that I don't have to worry about the escapes, but this is not a comment, this is part of the body of the tag. And as a part of this Nix building process, I pass all of this body HTML file through a Rust application that I conveniently called render post. And basically, there's this application that takes my fake HTML-ish code and outputs actual HTML, mostly by calling pigmentize, which allows me to automatically add some formatting and whatnot, does some minor clarity checks. And there's a very cool pattern that allows you to call this Rust code as a Nix function. And basically the idea is that there's this command, well, maybe I'll write it in a bit easier way. There's this command in Nixpkgs called run command. And it allows you to run arbitrary, well, more or less, as before, more or less arbitrary bash script. Yeah, let's say bash, but I'm not sure, but some shell script as a part of the Nix build process, as long as you generate the out file. And the idea is that you can do something like this. And the trick is that if you now called, is it built-in? Yeah, it's built-in read file on this result, you get this output as a Nix string. So in this case, if we evaluated this, and the result of this expression is a Nix string containing, well, the value hello. And because you can actually call any executable in here, you can as well just write your own Python script, Rust application, Go, whatever, that allows you to take some arguments, process them, standard I/O stuff, and produce some output. And in my case, this boils down to piping the original fake HTML and saving the actual proper HTML into output. And then I read it back as a Nix string so that I can, pass it later to do, layout, whatever. And I gotta say, this counts as an import from derivation, I think, which is a fancy word for saying that if you wanted to do stuff like that on actual Nix packages, this wouldn't fly, I think. But if you have, if you're doing stuff for yourself or you don't care about it, that's a great thing to have in your tool set. And yeah, before we jump into Q&A, I wanted to give some minor highlights or minor thoughts as a pros and cons. And yeah, basically I'm satisfied with the setup because it's plug and play. So because I can just run Nix build, well, in my case I'm using Flakes, so Nix space build without the dash. It produces this result file, well, not AL, just result that contains some posts, files, well, everything. It integrates well with Sass because, for instance, I don't like writing CSS by hand. So as a part of the build process, I just called a Nix derivation that converts Sass into CSS, and then I get basic CSS as the output. And to show you how well it integrates with, let's say, deployment, it's basically one line of code to actually have it deployed. And, well, one is maybe too much, but to show you the gist is that I'm using Nix Flakes, and I've got this website posted on GitHub. So I just pull it into my Flake Nix, and then in order for Nginx to actually host this whole site, because the output of this derivation is just a directory, I can tell Nginx to, this is the root of the site, and that's it. This is everything you need to actually deploy this. And it's rather convenient. The rest of the rules are basically some redirections from the past, but basically this boils down to this, and you've got the site deployed as long as you generate directory tree. And yeah, as I said, to wrap up with some specific pros and cons, yeah. Plug and play ability. If the site builds, it should mostly work in the sense that I showed you that I'm using this custom HTML-like format. If I make a typo in there, forget to close the tag, whatever, because the entire site is built when you call Nix build, it's sort of like all of the posts are also validated there. And if there's some unclosed tag or whatever, I see it immediately, as compared to having some lazy rendering or whatever on demand. Yeah, as I said, I'm using Sass in my case and Pigmentize to have syntax highlighting, but you can use everything else. Like, oh well, I'm mentioning custom fonts in here because just for fun, I'm also using iosfk, this font to format the code blocks. And it's very easy to, well, normally you would have to upload it to your assets directory, whatever, but with Nix, there's like a single line to pull it to CSS, and you've got it. So, this whole approach very neatly integrates with everything Nixpkgs have to offer. And yeah, you can use this run command trick to delegate all of the stuff that you wouldn't want to write in Nix, like I wouldn't probably want to write in fake HTML parser in Nix, so I've done it in Rust. And you can delegate all of the stuff that you don't feel comfortable writing in Nix to different languages, and it works well. There are some cons. So as I said, there's no out-of-box instant reloading. It is sort of my fault because, as I said to you, as I've shown you, I've used this custom Python script that serves as a HTTP server locally. It could be extended to support reloading, but it's not out of the box. Because Nix has no explicit type system, sometimes you get very cryptic error messages. And this becomes painful, for instance, when you have the metadata of the post. Like some stuff is sort of typed. I mean, most of the stuff is typed, but implicitly. Like dates are specified in this YMD format. And if I made a typo, it wouldn't be pointed out towards this file. It would be some random code elsewhere that's failing because it tries to access a field that's not there. So this can be problematic. And there's no built-in testing framework as compared to, well, Rust, I guess, where you can just run cargo test and you've got the tests in here. With Nix, it's a bit more difficult, and it would come handy because, for instance, the dates in here are specified in this, well, random format, but they are pretty printed. And I've got small function that allows you to pretty print dates. And it's not tested. I mean, I see it works. Obviously, it works, but it would be nice to have it tested. But there's no built-in facilities to do that, so it's sort of finger-crossed development. And yeah. As I said, there are some cons, but I've been doing it, improving my site over the past 2 years, and I'm quite satisfied with the setup. If you would like to try it locally, basically you would have to go ahead and clone. This repository in GitHub, and basically most of my custom stuff is in this directory. If you change it, you would get your own site, at least to play with, to get bootstrapped, and you can write your own stuff. Oh, shut down the server, never mind. Which I highly recommend, because even though some parts of the Nix can be difficult to understand at first, it might look like a gibberish if you're not used to it. But I think after like a week or two, it actually made sense, and most of the stuff clicked. So yeah, I can recommend that. And yeah, I guess now would be time to move to Q&A if we have time, right? Yeah. Cool. Yeah. Thanks.
First of all, thanks for the talk. I love cursed software. I just have one question. How much time would you think you've spent on this?
Oh, way too much. But it sort of starts easily because, for instance, now I have both posts and talks and some tags on my site, but it started very easily as just basically this list of posts. And back then it was easy. Right now, if I had to write it from scratch, it would take me probably like a week. Well, maybe 2 days to get started, but then more time to polish. But as I said, it started as an experiment, and with that, having that in mind, I'm satisfied. I wouldn't probably recommend it to have it professionally. Like, it's a bit difficult to expand on, especially because and still not so many people are used to Nix. But as an experiment, I'm happy with it. It took, like I said, a couple of days, and a couple of days every now and then to improve stuff. But I gotta say, just to cross the T's and dot the I's, that I'm more happy with this setup than I was with Hugo, because I started with a typical out-of-the-box static site solution like Hugo or something else. There's like tons of them nowadays. And I had the issue that I like to extend stuff to mold it to my will. And with Hugo, I had this problem that everything felt like it was curated for you. Like you have, because Hugo supports many languages, multilinguality, whatever, you sort of had to build your stuff around this framework. And with this, you can actually write stuff any way you want. You just write Nix expression to convert it to whatever you need at the output.
Thank you.
Yeah, also thanks for the talk. Do you write everything in raw HTML, or do you actually have something like a markdown parser for the content?
Oh, you mean like some linter, or?
No, more like, so you, like, as you show here, you write the HTML raw in Nix, but I was thinking, like, do you have some files that you just pull in and then render for the website, and then the website is your custom framework for it, or do you actually just write everything in Nix?
Oh, so as far as I understand, I actually write like the metadata in Nix, but for the actual content, I actually just use read file and keep it elsewhere.
Ah, okay, that was the parser. Thank you.
Yeah. And yeah, as I said, basically this takes this file, and then later some part of the component, actually some part of the framework, passes it through this Rust application that converts the stuff. But this is more or less what you get at the output minus the listing tags or whatever else.
Have you tried using NixOS modules to add types to all of this for metadata and maybe data? For this particular project, not, because as the output, I wanted to have this single directory of symlinks or whatever to the actual content. So I think NixOS modules don't fit really well within this project, but I do have different project, some game I wrote that actually uses NixOS modules, so that when I deploy it on my servers, I just pull this sort of my game, and then in order to deploy it, I just have this custom module that says, my game name enable true. And this also works really well. I can recommend it because also within this repository of that game, I also when I do deployment, or before the deployment, I run a temporary NixOS container on my laptop to sort of validate that it still works, to test it locally. And then when I just update the version within Flake in my actual infrastructure project, I know it will work. So yeah, for this project, no, but for different ones, I do use NixOS modules. You can actually have any package as an output for your module set.
Could you repeat?
You can have any package as an output for your module set, so that it doesn't have to be NixOS system or something.
Ah, right. In the sense that I could have a module that you write enable, and this creates you like an Nginx service with this already point in.
No, like I guess we'll take it offline.
Yeah, no problem.
I just wanted to say thank you for this. This is awesome, and I can finally have something replace my Next.js site.
Please do.
All right. We're good?
Yeah, we're good.
Let's thank our speaker again. By the way, I think we're planning some kind of more or less spontaneous group photo just for anyone and everyone who wants to be in it. I'm still not sure how we're gonna manage to do it. It might be more or less during the break in this room, I think, but I know you also want to eat during the break, so I'll try to find out more details about it, but it's probably gonna be pretty spontaneous anyway. Also, again, lightning talks. If you want to do a lightning talk, send us your slides. 2024 CFP at NixCon.org. All right, our next talk is going to be about Nix and Bazel. Give it up for Artur and Aleksander.
All right. Oh, yeah, that's the good screen. I'm Aleksander. This is Artur. Maybe a bit of introduction. Like, we have been good corporate drones for the past like 6 or 7 years, and we have been using Nix for the time. But because of the corporateness, like, we weren't really able to contribute. But finally, we decided like maybe we can at least share some experiences or grievances. We are Poles. We like to complain. And today, I hope we'll be complaining in Bazel and Nix. And maybe you will see that it isn't as easy as people like to tell you. So maybe, Artur, if you want to jump in, introduce yourself a little.
Yeah, I mean, I can tell only the same as you did. I mean, we've been working with Bazel and Nix for like past 6 years in corporate setting, and then like I think like a year or two prior to that. Yeah. So yeah. For the long time, we've been thinking that smashing two reproducible hermetic systems will give us only benefits, but it's not always the case.
Yeah, you will see. Like, we were like Matt and Pat, breaking everything. So I will be doing a bit of talking right now, and then we'll jump into live demo. No guarantees it will work, so it's gonna be fun. So this is something you might know. There is a page now, Nix plus Bazel, and it tells all the great benefits of using those two things together. And there are some postulates there, like why would you like to do it? Like, why would you use that? So very briefly, I will run through this. If you don't know Bazel or Nix on Nix conference, you will get to know that. One issue of Bazel, it's not really hermetic. Like, they make big deal of hermeticity, but really they have a lot of baked-in assumptions. They like to go into a host operating system, the execution operating system. They like to have their bash. They make assumptions about running on Ubuntu. That's the whole thing like they are doing. So they're not really hermetic. They're fast and they're incremental, but not hermetic. If you want them to be more hermetic, you need to do a lot of groundwork. You need to make sure that everything is described well in the Bazel terms, and that's laborious. And in Nix, you get that for free. It's hermetic. You can just yank it from the store. So yeah, this is the reason why we would like to connect them. But on the other hand, Nix is really not that, I would say, incremental. So the broad picture here is take the fastness of Bazel and take the hermeticity of Nix, and then you're living in this perfect world. So I don't know if you like obsoleted memes. I couldn't help myself. This will be an obsolete meme. I hope you know where it is going. So Bazel is just this like single tool, one binary to rule them all. It's fast, incremental, and I'm using the scalable word non-sarcastically because it really scales. Like, if you have something that literally cannot be run on a developer machine, or the developer machine would be prohibitively expensive, then you move to Bazel because it can run on big farms with hundreds of CPUs. And Nix is also this beautiful horse, right? It's hermetic, reproducible. It has this vibrant community. And if there is something that is difficult to make hermetic, it's probably already there, right? So this is what you get if you connect those two. Like, it's not even one half that is nice. And there is some tippet there for a reason, because the idea here is that running those two things together is hard. And I will jump forward a bit. It's not that you have the sum of pains, it's even a bigger pain, because Nix is opinionated, Bazel is opinionated. And those opinions, they do not match. So if you want them to talk together, you do a lot of bashing open doors. Sometimes you open even walls. It's difficult. So what we want to show you today, that you really need to know what you are doing if you're moving into this direction. And to showcase this, like, we were not even trying. Like, it's a hello world application in C++.
And C.
And NC. And yeah, we will try to compile it. And you will see that, if you are not familiar with the tooling, you can spend like a week, 2 weeks trying to run that, and only then it will work. And the biggest reason for this is, like, we have one opinion that we are making here is, if you are using Bazel, you really want remote build execution. Otherwise, like, just use Nix. Like, that's opinion we have. And this is the only caveat we will give. So demo time, it's gonna be hopefully functional. And I will talk less now. Thank you. Yeah, and keep in mind that the thing that we are going to show is just one of multiple approaches. Like there are different ways to address the same problem. You can run Bazel in Nix. You can run Nix in Bazel. You can write them like side by side. And our idea is to show how supposedly the simplest solution will leave us with most problems, which we'll need to fix. So the gains are somehow nullified.
To increase the font size, unfortunately, you need to open this. Okay.
Well, that's your laptop, man.
Okay, it's gonna be. I already tried to. No. Oh, okay, because we are here. Okay, so. Just a second. We'll fix this. Live demo, great. Typing config when you are stressed, highly recommended. And someone here, there is font size, right? So what are we thinking? 16, 18? 18, here we go. Oh, yeah, because I was doing that. That's a very good point, because great, that is going smoothly. And we are wasting time, but let's see.
I think that's the only conference when everyone's okay with that.
Yeah. Because, of course, this is running NixOS, and everything is declarative, right? Right, OK, so this is no longer a symlink, I hope. So if now this... Oh, I see what was the issue. So... yeah, I'm not taking any prisoners here. So now if we go to the font... Pretty please? Yes, awesome.
Nice.
Thank you, thank you. 6 years of using Nix, and yeah, that's what you get. True. And the code for the slides and for this demo, it will be all available.
Yep. Okay. So we'll, okay. So we'll start at the very beginning and just switch between different commits and see what happens. Between.
While you are switching, I will just say that the way this is, please.
Yeah.
The way this is structured is that we have stage 0 commit, so it is the most dump naive approach, and then we have commits that build on the top of that. So we're slowly moving toward this like blessed sandwich of Nix, Bazel, Nix, but yeah.
Yeah, so we have like a standard setup for Bazel plus Nix sandwich. So like the Nix definitions, then a basic Bazel workspace and a single build file, and the actual thing that we'll be compiling. Yeah, so that's it.
Told you, exciting.
Yeah. And let's just take a look what's in there. So we have like a single Bazel RC file, a simple definition. Yeah, there's nothing special about that. Maybe apart from this thingy. So that's our shell definition. So take a notice that we are running in this thing in a shell that doesn't include the standard GCC, and
it has nothing.
Yeah, it has just Bazel and Nix.
The reason why we are using now GCC because we are mean and we know what Bazel does. So this should work, right? We have Bazel from the Nix packages. Everything is hermetic. Bazel is hermetic. It's only a GCC.
Yeah, but it's not working. So I think it should be visible somewhere in here that it fails on auto configuration step. So by default, Bazel tries to auto configure its own CC toolchain,
and takes whatever's available in path, and then tries to, well, configure that as its own toolchain. But obviously, this thing might differ between machines. So yeah, and at this point, it's not even working in the local setup on the host machine.
But we have Nix, so let's add GCC to the shell. It surely will help.
So now let's just jump one commit back and see what's in there. Yeah, so we are just adding GCC and running the same thing.
Yeah.
Yep. Woohoo! Now it works.
Great. So we have that local thing, but we told you we are opinionated. Bazel locally is nonsensical. Let's run it remotely.
Now it's 4. See what's in there. So we'll be running the same build, but on a remote build execution service. We have some additional definitions that are required to set up a remote worker.
One point of notice, again, we are min, and this is going to be executed on a nearly empty container. It's not even distroless.
Yeah, it just contains
bin-ash, and that's it.
Yeah.
You don't get anything else, because Bazel and Nix are hermetic, right? They don't need anything.
So yeah, let's give it a spin.
And you may already know what the issue is,
yeah.
right?
And that's like the very first issue that happens for someone that tries to mix these things together, like that is Nix and Bazel, and then tries to run something remotely. So immediately gets an error saying that this path does not exist. Because Bazel sends that information to remote worker, and remote worker well, assumes that the path will be there. So at this point, we can either provide that path to the remote worker, or, well, try something else.
And just FYI, this is what was shown on BazelCon this year by, I think, Twix models, right? They are literally mounting Nix store to the executor or workers and doing some pre-work to make sure that they are there.
Yeah, because even though we can mix these two build systems together, they are not so aware one of another.
But let's continue. Like, we are still mean people. So in this mean spiritness, let's bash up Bazel a little. Because I believe now we will take what they call hermetic toolchain. Let's see how it fares.
So we are dropping Nix for a moment and just taking some well, pre-made GCC toolchain, which is supposedly hermetic. So we still use the same remote worker that contains nothing but just ash shell, and then try to use something that is advertised as hermetic.
So this time it will work for sure. Like, it has got all the guarantees. We have a container that doesn't skew it in any way because it's empty. We have hermetic toolchain, and Bazel will just do the right thing. No need for Nix, right?
We'll see about that.
And we'll see about that
in a moment.
In a moment. Like, so the reason why we will have to wait like 30 seconds or something is because it is extracting. Like, the hermetic toolchain is big, it is archived, and there was nothing really that we can do. So
yeah, and it comes in two parts. So the one is the cross compiler, the GCC, and the second part is sysroot for the target platform.
And this is good to know. Like, to me, it wasn't immediately obvious. Like, when you are cross compiling or you have an SDK, you are supposed to have like two places you use, like your exec and your target. Okay, and it is starting fetching of the sysroot. So I would suspect it should work. Like, why would anyone lie about things being hermetic?
And it's nothing fancy. It's like native to the runner. So we are not even cross-compiling at this moment.
Yeah. If only we recorded it beforehand, like, we could speed it up. But yeah, we are pain piggies for live demos, I guess. Almost there.
Like what we need right now is network outage. This will teach us the lesson. This network is always stable. Okay, and now we are compiling. Yeah, it seems to, oh, wait.
Yeah, and now we run into somewhat similar error, but this time around we are very sure that we provided the runner with all the binaries needed.
So we have this weird no such file or directory.
And this could mean
anything.
Anything.
It was just trying to load something. You don't know what, but it was not there.
Or it could possibly use some different shell.
Yeah, but as Artur was saying, like this time, like the first thing you are hitting is they are assuming bash is there. So there is like this prevalent assumption, like you are using Ubuntu. So now we fixed that a little.
Okay. Let's see what's in there. So now, instead of using just plain ash, we substitute that with a different variant of the image that contains glibc and deep STC++.
Because the hermetic toolchain requires glibc, obviously. Like there is no way this could ever backfire.
Yeah, and also we had to patch the wrapper that runs the GCC. So that is POSIX compliant. So in our case, that essentially means that we are switching from bash to something that we know that will be compatible with our runner.
Okay, let's show the guys how it will not work.
Well, will it?
Oh, let's see. And there is one more thing that we promise. At the end, there is Nix, and the Nix is working. But as you see, it's hello world, and we are here like 15 minutes in.
We manage.
No,
I mean, it's fast.
Yes.
Correct.
It's very fast. So this time we will be waiting a little more. And one thing you have to really consider right now is when you're adding these Nixpkgs to your like mix, it's not only fighting, because here we are only considered with GCC. But you have to remember that Bazel has a lot of assumptions about, oh, when I'm running tests, I will use this shell. Or maybe the architecture is the same. Or maybe I will load some LD flags from the environment. And there are so many foot guns, especially when you're using Bazel that is coming from the Nixpkgs. Bazel coming from Nixpkgs takes all of the assumptions of Bazel and make them crazy. Like in the remote build execution, I highly do not recommend using it. You are better off using it with the usual Bazel, but to use usual Bazel on NixOS is also not that easy, and you have to provide it like the...
Oh, you need to patch the binary on the fly.
There is much of work you have to do to make them talk to each other.
So you either need to unpatch Bazel, or you need to patch the binary that gets you like vanilla Bazel.
Oh, and I was way too negative. You see, it is working. It only takes us completely rewrite of the hermetic wrapper, and we only had to make it POSIX compliant, and yeah, off you go.
And there's hardly any benefit of using Nix at this point.
Yep.
So let's just switch back and see whether we'll be able to implement the same thing, but using Nix. So now we'll try to use something that comes from rules Nixpkgs, and that's a very nice rule set, which in this specific case allows us to set up like equivalent of this hermetic toolchain, without going through the hoops of patching it and like switching its wrappers and what's not. So there are some changes to Bazel RC, but I don't think we have enough time to go over that. So the important bit will be at the bottom, I believe, in here. Okay. So now you see that we are ditching the previous implementation. I mean previous toolchain, and replace the rule set with rules Nixpkgs. And then somewhat at the bottom, we use this repository rule that takes care of registering a hermetic toolchain using GCC from Nixpkgs.
So we did it by the book. It will work. But the benefits are nice, because we no longer have to do some crazy-ass monkey patching.
Yeah. we are just taking it from Nix, wrapping it in Bazel definitions. Thanks to rules in Nixpkgs, you save time, loads of time.
Okay, but it succeeded partially. So very first run that happens locally passes without any issues because, well, the Nix store is available at the machine that we use for the build. But when we switch to remote execution, we are back to square one with the familiar error saying that the store path does not exist on the remote worker.
So there's one more thing that we need to do, and again, it's manual labor. And I will just remind you that this is a simple GCC toolchain, and it's only one. Imagine you are doing, I don't know, 10 cross compilers.
I think we are at the head. Okay, so now let me just switch to the very bottom. So now, instead of compiling C++ code, we'll just stick with C because that's a bit easier.
We are cheating.
We are cheating, yeah. And the reason is that we'll be using, instead of glibc, we'll use muscle C, which comes only with libc. With libc. And instead of using this really nice repository rule, we'll just invoke a bunch of Nixpkgs package rules, which essentially expose some specific packages from rules Nixpkgs as Bazel repositories, from which we can extract individual files. So think of it as like reaching out to Nix store for some specific files and then just collecting them. And here we specifically use static GCC and muscle for the equivalent of sysroot, and muscle dev for headers.
So let's see how the gentleman went fair here.
Oh,
Q. Okay. Right. So
now if we run the same thing.
Yeah, and just to narrate it over it, like if you know a bit of Bazel, you know how cursed it is. What we wrote there, you're essentially writing definitions for the definitions of the definitions.
Oh wait, but that's just part of it.
Yep. And now finally.
Yeah, so we finally managed to build the same thing locally and remotely by combining Nix and Bazel. But the reason why it works is because we are specifically using packages that are statically compiled, which means that the amount of transitive dependencies coming from Nix is vastly reduced. So we are fairly sure that whatever's needed on the remote runner is in our control. And then instead of writing a complex toolchain rule and build rule, what we did is we just went with a most generic rule and re-implemented like the simplest toolchain possible. So as you can see in here, whatever is prepended by add refers to these external packages. So we just collect them, mash them together into execroot. That is like the sandbox for Bazel, and yeah, provide a simple command line. So that is one way to approach that problem. And for the second, I think we'll need to wait like 3 hours.
Yeah, we will be mentioning something more pleasant on the Nix fuse with Nix, something that helps with that, but it's also just like a workaround, really. And I think we exhausted the space of examples.
Yeah.
One thing to notice is if you ever want to run shell scripts, the pain is twofold. Like it increases. Like it's not easy to wrap it and do the Nix. A lot of manual label also.
So it's much better to think of these two build systems as something that complements as a complementary things rather than something that should be mixed together like deeply.
Yep.
Because it's not a seamless experience at this point.
Yep. So that's it, guys.
Yeah.
Hi, thank you for the talk. You showed that it's repeatable now, but is it also reproducible? Like, is the binary exactly the same on both machines?
We can
also
try,
on more complex cases? Also in more complex cases?
Well, I wouldn't try more complex cases with this thing. I mean, like once again, Bazel perceives Nix as something that is impure, even though the other system is considered pure and yields pure outputs. For Bazel sees only the last part. So it's, for the most part, it's completely unaware of whatever transitive dependencies are provided by Nix, and that causes problem not only in the build time but also in the runtime. So what we haven't really showed is that the binaries that are built using toolchains coming from Nix have the different run paths baked in, which makes them a little bit less portable. So you need to take care of like collecting all these transitive dependencies on your own and then shipping them together with the binary, because Bazel cannot really do that on its own. I mean, there are ways to do that, but it's much safer to assume that Bazel is unaware of transitive dependencies.
So nearly. The answer is nearly, unfortunately.
Thank you.
We got some time for a few more questions.
Could you use Nix only to build runner images that you use as remote runners and then run Bazel after that?
Yes, that is one of the approaches. I think it's the link.
Rules LL from native link.
Yes.
They have the really nice implementation of something that they refer to as local remote, if I recall correctly. So what it does is essentially takes a snapshot of the environment, or in our case that was this shell, and yields a container image that then can be uploaded and used as a runner, which sort of provides the same set of paths, store paths, as what is expected on the host machine. But then one has to keep in mind that whenever there's a change in anything Nix related, it has to be redeployed in the form of a runner image. So it's not, that's not a seamless experience.
Like you will pay the price in the operations of the node that are running those containers.
Yeah.
Thanks.
Hi. Thanks
Hello.
for the talk. I'm curious, how do you make this system scale? Because I saw a list of all the paths of GCC that you need to transfer to a remote machine, and you need to provide this by hand, so you have to list it manually, right? If you have more dependencies, do you have to list those too?
Yeah, it becomes quite a challenge, and fortunately, this problem seems to be like got quite some traction recently. So, for example, Guillaume did a really great presentation on BazelCon on how to merge these two systems together in a seamless way that will also scale horizontally.
Like the way I see, there are two approaches to making it scalable. One is you treat those as two separate systems, and you make sure that the Nix path that is available locally will be available on the runners by whatever means. Or the other way is, and it's much harder, and I still don't know if it's that possible. I am still struggling to get it off ground. But you can try to move Nix to Bazel, like to the execution phase, and if you succeed in moving them, then it is the native citizen of the Bazel, and you no longer have to switch paths. But it is, to me, it will be difficult because Nix is not really the Nix store cannot be relocated easily. At least this is my understanding. Like I think the check that prevents, for example, symlinks is still there. Like the paths are canonized, and I think the GCC also does some real pathing. I might be wrong though.
Did you consider basically creating some kind of Franken toolchain that actually calls into Nix when Bazel tries to invoke GCC?
yes, but then you are in this in the world when you are starting when you start to write definitions you start writing definitions for in Starlark for Nixstore, and this is like I don't think it's scalable. Even if you automate it around, like I don't see it getting off the ground at scale.
Thank you.
No worries.
Do we have more questions?
It's GCC, there won't be many.
All right, I think we're good.
Yeah.
Okay, let's do another round of applause for our speakers. So now is the lunch break. After the lunch break, I should say during the lunch break, we're going to do a big group photo in the auditorium here. Try to be here at 12:50 because our next speaker already starts at 12:55. On? Let's go.
All right, guys, sit down. This is going to be exciting. This is my excited voice. Come on, sit down. Tell your friends, tell your moms. We're doing a group photo.
Also, I sent out a message about people having nice cameras. If you want to flex your whatever Sony Alpha, what are they called? Now's your opportunity to shine.
We have more seats in the front. Come on, come on.
Like
this picture has to make sure that we look like we're having fun.
Do we have? What's our fallback? iPhone?
Yeah, I mean, I can use my phone.
Is your phone good?
We have like 5 cameras here.
Is it good? Is it good? Wide angle enough? Yeah, then you'll like from the top. But who's gonna? Should we ask staff maybe?
Yeah. Who can take a photo? You want me?
I should have brought my camera. Fuck.
Yeah, you go. Maybe go grab one of the staff so that we're all in it. Here, give me the mic. Domen, are you getting in the talk? You're getting in the picture? Put the mic on and just start the talk while you're going through the crowd. Be like Tony Robbins. You all look great. Yeah, there's still seats. I still have like 2 seats in front to make it look like we're interested in this next talk. So if anybody wants to come in and just like sit right there next to Domen. I have also a seat over here. Yeah, if you have a seat next to you, raise your hand. Oh Lord, that's a lot of seats. Thank you. Can you do? We're doing a practice run, so don't waste your smiles.
I think you can also, like, this is 3, 2, 1, go. I think you can also just reload them, right? You can just rapid fire.
All right.
Wait, where do I go? Where do we go?
We're gonna lay down in the middle.
No, I mean, come on. We can sit down somewhere. Lay down like the goalie.
We're gonna come over here, and I'll sit over there.
Yeah.
All right. So first picture is like usually we do a very serious one because we're listening to Domen's talk because it's starting in 3 minutes. So we'll do that.
He can wait a bit. I mean, it's fine. But also, who here knows about Carlos Matos? Yeah, okay, so you don't know. So I'm gonna say what's up? And then we say NixOS! Alright? The higher the cringe factor, the better.
Let's go.
Alright, okay. Hey. What's up? NixOS!
All right, now one like we're having fun. Okay,
What?
Maximum fun. This is the picture we're gonna post and tell everybody that they sucked for not coming, except for those that couldn't come for medical reasons. So, maximum fun. I don't know. Do whatever you do when you're having fun, as long as it's appropriate to do in a room. All right, thank you. Oh wait, there's a different angle. This is for Instagram.
A different angle. Okay, let's go. What's up, NixOS? Woo!
All right, thank you guys. This is awesome. Everyone can leave now. Domen, you can go on stage. Thank you.
Perfect. It was good.
We got the crowd hyped. Don't let us down.
I was waiting.
for the top.
Did you buy the extra premium ticket?
Oh yeah.
All right, I guess we've got everyone hyped up for our next talk. The next talk is devenv is switching to Twix. Let's welcome Domen.
Hey everyone, hope everyone's got coffee after lunch. This NixCon is a little bit sentimental for me because I think the first NixCon was 2015 in Berlin, organized by Rob Garbus, and we were like, completely...
Sorry, we got no slides?
No slides?
Check the video, I'm sorry.
It should be slides. There you go.
There we go.
And yeah, it was like, I think we were like 50 people, and we were in like we had to like move stuff from the room to make it empty with Garbus to even make the conference. So it's great to be back, long story short. Yeah, so I want to talk about a little bit like where we're going with devenv. I've written on the devenv blog post a bit about history, how we got here. So I'm going to skip some parts of that because I think it's more interesting to see where we're going. So let's start a bit. So like one of the things that I was thinking about, why is Nix not mainstream? Why is not everyone using Nix? And this is the question I've been asking myself for many years. And when I was in Thailand, I was listening to audiobook Crossing the Chasm. It's a very typical book actually for startups, but it talks really about technology adoption and how it goes through this like cycle of adoption, and then new technology comes in and so on. And in the beginning, there's like technology enthusiasts and visionaries, which kind of like are super excited about the thing. And then at some point, technology either dies or never goes through that thing when it becomes like mainstream and used. And this is called the chasm like kind of phase. So I was thinking a lot like, why is that happening? Why is that not happening to Nix, and what we need to do? And so if you look at Nix going mainstream, there's like these like two things that are happening. One is the positive feedback and the negative feedback. And I think in Nix we have plenty of positive feedback. Like whoever tries Nix, they're super excited. They tell everyone, right? We have all the memes about like Nix spreading, the word spreading in toilets and whatnot. So I think that we don't have a problem with that part. I think the problem is with the negative feedback, and that's important feedback, right? That's the feedback where we get, okay, this doesn't work, right? Nix doesn't work, I hate Nix, I don't know, whatever. Bazel is better, I don't know, whatever. So like when I wrote the blog post, someone from Canva said, Oleg, who I said, okay, typically the face is like this. Somebody's super excited about Nix, and they bring it to a company. Canva is a huge company, right? Huge, huge, huge. So there's one person who does the effort, brings it in, and then after some time, there's like backslash from other people who are like, oh, Nix sucks, I don't want to work with this, and it's difficult, and it goes in my way, and things like that. And so Nix initially introduced by so enthusiastic, and then faced with steep adoption curve, it's abandoned. And he said, both true. I brought the whole Canva on top of Nix back on the day. And Canva is like, I don't know where exactly they're headed, but it seems like they're not going to head it to the Nix way. So like this is really important feedback. And in my company, when somebody stops using it, we would always ask, why did you like stop using Nix? And this was very consistent. Right, so we have to figure out what is going on there. Like, why is this happening? Like, why are people like not liking Nix? Because this is like those people are the ones who then go around and say, "Well, we tried Nix, but it didn't work out." So that's really bad. So this is how they see us, right? This is Nix from the outside. Like they're like, "Okay, you guys like pain. That's like not good. We're not gonna do that." So like. You know, joking aside, this is something to be addressed. So like, I like to see this as like, we need to fix the developer experience. We want people to love Nix as much as we do, and they shouldn't walk on eggshells in order to use Nix. And you know, everybody talks about developer experience, and it's like this vague abstract term. What the hell does it mean, right? So like, I like to think as developer experience as like all the things that you need to think that you shouldn't want to think, right? You know, like every time I need to make a decision about something, maybe I don't need to make that decision as a user, right? And there are different aspects of cognitive overhead that happen in technology. But I think removing all those things from the user's plate is really important to love Nix, right? Like, I don't know. I don't want to... Why do I need to package something in Nix, right? It's not... I didn't want to package something in Nix. I wanted to run something, right? I wanted to run some software, right? And we are excited to package things in Nix, but people are not. And it's totally fine. So maybe they shouldn't, right? So there is a great quote by a French poet. Perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. And I think this is like notoriously problematic in technology, that we keep on adding things, but then sometimes you need to remove things because there's too much stuff. And this goes together with the developer experience. Maybe there's some things that you need to remove in order to remove that cognitive overhead. Well, actually, that quote can be simplified to perfection is achieved when there is nothing left to take away. And if we go a bit further, we can say perfection is achieved when nothing is left to take away. Or, as we like to say it, you ain't gonna need it, right? I think that's like, I think programmers, we typically obsess with the dry principle, you know, do not repeat itself. I wish we switched more into this, right? Like, do we need this? No. So this is like kind of the mindset I have when I'm trying to tackle this developer experience in Nix. So, all right, that was a very long intro. So developer environments, like we've been working on devenv now for 2 years. I don't know if you can see this, I hope, in the land, okay. So it's like, okay, what do we need to remove, right? We need to remove all this cognitive overhead of dealing with systems and importing stuff and whatnot. And NixOS as a module system turned out to be a great interface. So why not use that for developer environments as well, right? That was kind of like the key insight. So like this would be like a very typical definition where you say, okay, I have some packages, I'm using Rust language, I want to use this channel, I want to pass some flags, I want to specify some targets. I have some processes that I want to run as developer. I have some services, maybe I depend on Postgres, run Postgres for me, please. And even testing, like we have like a test command that will like run the processes for you, create the environment, everything, and then you can like wait for a port to be open, for example. This is like really as simple as it gets, right? That's as simple as we managed to get it. Like I don't know what else to remove from here, and that makes me very happy. So the way I see it is, Nix is like the JavaScript of DevOps, right? I don't think anyone is extremely excited how good the Nix language is or bad. Like, so that's why I'm like, okay, this is like we're kind of in that sphere, right? And we might develop like TypeScript at some point, right? We have Nickel, for example. So like there is a lot of parallel things that are happening. And we want Nix to kind of be the toolkit for DevOps, right? So I see a lot of similarities between the two. So anyway, we developed like a bunch of stuff, tasks and services and whatnot, and Git hooks and everything. But this is not a talk about devenv itself, and there's a workshop at 3 if you want to try devenv and use it on your project. This is more talk about like, why are we switching to Nix, right? So again, long introduction. So what are we happy about? We're happy about a command line interface. We spent quite some time to make that like nice and simple. And we're happy with the Nix interface, which is the module system, which allows us to like add options, remove options, deprecate options, and extend options. Anyone can add their own set of options to devenv. Let's say they're not to be upstream to devenv itself, but you can have it for your own project or whatever. So that makes it super nice. And thanks to the module system and NixOS, this is all like there, right? And people know how to use it, which is great. But then, now that we're happy with this, there's like a ton of bugs we need to fix in Nix, and a ton of problems that we have. And devenv uses Nix as a command line interface underneath to invoke Nix. That's just because when we started devenv in 2022, that was actually the best option to use Nix through the command line interface. There was no SDK or anything. That had to be developed. So command line interface is highly, highly restrictive and very basic. So we had to maintain a couple of Nix patches in order to bend devenv to be what it is today. I mean, that's also not great, right? We would like those patches to be upstream, but they cannot go upstream because they're too opinionated and they go too far away from what Nix upstream is, right? So ideally, we would have these interfaces for Nix that everyone can implement something on top of Nix and decide what is their interface and how they want Nix to be. So that like we're not fighting in this one monorepo and like, it should be like this. No, it should be like that. So now that we're at this phase where we want to like look at that, it's like, okay, before we go there, we want to explore the options, and I see two options. Either we go very deep into developing SDK for Nix, or we go to Twix, which has seen like 3 years of development. So I was researching that, and I want to show an example of how our thought process went and why we arrived where we are right now. So one of the problems with developer environments is like they should be really fast. We develop like a caching for Nix, and at the top you can see if I'm using the cache for the eval, like devenv runs in 0.1 seconds, about 100 milliseconds, and activates the shell for you. And without a cache, it's 5.5 seconds, right? So like this is completely basic devenv, like nothing is happening in there. This is just all boilerplate stuff. So 5 seconds to set up developer environment is, I think it's too much, right? The good news is like we implemented this cache and it works really well. So we're happy with that. The problem is how we had to implement this cache was tough and not nice. So there is no SDK for this. So what you can do is you can tell Nix, okay, give me the log format in internal JSON, and you get these like wobbly JSON lines. And in there are messages where it says evaluating file, and it gives you the file and reading directory and so on. So what we're doing is we're parsing all the logs from Nix, and we're like collecting whatever Nix is trying to import to do the evaluation. And this is like what we need to track in order to be able to cache it, right? So we parse the logs, and then we store. Okay, if you invoked Nix with this command line, then these are the paths that also were the inputs. And then if none of these changes, then we can just cache the thing and return whatever the result was. In other case, we have to invalidate the cache. And then we compare the timestamps, And then we use Bley tree hashing in case timestamps don't match. So this is just like an optimization. And we can do this like in a couple of milliseconds. So that's why we can get to 100 milliseconds. There are parts of we still need to use NixDevelop, and that actually evaluates bash, because why not? So once we remove that part, it's going to go sub 50 milliseconds for sure. This is kind of like how it works. And if you look at the implementation, we have made it a library. This is about 1,350 lines of Rust code that parses the thing, stores it in SQLite, does all the logic. So that's not nice. I mean, that's like a lot of stuff we shouldn't be doing. And there's no guarantee. Like if somebody contributes a patch to Nix, now this logging changes and it's going to break devenv. It's like really sad. Again, should we use NixCFFI or Twix to improve that? And there is no SDK support for this, so like we would have to implement that SDK support. So now I'm gonna try to explain how this would look in Twix and why we think that like Twix solves this in a fundamental way. So if we say we're gonna switch to Twix, that's a rewrite, right? And rewrites are scary and dangerous. They not often work. But the key, I think, to rewrites, to successful rewrites, is to do it in a modular way. So we're gonna start with the evaluator, and we're gonna like integrate Twix evaluator, and then go step by step into Twix. So Twix was started in 2021. Florian had a talk, and you can watch like the general overview on YouTube probably later if you haven't seen the talk. And Vincent, who I think they were the first ones to really go deep into this, but there were many other people involved into Twix effort. And I really like this picture because it captures that energy and moment when Twix started in 2021. And there's a blog post, We Are Rewriting Nix, that kind of talks about a bit more about what Twix wanted to do and the similar goals to what Twix was trying to, why the rewrite is needed in the first place, right? Because that's expensive. So currently, the Twix evaluator looks very like this. We have some Nix code. We compile it to bytecode, and then we execute that bytecode into whatever result, which is derivations. Usually, that's what we're interested in. And the idea behind this is that like this extra step of generating bytecode can be useful to cache it somewhere, and that should, in theory, speed up the evaluation. So we don't know yet. The core idea is that like if we can create optimizations at that level, that a bytecode interface can run faster, then running the bytecode should be faster than just what the C++ Nix does, is just straight from Nix to running the thing. So this extra step, a lot of compilers and interpreters always have different steps. So this introduces this one intermediate interpretation. So we don't know if this is going to work or not. This is like, as far as I talk to Twix people, they don't know. But it's an idea, and I'm confident whatever solution we end up, the goal is to make the evaluation faster. So to go back to my previous, what we had to do to implement caching, like Twix has this idea that it exposes in Rust traits, but you can think of this as interfaces where you can implement your own implementation of a certain interface. So for example, for the case of caching, there's an evil IO interface which has all the IO operations that are happening during when a validator runs. So we can hook into this and just essentially store this in some kind of SQLite or whatever. And that is our caching then. So that's like really simplifies the implementation. So this concept of like, let's split the whole Nix into a lot of interfaces, and then we can swap and experiment. is, I think, really powerful, and that's going to enable a lot of innovation. So if somebody else writes a better evaluator and implements the same interfaces, we can just swap it, and there you go, right? And that creates, I think, very healthy competition. So devenv has this title: fast, declarative, reproducible, composable developer environments in Nix, but they're not really fast, and we want them to be fast. That's really important for the feedback loop. One of the things I didn't talk about in developer experience is like really fast feedback loops. I think it's really important. And developer environments are the core of software development, so like we shouldn't compromise on that. So like the idea is currently that, okay, if we look at the frequency of operation, like devenv, which is like the top thing, is rarely changed. But if you do, so that means like if you don't change anything Nix related, then environment should be like instantaneous. Just get it from the cache, and this is your environment. But if it does change, it's like just one file that changed, right? Like the rest didn't change. So like why are we re-evaluating the whole thing from scratch? And this is where we hope the bytecode cache is going to take care of saving us all that work. But then if you run devenv update and update like dependencies, then the whole thing changes, and then you're starting from scratch. But how often does that happen? Like almost never, right? Like you run this like a part of like a pull request or something. So this is like not something, even like that's gonna be a CI who's gonna run this. So not even developers are gonna like get this. They download the thing, they have to update the bytecode, and that happens now and then you're done with that. So if we like look at the statistical kind of like distribution of this, we want to solve the first point, and that's what we did. Like, so right now we have this cache, check if any of the files needed for this evaluation changed. Okay, that runs in 100 milliseconds, we can get lower. But then if we hit the second point, like if it does change, then if you evaluate devenv.nix, it's around 600 Nix files. Like this is all a lot of Nixpkgs import, right? All the packages that it needs and a bunch of devenv modules. So like it has to go through all of that, right? Again, if we can cache that and it gets like lower than 5 seconds, that would be great. I would personally like to see that to go below 1 second, but that's just like more of a developer experience goal rather than is it technically achievable. If we don't manage to do that, then we're gonna need to add garbage collection to Nix and have some kind of a daemon that is going to like cache the whole thing and then reevaluate the top thing, but keep the rest of the results, and it all becomes really messy. So I really hope we find a solution to this that doesn't require this daemon state to run all the time. But worst case, we're gonna have to go down there. So again, it's an experiment. So I don't know, I hoped I gave you one example of how these interfaces and Twix make implementing these things much, much easier and save a lot of developer time and a lot of bugs as well, right? Parsing logs is difficult, as in keeping compatibility layer in place until something comes up and changes it. So then the question is like, okay, are you already using Twix? And the answer is no. I spent quite a lot of time looking into Twix and what needs to be done in order to get there. So I want to go through like general roadmap of how do we get there to use Twix evaluation component in devenv. So built-in fetch tree, this is like the core idea in Flakes. And I think that this is like the part of Flakes that is difficult to implement. There's a lot of problems with it. But it's something that we just have to keep because these URLs are now everywhere, and we need to keep compatibility with fetching things in the same format. So like implementing built-in fetch tree is gonna be tough, but that's something that I've been looking at, and I think we can do it. The challenge in built-in fetch tree is that like what Nix currently does, there's a lot of problems. So we can either do the same thing and kind of inherit all of those problems, or we can do the correct thing, but then we break the hash that this generates. So what does fetch tree does? You give it a URL, GitHub, tarbles, whatever from the internet, and it puts it into a Nix store. And this is like the layer, if you're familiar with functional languages, this is like the impure layer of languages because this is done outside of Nix build. This is done outside derivations, and it's kind of ingested in Nix. And this is like how we're like fetching things from the internet so that then Nix can do its job, right? And there's this idea of like, okay, we're gonna make an R hash so we can use substitutors, and we have this Nix store path and so on. So we are thinking to implement this GitHub side, which is like a pure Git re-implementation in Rust. Expose the caching layer as a trait. You need to do caching because every time you fetch this, you want to check. If you don't specify revision there, you want to check, is there a new version? Is there a new revision for, let's say, Nixpkgs, right? So we need to. Sorry? Okay. And yeah, like there's a lot of other stuff like there's like GitHub API calls that I don't think there needs to be there. So like all of this throttling that's happening right now by the GitHub, we just don't need that, and we can like do things without hitting those rate limits. So that's something that we're gonna work on. The next bit is like Nix debugger. We're not shipping Twix evaluator without the debugger. And right now, if you pass Nix debugger to devenv, that invokes the Nix debugger, but there is no debugger in Twix. So why is this important? Like Nix is dynamically typed language, and if you get an error, you know, value is a set while a function was expected. Like this depends on the value of what error was happening, and usually from the code, it's not always trivial to know what this value was. So we need to be able to go into debugger and spec that. This is something that I have interest in funding. I don't know how to build it myself because it spans different components of Twix. So if somebody's interested into doing this, please let me know. This is a really important part and the biggest unknown right now, how do we get this done? And at the same time, it's something that we really need in Twix evaluator before we can start using it in devenv. Then the important part is like, okay, Twix is re-implementation of Nix. Is it stable? Does it work correctly? There's been a ton of work in this direction, but I would really like to have regression tests that evaluate the whole Nixpkgs over time, go back over years, make a nice report, and then we can see, okay, is there any problem still that we need to fix to make sure that evaluation is exactly the same? And this is really important for correctness. And then if it's not the same, we need like to build a bunch of debugging tooling to be able to fix these things in a fast way, to be able to understand, okay, why is it not exactly the same, and where those differences come from. This is like crucial because we want to have confidence into the evaluator when we integrate it. And then the last bit is the Nix daemon. So once we evaluate, we need to schedule builds. And there is like already been work done by, I think, Edifits and others. So we have like a handshake between the Nix daemon from Twix. But we need to implement more parts so that we'll be able to say, okay, like Nix daemon, please schedule the builds for us. That way we can like have the evaluator component re-implemented, but still keeping the Nix to do the builds for us. The other option is to use the FFI, and I would really like to avoid that. So if somebody wants to collaborate on this, that would be great. But it's reverse engineering the Nix demo protocol, which is not spec'd out. So it's quite interesting work. Let's put it like this. How am I doing on time? All right, good. So, but the least of all, it's really fun. Re-implementing Nix, I think, is fun. I envy when I see Flockly being excited when something new works, and it really gives me that like vibe that was there in Nix like 5-10 years ago when we were figuring out things from the scratch. And I feel like that is kind of like being reincarnated in a new form through that. And it's really cool to see that energy and for the dream come true, what Nix could have been and what Nix could be. and open up those gates. I personally think that like, I don't know, I like to compare it a bit like Docker and containers. Docker was like, came and it was this big thing, like it was this big thing that you had to use. And then container industry like tore Docker apart into different layers and components and made like Docker as a thing that everyone can use containers now, and there's different runtimes and there's different formats and all that stuff. And that's really important that then innovation starts to happen in different areas. So I really see that this is like the moment in Nix when we get to do this. So I think this is really, I tried to make this meme about Twix, but I couldn't find a way to do it, so it's just beers. Sorry about that. All right. So the last part of my talk is like we've been organizing sprints, and I think Nate is going to talk more about what sprints are and what exactly at the lightning talks. What do we have? So Lassulus, besides organizing conferences and speed dating, he also does cooking. I'm just kidding. We were at the Tiger Sprint this year. That was the first sprint in Thailand, Chiang Mai, where we gather for a week and everybody can work on whatever. There's going to be Twix people, so if you're interested in hacking on some of the stuff, there's going to be announcements hopefully soon that you can sign up for the sprint. And we've been hosting in Lanzarote on Canary Islands where I live, Ocean Sprint. I think we have the 5th edition happening in March, and you're also invited to come and to hack on whatever you want about Nix. And that's it. There's like the devenv projects and the Twix project, if you want to know more and if you like to explore this. And I'm really excited about like what this is going to enable us, and I hope that once we do this work, we'll be able to be confident we can iterate faster on devenv. And well, give it a try, dive into Nix. It's nice. It's really nice Rust code, well documented. I enjoy it, and I was immediately sold when I saw how it works. And that's it. I hope you enjoyed the talk, and thank you for listening.
Hi, thanks for your talk. I think it's really exciting, and Twix will probably enable many new use cases. For devenv in particular, I'm curious about the onboarding experience that you aim for in the medium term when you have Twix embedded or used in devenv. You had a slide about the daemon and integration with the daemon protocol. Does that mean you plan to use the C++ Nix daemon still? And what does that mean for users that you want to try out devenv for the first time? Maybe they're new to Nix. Do they then still have to install traditional Nix and Twix and devenv, or what's the plan there?
Yeah, so like because we're doing a rewrite, we want to do it phase by phase. So when we integrate the evaluator, you're going to have to install Nix and for the Nix daemon to run. And long term, of course, we hope that the Twix building part is going to stabilize as well, and we can stop using the daemon. But until we get there, we have to do this in this way. And yeah, so for now you have to install Nix in order to use devenv. That's the short way of putting it. Yeah.
All right, thanks.
We have a lot of time for more questions.
Have you tried Nix Remote Crate that implements Nix daemon protocol?
No. Does it work?
Kind of. The example in the repo is a proxy that dumps all the interactions on the STR, so you can kind of use it.
So it implements the client daemon protocol and then talks to...
Client and server side, well, all the structures and stuff
Okay. Yeah, that's great. Thanks. I'll take a look at that. There you go. One problem solved. Any more questions?
Yeah, this is me not really understanding how these things fit together. But what I remember from Florian's talk is that with Twix, they want to not have derivation files, right? They want to do the build as they evaluate. And how does that rub against wanting to use the evaluator with Nix? Does that have competing goals? Does that mean that Twix needs to do more than they originally envisioned? Are there changes to be made there, or?
That's a good question. So because these are components, right? I at this phase I only care about, okay, give me the evaluation and then let's create derivations and talk whatever Nix daemon is doing. But Folkly might explain this, but I think Twix main benefit actually comes from the build part. There's a lot of really nice stuff you can do there with stores and all that stuff. So they want to eliminate, yes, the derivations and have this thing be more like a stream-like interface rather than write to the Nix store and generate derivation and blah, blah, blah. But that is then part of the implementation, how the building works in Twix itself. And yeah, you're not, technically you could implement an interface that both can work, but that's still up, as far as I understand Folkly, and Folkly can say more, that is still something that we need to decide whether we want to support both options or just one. Yeah, but I'm sure Folkly knows better about this part of the Twix. I think Folkly, yeah.
So we do have the derivation, or at least enough information to realize the derivations as we go through the build. They are not written to the Twix store or to any file system or something, but we need to maintain this information as we go through the evaluator. So right now it's accessible in one I/O implementation, one of these eval I/O implementations, and you can kind of get it out of there and then write the derivation files to some SQLite database or wherever to then feed them to Nix somehow. So that should be possible to access from there.
Yeah. I think one of the main goals that is very exciting for devenv is that you can have import from derivation as a first-class citizen. And well, there's a couple of things you need to get in order to make that a first-class citizen feature. But that's really exciting for devenv because I started devenv as a goal that you can have. You can say oh, I have a Rust package, Rust software here, just package it in Nix, right? But we need to get a lot of things in order before we can get to that point. And IFD and what Twix is doing is actually the way there. Main blocker being the parallel evaluation. So a lot of evaluator work that needs to be figured out.
Do we have more questions?
There's one.
I'm sorry.
So, Domen, you're of course the creator of devenv and Pkgs. So, of course, you're always thinking about this, total picture of using Nix. So, one of the cool things about Tvix, from my perspective, is that, in the talk I saw yesterday, there's all kinds of fun new hooks for having Nix or this Nix-shaped thing talk to other services and talk to whatever. I'm curious if you have any sort of big picture thoughts about where devenv could go and what kind of sort of platform interactions it could have, either with Pkgs or with some new sort of platform or something like that.
That's a great question. I mean, when I was designing this, I was thinking for maximum extensibility. I don't know if that's a word. So devenv is going to have like cargo style plugins probably one day where you'll be able to like, insert your, I don't know, devenv foobar command. And in the end, you're going to have the Rust API to be able to like, evaluate something, do whatever you want. And that way anyone can write, like you could write even like, I don't know, JSON interface, and you would like fetch the developer environment in JSON and then convert it to Nix and then do the rest, right? So like that's the long-term goal. But before we get there, we need to figure out a lot of the other stuff. And then hopefully that enables everyone to integrate devenv into whatever they want. I don't know if that answers the question exactly.
For sure, thanks.
Do we have any more? Okay, I guess we're good.
All right.
All right, let's thank the speaker again.
Thank you.
Okay, are you ready? Cool. No animation? All right, everyone. Our next talk is going to be enabling incremental adoption of NixOS with module contracts. Let's welcome Pierre.
Thank you, everyone. Thank you for having me today. And so, yes, I'll be talking about incremental adoption of NixOS and what we need to do to be able to enable that. So a little bit about me before. I'm Ebit Zaman on internet, if you saw me there. Pierre Penninckx. I'm really into self-hosting, into data sovereignty, and that's the angle I approach NixOS in everything I do. And that's also what I want to enable more with this talk and what I propose in this talk. A little bit about work. I worked until very recently at Fastly. For those that know, they're the CDN for the Nixpkgs binary cache. So that's pretty cool. But then I moved to Switzerland recently, and I'm now a full-stack engineer at WeDo. And for the funny part of all this, I moved from Belgium to LA for the work, and then 9 years later and 6 kids later, I'm back in Switzerland now. So I moved like literally a month ago, and now I'm here to present to you. But anyway, that was about me. So this talk, I'd like to essentially introduce a new pattern into Nixpkgs and convince you that it's a good idea and that you should all do that for those that maintain something in Nixpkgs. And it's actually an old pattern, and you'll see what I mean about that, but it's not rocket science. I didn't invent anything. It's like something that we just don't use and that I find fitting. And so the promise about this pattern is that it will improve our capability to share code across modules, that it will improve code quality, and that finally, it will enable incremental adoption by other people that do not use NixOS right now. So just so you know the structure of the talk, I'll just go over a little personal history of how I used NixOS and how I got introduced, the issue I saw with NixOS as it stands now. I'll introduce the new pattern, and then I'll show you what essentially the world with this new pattern would look like. I started, as maybe some of you, with a new server at home a long time ago now, and it was my old desktop server, very simply. So it got XBMC at the time, for those that know. It was to see movies. It was a shiny app, that I could show to my family, so that's the reason why I installed that one. But then I didn't know anything about managing software and things like that, so the way I did that was very imperatively, right? So I installed a few things, and it piled up, and then the list went on forever, right, of things I wanted to try. But then at some point, everything was imperative. So when I got to the last thing, the dashboard, I found a Homer package that does this, that has a nice dashboard for your web UI. Well, I needed to change everything I did previously, and I forgot everything about everything, of course. So this has the unmanageable stamp, and I didn't really like the solution, but that's what I had. It accumulated over the years. So I tried something else. I was using Emacs at the time, Vim also, actually, so there's no war there. I used both. And I did this. So essentially in Emacs, I don't know if you know, there's a org mode package, which essentially is a way to do kind of declarative literacy inside Emacs. And I had this documented checklist of things I needed to do to install something, which kind of worked, actually, surprisingly, now that I see this a long time afterwards. But so, I had something to install a package using Arch Linux at the time. I had something to create a Postgres database, which is not really unlike what we have on NixOS, actually. I have something to manage a file for the reverse proxy. And then I got to the point where I wanted to have SSO. Don't ask me why, but I found that cool. And so I was like, let's configure SSO for everything. But that was too much for this standalone file. So I had even scripts I created in Bash. And it was, again, quite horrible. So if this is literally screenshots from the file I used before switching to NixOS. And you can see these are all the top level, things I needed to manage. And nested inside was like a long list of things I needed to do. And as you can imagine, there was a lot of copy pasting. And again, it was unmanageable. But then I discovered NixOS, and it was super cool. And by the way I discovered NixOS was using through Haskell and Reflex FRP, which is a functional reactive programming package for Haskell. And that thing is so complicated that it needed to use Nix to build. And so when I first stumbled into that, I was like, oh no, something new to learn. But then for a year or so, I kept it on the side and finally realized what it could do. And so I wanted to use that. So on the laptop, it was quite easy to start using that because in a way, my laptop is just a few files I have laying around, a few documents, code editors, but that's about it. There's not too much state, right? So I could start anew pretty much easily. But then the question is, how would I move my server to using NixOS? Like, if you remember that long list of things I installed, there was no way I could convert that to NixOS in an afternoon, right? So the question is this: how do I switch the server from this thing to NixOS? And so the first option that I do not recommend is clean state, right? So what happened to my server at some point was it fried. So that made an easy path for me to start from scratch because everything was down anyway, and reconstructing the other one was too painful. So that was easy. I could upgrade to some crazy beast of hardware. Shout out to the self-hosted podcast, actually, because I got it for half the price. So that was nice. And it even had 4 USB 3.0 ports, which was a huge improvement for me. So that gives you the level of where I was at that time. And so, clean state, right? I could do this, services.nextcloud.enable equal true. And this thing sets up a lot of things for me. Everything I took like months to get right, I could do in one line of code in NixOS. So it sets up Nginx, the reverse proxy, PHP FPM. It even allows you to choose between multiple databases. And same thing for the cache. You could choose Postgres or MySQL or Redis or mcached, and I think there's even more now. So I really was convinced I needed to use this for NixOS, and that's how I started. But then this is the happy path of using NixOS, at least how I see it now, starting from scratch. So first option for people to adopt NixOS is do the same thing as me, just fry your server and then switch over. But we all know that's not really realistic, especially in enterprise environments. So essentially, what would happen if my server did not fry at the time, right? What if everything was working perfectly? How could I switch over my server? And the question could be more precise, is how to make people try out just a little part of NixOS in their current infrastructure. And so in another way is like this services.nextcloud.enable equal true. How could I make it work with everything I had already working at the time? So this is the first thing I want to show you, incremental adoption. And the question, of course, with this one is how can I use my reverse proxy? How can I use my database that I set up like a long time ago? How can I use my cache? And this is really not possible right now in Nixpkgs in general. By the way, I'm picking on the Nextcloud module just because I like it. It's not because I hate it. It's pretty much the opposite. So I want to make this better, easier to use, but in a way it does too much. So yes, what about other reverse proxies? And something that's really, I don't see talked about too much is how can I even link this to another host? Because if you think about like how you would incrementally adopt Nextcloud in your existing infrastructure, well, you could start a VM with NixOS, but you could also have another machine But in a way, you need to link the two environments together, right? And there's no real way to do that out of the box with NixOS. There's another side quest, which is how to have multiple instances of a DB, of a reverse proxy. So this is a very interesting question, but this is not about this, multiple instances, just so you know. But that's interesting too. So the second promise is about improving code quality. And so what we have now is a giant beast of a module that does a lot of things. So everything I talked about, like it sets up Nginx, allows you to choose between Postgres and MySQL and things like that, it's all inside that module, embedded inside that module. And the thing is, I see as an issue is that essentially the Nextcloud module tries to own all these dependencies. And, well, spoiler a little bit, but that's, to me, what needs to change. And also a side problem of this is that if you want to be able to tweak the setting of Postgres, for example, that's Nextcloud setups, then in a way, Nextcloud needs to expose all these options because it owns Postgres, so it needs to expose those. Or you need, of course, to, I mean, you can always read the source code, right? That's easy. But that's what needs to change. You need to read the manual or the source code, and that's not really a great experience. Another way to put this is splitting the knowledge into multiple groups, right? For now, the Nextcloud maintainer needs to know a lot of stuff about a lot of things, and that's not really tractable and maintainable across like all the packages. And I see, and I suppose you see too, like different level of adoptions of different technologies across different services that are provided through modules in Nixpkgs. And again, that's something I would like to show you that it's possible to change. And the final one, sharing code. So Nextcloud does a lot of things, but it doesn't really allow you to set up declaratively backups, LDAP support, SSO. You can do it, but it's hard. And again, other services do it, but you cannot really benefit from it apart from copy-pasting code around, I guess. And yes, that's what we're doing most of the time, and that's, to me, what I'd like to see change also. So, about owning dependencies, this is how I see the Nextcloud module right now. There's the core in the middle, and then it does a lot of things. The goal for me would be to move that out of the Nextcloud module, okay? So, I talked a lot about problems, so I'd like to show what the solution is, and it's in a sentence, very easy, but we'll see, I'll show you exactly all that entails afterwards, is like not owning the dependencies. Nextcloud shouldn't be the one that sets up the database. You should give the database to Nextcloud, in a way. Oh, sorry. And so how I called this, and I'm not good at naming things, so I call this contracts, this separation, and I'll show you just now what I mean. So the goal, right, after this would be to have the core of Nextcloud take most of the module of Nextcloud in terms of, I guess, line of code, if that's a good measure. And so, for example, you need a reverse proxy. So the Nextcloud module will say, hey, I need a reverse proxy, right? And something else would provide that Nginx reverse proxy to Nextcloud. So you could do the same for PHP. To be honest, I don't know much the various implementations of PHP FPM, but it's still an example. But then you have the cache. You know, you could have a Nextcloud say, hey, I need a cache, and then you could give the cache to Redis, and same for the database, okay? So that's the goal of what I want to show you. And just so we're okay with we have the same nomenclature. Again, I'm not good at naming things, but I called the Nextcloud side a requester because it requests something, and then on the right side you have the providers which provide the thing that Nextcloud requests. And the promise with this also is, I think you can see it already, is that, yeah, right now Nginx is hard-coded inside Nextcloud, but with a pattern like this, somebody else could write a KDE module that interfaces with this reverse proxy contract, and nothing in Nextcloud needs to change for you to be able to switch reverse proxy. And same thing for the rest, right? So what does a contract look like? Well, it's in Nix terminology, it's a set of options, like module options, and an expected behavior. We don't really have something like that, like a behavior in Nixpkgs right now, but if you think about how you would interface this with existing providers, modules that provide this reverse proxy contract, well, we would need something like a little adapter that essentially implements the options of this reverse proxy contract and would tailor the Nginx existing module that has different names for options and things like that to respect the behavior that the contract is expecting. And same for each of them. Maybe at some point the adapters would merge or something, but this provides at least a not intrusive way to add this thing to Nixpkgs. And so, yeah, just to be clear, this would be a module on top of the module that we have already that would configure the providers. So one question about how would you even enforce this, the fact that the Nginx, for example, reverse proxy behave the way you expected. Little spoiler, I'll show you afterward, but the idea is with NixOS tests and to have abstract NixOS tests at the level of this reverse proxy contract. And so about the 3 promises I talked about in the beginning, like the first one was sharing code. How does that look like in this world with contracts? Well, you could just have other services like Home Assistant, Jellyfin, whatsoever, point to the same reverse proxy, and they would automatically share the code that the Nginx maintainers would have made, or all the others. And if at some point another reverse proxy gets added, it gets added to all of those that uses this contract automatically. About code quality, for me, this separation of concern is really important. It means that the Nixcloud maintainer knows Nixcloud, can focus on making Nixcloud good and behave in the NixOS environment and ecosystem. And same on the other side, you would have the maintainer of Nginx that knows Nginx, that can do what needs to be done, and that to interface with NixOS in a great way. And you don't need to cross necessarily the boundary. So in our case, it's more like people interested, right? That would be maintainers, but the idea is that you could split this in a way. In the middle, you'll need to agree on something, of course. So the community would need to enforce this reverse proxy contract, or at least come up with, a standard set of options and behaviors that this reverse proxy contract would need to do and would need to implement. But I'm not an expert in reverse proxy, so that's the goal also. It's like being able to crowdsource this expertise in a better way than what we have now. And not really related to code quality, but something that for self-hosting is like super important. It means that when you're building your box, you're the one in charge of selecting which reverse proxy goes with Nixcloud, right? Or whatever service. You're the one picking the provider that the requester service asked for. And that's super powerful to me as a self-hosting enthusiast. And so just to insist on that, the idea would be for a provider to prove that it can respect this contract, you would have NixOS test to do that. And I'll show you in code later on what that looks like. Okay, and finally, the last promise about incremental adoption. So the idea is to merge the gap between essentially the NixOS world and the non-NixOS world, whatever that word is. And so what do you put here, right? This little box. So the idea would have to be that the end user provides a provider to this reverse proxy contract, but in the config of this implementation, there would be nothing. It would, like that, it would not work, but the idea is that on this external world, anyway, the goal is not for NixOS to manage it. It's all manual, it's Ansible, it's Terraform, whatsoever. And so the idea is just to say to NixOS, hey, don't worry, I'll take care of this. Just do the evaluation and deploy, and I'll take care of setting up what needs to be done manually inside this other server or whatsoever. And this is how you could bridge the gap between your NixOS box or VM and what you had before if you want to transition or try out NixOS. So as an example of how we do things now and how things could look like with this, I propose you to go through a little example of creating a Forge, I don't know how to pronounce it actually, Forge Joe service, and link that to Otelia to have a SSO enabled for Joe instance, okay? And just because I know subs and that's the one I'm using, I'll use subs as an example for the secrets in between. So I put those on the top right here so we can follow exactly which point of view we're looking at when we look at the code. So the first thing is Otelia. There's a, just so you know, this it's a bit long on the slides. So O.S is for options.services and C.S is for config.services. So that's what I'll use for the rest of the presentation. But so there's an option in Otelia, if you don't know, to create an OIDC client. And that's essentially a list of submodules in Nix module terms. And for us, I'll reduce the plethora of options to just a few so we can follow. But the idea is you have a client ID, which is a string. You have a client secret, which is a secret that shouldn't be stored in the Nix store, right? Which is it's a string because it's the path to a file inside NixOS when it gets deployed. And redirect URIs, which is something that doesn't really interest anyone, but you still need to configure to get this set up right, okay? On the Forge Joe side, you have these options, which is you need to also to provide the client ID, which is a unique string, but needs to match between Otelia and Forge Joe. And you have the client secret, which again, same thing is a secret and needs to match between both, okay? Finally, the end user, what would we need to do to bridge the gap between both? You will need to say, hey, the client ID is Forge Joe. Again, it's a unique string. You can choose whatever you want. It just needs to match. And we'll see in a bit how the client secret is done. And then on the Otelia side, you would get, you could just copy paste the string, but let's say you want this a bit more manageable, and so you'll reuse the same options that you set up at the top, right, for the client ID and the secret. And then you need to set up the redirect URIs, which is this thing, with the FQDN, the fully qualified domain name related to your domain where you host things. But you need to put this in, which is no fun, right? So how do you know, again, what to put in there? You need to read the manual, and it doesn't exist, so you need to read the source code. You need to understand how Otelia works, how Forjo works, etc., etc. So another layer on top of this a little bit, which is what usually we have in the services right now, in the module services in Nixpkgs, is Forge Joe will configure for you the Otelia part, okay? And this is, yes, what Forge Joe would do. So here, the user wouldn't need to set up the client ID. It's like there's a default, so you don't need to figure that out. You still need to set up the client secret. And then in the same service file, right, in the same module, there would be the configuration part of Forge Joe, which would set up Otelia and would add its own OIDC client, because in a way, Forge Joe knows what it needs to have from Otelia to work correctly. And again, this time it means that the maintainer of Forge Joe would set up the redirect URIs for you. The end user wouldn't need to know about this, which is good. But then that means that we get in the same issue we had before with the Nextcloud module, is that you need then to provide an option for the user to pick which provider of SSO they want. And then if there's a new one that comes up, the Forge Joe maintainer needs to add it to the options, etc., etc. But so this is what we have, and it works pretty well still, or enough, I'd say. And so on the end user side, when they set up the SSO in Forge Joe, so they would give the provider, right? It's Otelia in this case, assuming there's a default set to null, and if you don't give it, there's no SSO configured. On the client secret side, you would then give the secret, which in SOPs terminology is created this way. You have a sops.secrets. Whatever string you want, which is a unique identifier for the module. And then you need to give the mode, the owner, the restart units in there, which we don't know where to find. And there's nothing telling us how to do that again. So it's, again, back to reading the manual and actually reading the source code again for this to set it up, right? So we did that. Let's say we did that. We took the time. And so, now we know it's this mode, it's this owner, this service that we need to restart when the secret restarts, when the secret changes, which, to be honest, maybe we could have guessed, but still, it's annoying to do ourselves. And then, yes, we could be a bit more smart again. Instead of copying again the forjo owner, we could use the one that is provided by the service, so that when you change it, if you change it, it gets automatically updated. But it's still annoying to do this part. So let's say you do that, you deploy, and then you get an error because otelia-yourdomain.com.service cannot start because it cannot read the secret file. And so why is that even happening? Well, if we go back to how the forjo module was set up, we had an option at the top for the secret, and then we shared that secret with the Otelia OIDC client instance. But those are two different services that run with two different usernames, Linux users. And so, of course, the Otelia one cannot read the one from forjo. So the way I solved that at the time was, instead of having the mode be 0400 for those that means something, I created a new group for the both to share, and then that was another pain to do. Very manual stuff to do for no fun, essentially. So in a way, we would want to do, hey, get that client secret, but change the owner to Otelia, which doesn't work, of course, because the client secret is a path to a file and not the path to the module, and we cannot really clone that thing around, so this doesn't really work, but this is what we still would want to do, right? So, yes, because it's a string. So the other option is to have a second option to have the end user fill out the secret for Otelia, and we call it client secret for Otelia. And then in the documentation, you need to say, hey, this is for Otelia, so don't use the same user as forjo, and then this would work. Yes, so this would work, sorry. And then if you look at what we had before, we had this configuration for the client secret for forjo, but we added a new one, for Otelia. And so what do we need to put in there? Guess what? We need to read the manual or read the source code to know, right? So after reading the source code, you know that you need to put in this, which, to be fair, is harder to guess because the Otelia-domain.service is not super obvious, or at least I wouldn't have guessed that at first. So you need to understand how that module is set up in the source code. It is not super obvious. So, these are the two secrets the end user needs to create by hand and needs to read the manual for, we need to read the source code for. So essentially, this is how it looks like in a comics form, I guess. So there's forjo that asks you, hey, I need a little secret. The end user says, okay, sure, I'll ask subs. Subs says, hey, yes, I can provide you a secret, but I need all these options set up, please. And so the end user says, okay, sure, I'll ask forjo. Forjo answers very gently and saying, oh, yeah, just read the manual for all the options I need, and then read the source code. The end users will do that. A little bit later, that's the most annoying part, reading the source code. It's the longest time, right? Finally, the end user knows, oh, yes, this is all the options I need to set up for subs. It asks subs about the secrets. Subs will say, hey, sure, I'll give it to you at this path. And then finally, the end user can say, hey, forjo, this is the path you need to look for the secret you asked for. So I hope you arrive to the same conclusion as me. This is kind of annoying. And to be fair, also not a great user experience, especially for those that just want to try out NixOS. So let's see what this picture looks like with the contracts. So let's squeeze a little bit of contracts in between all those actors. And again, just so we're on the same, using the same nomenclature, there's the provider that provides the secrets in this case, and the requester, which is Forjo, that needs the secrets. I put those again at the top right here so that we can see which point of view we're looking at. So first, finally, I guess, we'll look at in code what a contract looks like. So it's essentially a submodule that has two parts, the request part and the result part. And by the way, this is like a totally up to change. So this is like what I did in my garage, right? So that's also the reason of this talk, is to show you this and get opinions about this. So don't take this as this must be the way to write contracts, okay? But then at some point, we need the options we saw earlier, the mode, the owner, restart units. There's even more actually for the secrets, but it doesn't fit in the slide. And then we need this free form type equals anything for those that know, but I'll show you afterwards why we need that. So this is the requester part, right, of the contract. And then at the bottom, we have the result, which is again a submodule. And in this case, we have the path where the secret will live. And this is the provider part. So let's see how SOPs can use this. So we have the requester part. Again, these options that SOPs were already providing. We have the path part, which is the result. And then for SOPs, you need to configure actually more than just these. You need to give it, well, the file where the secret is encrypted. So this is an extra options, you know, to configure this provider. And it will change for every provider. And this is why we need the freeform type equals anything. Just so you see why I put that in there. And by the way, I was talking before about like adapters for different things. But in this case, I cheated and I adapted the contract to match SOPs because I could, because I'm the only one using that for now. But obviously, there would be some adapter in there that, but if I showed that, I would take hours to show everything. But anyway, so now that we have this contract, how does Forjo use this? So it's in a way quite simple. You would have this SSO client secret. Actually, do you see my pointer? Perfect. You have this SSO client secret at the top, and you would say create an option, and the type is of contracts.secret.type. Okay, what we defined just before. In a way, I would like here to say yes, and what I need is this mode, this owner, and this restart units options. But that's not really possible because the type here is the result of make option, you know, MK option, which is not like directly translatable. So we need to go back to the contract and change that a little bit to make this a function essentially that takes all the defaults and that passes that around there. Maybe there's another way to do this, but that's the way I found and the most easiest. So if we come back to the Forjo side, this is then finally how we would create the requester side of this secret contract for Forjo, which, okay, I did it, so maybe I'm totally biased, but it's not like too bad. But I'll let you be the judge of that. So that is for the Forjo part, and let's see how all these pieces fall together for the end user. What would be super cool is if we could say, hey, take this SOPs things and then do whatever you want with that. So you manage it how you want. So I didn't manage to do that. I got a lot of infinite recursion when I tried that. So the way I propose currently is more convoluted, and there's more. It's more convoluted, but it's not too bad. But we can definitely work to make this better. So the way it works now in code is to have this Forjo SSO client secret, and you give it the request from Forjo, okay? And then you need to add the provider-specific options, the extra options from before, which is the subs file where you have the secrets. So this is what fulfilling the requester part looks like from the end user perspective, okay? And then you need to tie that back up because now, okay, you told subs how to create the secret, but then you need to say to ForgeJo where to find it. And so you need to do actually the opposite, say to ForgeJo, hey, the result will be found here, okay? So, and also we could be more consistent with like the suffix here of all the options, but again, that's what I have for now. But this does not work, again, because infinite recursion, and I couldn't make it work that way, so you need to be a bit more specific and give the path actually explicitly. Again, maybe there's a way around this. And so, with the contracts, this is how our little comic look like now. ForgeJo asks for a secret, and you say, hey, sure, just talk with subs, and that's about it. And that's much better story for the end user, I think. So maybe some of you spotted like this new pattern is like totally not new, actually, and it has other names in literature. And again, I'm not like a theoretician, so I could be wrong here, but that's what I found from Wikipedia, in a way. So essentially, it's essentially dependency inversion, just applied to Nixpkgs. It has also a mix of interface that's not really talked upon in dependency inversion specifically. So the interface is like the contract itself and how we define that. And funnily, it's not actually totally related to design by contract, which is totally different. I didn't expect that when I named that contract, actually. And it's also not related to inversion of control. Just if you know about those, it's not related. It's a little bit related to plugins. You could think about that way too. If we come back to the promises from earlier, how does this fulfill the promises I talked about? So about sharing the code, you could see that you could add a provider quite easily, right? And so in code, what does that mean? Sorry, I'm just checking how am I on time. What does that mean is that you would, from the end user perspective, you would switch from this to this, right? The glue code stays the same, but you would just switch the provider and you would give a different extra option for that particular provider. On the requester side, how would you add a new one? Well, from the end user perspective, you would have this ForgeJo one, and then you would switch to Otilia. Again, it doesn't change much. You just change which provider you give. Then about the testing I talked about, well, the cool thing is you could have more evolved testers for what you do. We could have a hard-coded secret for tests. That is essentially what we do with write text, but it's evolved in the sense that it understands the contracts and behaves the way the contract is doing. And so, for example, for the hard-coded secret here, you would get, I'm not going to go too much into details, but essentially you would have the write text that we have usually, but then you would put that in a program that would create a path with the correct mode, and the correct user and owner, and then you would copy over that. And so what you give back to the user is a file that has the correct owner and mode. And so for the test, it's much better than write text because it actually showed me a few bugs I had in code where that was not respected, essentially. And on the other side, so yes, so you, again, from the end user perspective, if you want to test your code with the new hard-coded stuff we just wrote, you just need to change, again, the provider. It doesn't change like the glue code, just changes the extra options you give, which here it would be the hard-coded content. On the other side, you could test the providers themselves, which is a big piece of the promise here. And so you would have a common NixOS test for which would be abstracted above all this. So I'm sorry, I'll just ask, how much time do I still have? 1 minute? Okay, so I'll rush over this then, and I can show you maybe if you have questions. Same thing, we can solve the incremental adoption, all right? And again, we can write a module. I'll share the code afterwards so you can see what it looks like. But like I was saying, the config is empty because the promise is we'll do it by hand ourselves. Okay? So on the benefits for me of introducing this pattern, we can finally share code between all the services. We can improve the code quality by adding tests that are more meaningful and that are abstract also, and the same test for all the packages providing the same contract. And it would allow incremental adoption in Nixpkgs because someone can provide their own implementation of one of the contracts that suits them. My project on this is called self-host blocks. I have a few services, a few contracts. All of these at the bottom are not yet implemented. Oops, sorry. And on the right are the services I implement. So I'm trying to merge all this together to get a picture of what this could look like and something that actually works. So that's the project you can find. You can use the QR code if you dare. I know it's a bit scary. And then I'll switch to the end and just finish on this. Yes, so about the future of this, on my side, I'll anyway continue on this project because I use it for my server. I'll add more doc services, contracts, and everything. And I'm also upstreaming a few things. I mean, it's slow, but I'm still doing it. But also, I don't really know what the best way would do to introduce this inside Nixpkgs. RFC seems even small compared to all this, but it's a good start. And I'd love some help on how to structure this. I upstream already something in a PR about secrets, so you can check that out. I tried to have a grant from NLNet. I would recommend all of you to try that also. I don't know if I have it yet, we'll see. And then these are the links to all my stuff. So yeah, thank you for attending my talk. And if you have, I don't know if you have time for questions, but a few, if anyone has.
Okay, we got a question over there. Try and keep it short. Also, the answer as well.
So, in interest of time, I could be short. You had a graph with 4.0 calling out the implementations through the contract to create the things it need.
Yep.
What I would more prefer is there was a layered architecture where you have the base module and then modules on top which merge in the options and then do that through there. I think that's slightly more composable. I'm not sure. The other thing is, I don't know if Addis Buddies is here, but they were talking to me about like input-output thing, which isn't a recursive fixed point. And that sounds exactly what you're doing, where you have let's call it a module, which has an input-output. You define what the schema on the input, where you're calling the output into what other interface, and that works.
Yes.
So find them, talk to them.
Oh, okay. I will. But yes, that sounds very much what I would need.
Yeah, it's not a module system. It's not a fixed point. It's a separate thing. And it's
Yes.
all like a graph, I think. So yeah, that's just the remark I wanted to make.
Okay.
Did you manage to actually run it on non-NixOS?
You know what? I didn't try. No.
It's an interesting problem.
Yes, for sure.
We can run Nix on...
Oh, you mean Nix itself on non-NixOS?
Nix with Nix services on non-NixOS.
Oh, okay.
Like Nextcloud from NixOS on Ubuntu or whatever.
Okay. No, definitely not. I didn't try that.
It's easy to run it on macOS than on Linux.
Maybe another quick one.
Hi, thanks for the talk. It's definitely something that I would consider using. The example you gave, you went from your big mess into this beautiful Nextcloud one-liner. When you see this all finished, there wouldn't be a Nextcloud one-liner anymore. Do you have any ideas about how you could implement defaults, or is that something that's come into your thinking? So that a newcomer to Nix can really easily still use Nextcloud without knowing all these dependencies.
Yeah, that's a good point. I'm not exactly sure what it would look like, but I don't see an issue having defaults, or I don't see, a technical issue of writing defaults, be it in this way, maybe, like, you have this adapter kind of stuff, maybe we will settle on having a layer on top, that would be this contract world on top of things that exist. Now that I think about it, maybe it's not a good idea because of the inversion of dependency, but yes, I don't see why we couldn't have defaults, even if it's like, parked somewhere inside Nixpkgs, a default thing that sets up a lot of contracts by itself. That could work too. But yes, for sure, we're getting further from the one-liner. That's for true.
Thank you.
Okay, thank you. Let's thank our speaker again.
Thank you, Will.
Okay, our next talk is Call by Hash. Give it up for Julian.
Thank you. In the 1940s, two psychologists, Abraham and Edith Lutyens, they came up with these experiments that became somewhat influential. They're called these water jar problems. And the idea is you have these 3 jars, and they have different capacities. And the test subject, which in this case happens to be all of you, is expected to add up using these jars, filling them up, removing water from them, to a certain goal. So you see a few of these problems, and you're supposed to solve them. So here, as a sort of training example, we have one with only 2 jars, and the first jar, A, has 29 liters, or has the capacity for 29 liters. And the second jar has a capacity for 3 liters. Our goal is 20. So what we can do is fill up the jar with 29, and then 3 times over, remove 3 liters each time from the one with 20. So okay, so let's try this experiment. I'm going to show some of these problems on the board. I'll give you all a few seconds to think about it, and then I'll ask someone to tell me a solution. Does that work? All right. 21, 127, and 3. And the goal is to reach to 100. I'll give you a few seconds. Any ideas? Yeah. Yeah, exactly. So you start with 127, remove 21, remove 3 again, and you get to 100. Now a slightly different problem, 14, 163, 25, and the goal is 99. I'll give you a few seconds. All right, any ideas? Yeah. 20. Yeah, fair enough. Yeah. Yeah. Yeah, exactly. All right, one more. And by the way, at the end of this talk, you can all put this in your CV. I'm really good at water jar problems. One more, again, a few seconds. Yeah. So 43 minus 18, minus 10 again. Yeah. All right. Another one. I know this seems like it's getting boring. Yeah. Sorry, what? Yeah. Okay. So the funny thing about science is that it's not as reproducible as Nix is. You people are a bit smarter. So the effect that the Lutyens observed, and I've tried this on a few people, and it really does happen, is that most people answer 49 minus 23 minus 3 minus 3. And maybe some of you thought of this as the solution. And it's really very interesting because people who are in the control group, they immediately see 23 minus 3. It's a simpler solution. They answer very quickly. But the people who have been exposed to the 3 previous trials that I gave, they tend to answer the more complicated solution, and they tend to take longer to answer. So I might have biased the result by letting the first person to an answer to give the answer, right? But this is called the Einstellung effect. And the idea is that prior experience can actually reduce your ability to solve a problem well. And the Einstellung, in addition to sort of stance, also means preferences. So if you have your computer set to German, you might see it, and you have a Mac, which I suspect that no one here does. Then you might see Einstellung or Einstellungen there. Okay, but this talk is about Nix. I'm Julian. I'm the founder and CEO at Nix, and what we do is we try to make Nix be the only thing that you have to worry about. If you have a Git repo and you have a flake.nix, you push it to a Nix-enabled website. We build everything for you in CI. We cache it. It's really fast, and you don't have to do anything. But one feature that we added recently is hosting. So if you have an NixOS configuration, you can very easily deploy on every commit. And this is not what I'm going to talk about. Rather, I'm going to be talking about an idea, a principle, a concept that we adopted that I think is really, really powerful while developing this hosting. If you want to try out the hosting itself, at 4:55, I believe, we have a workshop in the other room. And hosting, I think it's really cool. You should come to it. But Nix, really, really great. I think most people here will agree. I'm not going to talk about that. NixOS, kind of surprising that, in addition to a build tool package manager, we also get this this extra thing, this entire distro that's really wonderful for your personal laptop. It's also really wonderful as a deployment target for servers. It's kind of like a great boon that we get both of these things. And NixOS is, I think, really, really phenomenal from the perspective of a static configuration. If you look at your Git repo, there's really no better way of configuring. If you look at the code itself, there's really no better way of configuring servers or a personal laptop. But there is this awkward in-between moment when you're changing things, mutating things. And that's kind of when I want, what happens in between one configuration and another? How do you get from one to the other? And this is, I think, if we start there, we get to an idea that I think is very, very cool and kind of shows us how to extend the idea of Nix and NixOS to the cloud so that we can really sort of beat the existing tools at their own game in various ways. Switch to configuration is the de facto answer to how to get from one configuration to another. And by this, I'm including NixOS rebuild switch. I'm including deploy-rs, Komin, I think, as well. All these tools at some level, when you have a system deployed, whether it is your laptop or a server or website running NixOS, on some level, this is always what you're using. Again, your laptop, let's say that you want to upgrade the version of Nixpkgs that your NixOS laptop is using. What do? You change the flake.lock if you're using flakes, or the configuration.nix if you're not using flakes, to point to the new version, NIV potentially. And once you have the code that represents the new version, you do a NixOS rebuild switch, or you do a switch to configuration. And this works, and it's really nice, and you have rollbacks. If you have a home lab and you're deploying something there, you made a change to your networking or your firewall or whatever it is, you write the change in code. It's really clear what the change is, and then you do an NixOS rebuild switch on the server itself. Somehow get the thing onto the server and do a switch. If you have a personal website, this is my idea of how personal websites look. You have something that you're sharing with a few friends, but it's not sort of high intensity, big uptime type of thing. And you have, I don't know, like a Go web server or with a TypeScript front end or whatever, however it is that you write these things. If you change your application, again, you have probably the change in the Git repo, and then somehow you get that change. You do a build, you do a switch to configuration, you use one of these deploy tools that basically automate the process for you, or you write a bash script that does this automatically for you. But this is the essential technique still. If you have a company that's very small, that has only one server, again, same answer, right? You probably have maybe a bit more of automation. But notice that this is beginning to look bad because you have downtime, for instance. So let's see some other issues. And if you have a bigger company, more users, more services, maybe you make a change on 2 different services at the same time and the API that communicates between them. And again, the answer is How do we get this deployed? NixOS rebuild switch, something like that, first on one server and then on the other, or both concurrently. Still, ultimately, NixOS rebuild switch. You might see where this is going. I think that this is the same. We're falling prey to the same problem. We're falling prey to this Einstellung effect, where we have a tool that works really, really well for your laptop and for your home lab. And we don't recognize its shortcomings in many of these other situations. And I think this is really holding us back again, right? Like, I think NixOS could be a much better deployment target than Kubernetes and Docker and whatnot. It has so many things going for it. But we have to be clear-eyed about what its shortcomings are if we want to get to the stage where we can convince everyone to switch to NixOS and be right, right? We have to be right to do so. So what are these problems, right? Like, I'm saying that they're problems, but I haven't really specified what they are. I kind of mentioned one briefly, zero downtime. What's the problem here? Well, if you have a server and you're doing a NixOS rebuild switch on that server, the systemd units go down. If you do a boot, it might even reboot. The systemd units go down. Maybe the network goes down briefly. Definitely, probably your app goes down. It has to be restarted, at least by default. And so you have a few seconds of downtime. And again, in your home lab, who cares? In your laptop, yeah, it's a little bit inconvenient to wait for 5 seconds, but given the enormous convenience of using NixOS in the first place, who cares? In prod, whether a small company or a larger one, this begins to matter. And you might still say, oh, I'm working in a small company, we don't care about 6 seconds of downtime, 5 seconds, 10 seconds of downtime. But the problem isn't just that. The problem is that if you go this route, and something fails during the deploy, if the systemd units fail to start up, you now are confronted with even more downtime and a situation of extreme anxiety because you're debugging in prod. And if you do a rollback, pretty cool that you have rollbacks. They don't always work, but they usually do. Pretty cool that you have rollbacks. But now you've traded one problem for another because, okay, your system is back up, but you've been treating your server as a pet, not as a cattle. You've been deploying again and again to the same server. And so now it's been up for God knows how long, and it's developed its own unique history. And that history is influencing potentially what happens when you do a NixOS rebuild switch. So you won't find it easy necessarily to reproduce the issue locally in a VM. In fact, the tests that you had maybe even did this. They tried to see whether starting up the VM with your supposed configuration worked. And it did maybe in your tests, but not in prod, because these are different environments already, right? And another problem is, if you're doing this, 6 seconds of downtime, I picked 6 randomly. It seems like roughly the right figure, but obviously it's going to vary from person to person and situation to situation. 6 seconds of downtime once a day is not a problem. But 6 seconds of downtime 30, 50, 100 times a day, 10 times a day, becomes a problem, even in small companies. And so what this means is you never really want to have CI/CD, automated deployments, on every push to main if you're doing something that causes this much downtime. So you never automate that process, and it is always manual. And the velocity, the time between you making a change that goes to main, you or your coworkers or collaborators or whatever it is, the time between you making a change that gets to main and it being live increases, and you're doing this work manually. So this zero downtime thing really sort of hides another problem, which is you want automatic deployments, and NixOS rebuild switch is getting in the way. There's another problem, which is atomic upgrades. What I mean by this is, again, the problems we're seeing are kind of tearing at the seams of this notion that the commits are the only moments of truth in your deployed system. In fact, there is this interstitial states, these deployments, right? And with atomic upgrades, that issue becomes more prevalent. For the problem of downtime, maybe you set up some sort of very manual system with rollover or whatever, and that could have been a lot of work. But combined with this, you're in trouble. Atomic upgrades are, what I mean is something like, if you're deploying with NixOS or build switch, and you have two servers, and they're talking to one another, what's going to happen is that you're going to have different versions. You make a change, you make a commit, maybe you change an API, right? An internal API, where two servers are talking to one another, and you go from an endpoint giving a string to it giving a JSON object. But you change the client and the server in the same commit. So in your tests, everything is green. In the snapshot view where commits are all the truth, nothing ever went wrong. But when you try deploying, there are going to be two moments. There's going to be a moment in between where either one server is up with the new version and the other with the old version, or vice versa, or sometimes even mixtures of versions if you have redundancy, or downtime. So these are some of the problems. And in my opinion, when you start looking at this problem, you realize that we kind of fixated on the wrong thing, which is using switch to configuration for everything, whereas we should have fixated on immutability. What I mean by that is that we're doing the original sin that Nix was supposed to save us from. We have one name, which is the URL of your server, and what it means keeps changing because you keep deploying new things. And I'll show how that problem sort of causes a lot of the issues that we see, and once we get rid of that problem, a whole new sort of landscape opens up. Now, on Nix, so again, this is about a design pattern or an idea or something, but we implemented this in Nix, and I'll explain a little bit how it works. So you don't have to do anything in Nix by default. If you have a flake.nix and push, it'll build the things. It'll build the NixOS configuration as well. But if you additionally add a garnix.yaml with this, for instance, and it so happens that you have a NixOS configuration that's called my backend, well, I said so happens, but obviously it's not coincidence. You should check whether the names are the same. Then what this is saying is that on every commit to main, I want you to redeploy this. So again, you add this, you commit it. We're going to spin up, without any extra work, we're going to spin up your server for you. And in a minute, it'll be ready, and you'll have a server running. If you delete this file and push, it'll tear down the server. So no provisioning work for you. But every time you make a change and commit, we're going to update your server. Or rather, we're going to do this with zero downtime. We're going to spin up a server on the side. Once that server is ready, functioning, then we switch traffic to it. And I say switch traffic when just a moment ago I said that you shouldn't do this. I'll come to that. But by default, you get these URLs for, they just get generated for you. And usually, either you give your friends that URL or you put a CNAME to it and we do HTTPS for you and whatnot. But then that server is going to be accessible in that URL. This is still committing the same sin, but it's sometimes practical. But the crucial thing is you also get, each one of your machines, you can have multiple ones on Nix, each one of them gets a hash URL. And the hash is the hash of the configuration. So that never changes. What's behind that hash URL is always going to be the same thing. A lot like, your Nix/Thor/ some hash/Python is always going to be the same Python. So you can kind of think of this as kind of the Nix store of the cloud, right, of servers behind every entry in this Nix store, which has names that are URLs. You have a single server, a single NixOS configuration. This buys us a lot. It's really amazing. If you spend some time thinking about this, there's just so many things that are cool about it. But to talk a little bit about how you use it, it's a lot like how you use packages in or store paths in Nix, right? Like you have interpolation, and here we have two NixOS configurations, the front end and the back end. the front end makes a request to the back end. And when you're writing this, you use this garnixlib thing that just calculates the URL for you. And the interesting thing here is, you're writing this in a fairly easy way, but of course, as you all know, this gets replaced by a hash, much like with packages Python. And when the backend changes, the front end changes as well. There's when you push, there'll be a redeployment, but the converse is not true. If the front end changes, then the back end doesn't. So let's use a picture here to make clearer what's going on. We have this infrastructure, let's say, a bunch of servers, and the arrows indicate that server makes a request to the server the arrow is going to. And at the very right here, maybe I should get out of the way. At the very right here, we have something that's supposed to indicate the public internet. So the state of the art for a lot of these problems is, a lot of people use rolling deployments that don't solve the atomic upgrade issue, but a lot of people use blue-green deployments. And the basic idea here is you spin up your entire infrastructure anew, whatever servers you have, spin up new versions of them. Once they're ready, you switch traffic over. And then, once the old ones have finished what they're doing, however you measure that, then you can shut them down. Now you have the new infrastructure. And this is cool. It gives you semantic guarantees that I meant, right? Like this zero downtime atomic upgrades, which together mean that you can really think of your infrastructure in terms of commits, in terms of what happens at those commits and nothing in between. It gives you that. But it requires a decent amount of extra work and it has some problems. One of them is that you had to spin up the entire infrastructure anew, and that's costly and slow. Another problem is that when we had the two infrastructures running concurrently, how is it that one server in the new infrastructure was talking to another server in the new infrastructure and not to the old one? How did we not get the wires crossed? The answer is usually we have a service mesh or service discovery or some other infrastructure that allows each deployment to resolve its hosts in a way that remains specific to that host. And this is how you get to Kubernetes. You start adding these things that are sidecars and all these other sort of things that need to exist in order for Kubernetes to work. And then it's really hard to run locally, and it's really hard to run it in your own infrastructure, self-host or whatever it is, because you're adding all of these extra things to make this concept work. Whereas once you have this very simple idea of hash URLs, when you change that, as we saw, if you change that server, you're going to change that server, and you're going to change that server in the same way that if you change the backend, the front end changes. The commits changed, so it's very clear that you have to deploy something new. The hash URLs changed. And so we deploy only those three things. And because the interpolations are being resolved to do different things now, we don't need anything special to make this work. They're just the arrows actually represent different URLs, right? Like when this is pointing to this, it's because it's pointing to a different hash URL. In the same way that if you update your Nixpkgs version and various packages change, like everything just works, right? So there's a lot of things that are really great about this. I mean, one very basic thing is that now, in the same way that you can see your dependency graph when you have a package, right? There are all these tools, I think Nixtree is the popular one. There might be other ones as well, where you can see all the dependencies of a package. Here, you can see your entire infrastructure statically, right? Like, you don't need any extra tools. This is often surprisingly hard in real world to figure out what's talking to what in a world that's different than this is often surprisingly hard. Another thing is it's very easy to, if you want to start a server locally, a front end locally that's talking to the same backend that's deployed, but it's a new version of the front end, that's also really easy. You can control very, very intuitively what backend that's talking to, and it makes, for Nix users at least, all of these things make a lot of sense. I mean, an example of this is we have pull request deployments on Garnix as well. Instead of having the type on branch, it has type on pull request. And I now added both the front end and the back end. So now we have 4 servers being deployed, 2 of them whenever the traditional sort of deployment, whenever main gets a new commit, but then 2 of them, the same infrastructure, whenever there's a pull request. So you can preview what the change is going to be. And the cool thing about this is that if you want to, if you do exactly this, then every time you change the front end, for instance, it's going to talk to the old back end, right? But if you don't want to, if you want it to be different, you can just add a string in the back end. Probably, if you don't want to, it's because of persistence, actually. So we'll talk about that in a second. Actually, we're talking about that now. Persistence is probably for following along, this all sounds great. But if in your mind you thought about persistence, what's happening here is like every time we deploy a new server. And this is kind of like this stateless deployments that are so popular, so universally acknowledged as the right thing to do in larger deployments nowadays. But of course, it doesn't work for state, right? Because you start a new server every time you deploy. If there's anything that happened, got saved in the file system, it's going to get lost. And usually that's really good, because again, we're the community that uses tools like impermanence to wipe out our hard disk on purpose. So you presumably understand why this is good. It's easier to reproduce things, in addition to zero downtime and atomicity. But if you have a database, that's definitely not what you want. The answer. So how do you solve this in this infrastructure? The answer we came across, which I think is very nice, is that you should think of all these servers as having a name that by default is the hash of the configuration. And every time you deploy, you say, oh, what's the name of the server? Does it exist already? If it exists already and it's exactly the same, then if nothing changed, you don't have to do anything. It's already deployed. If the name already exists and the definition has changed, then you deploy to the same system. So you're allowed to pick a name. By default, the name is the hash URL, but you're allowed to pick a name such as DB or DB1, and then we'll continue deploying every time to the same server, exactly how you're used to. But we separated out the persistence from everything else. And so now, you get downtime. You get downtime when you deploy a new version of Postgres or when you have a schema change. But that happens much, much less frequently than all the other changes. Okay. Now, some of the ideas, I'm going to say this very, very quickly and briefly because it's, there are a lot of directions to go. But some of the ideas that we sort of think about once we started inhabiting this space, this conceptual space, let's say, is that, we could potentially just leave these URLs running forever if we have, if we can spin machines down on demand and spin them up on demand as well when a request comes in. Then you can imagine it's a little bit like IPFS or something. Everything exists forever, but what we're saying exists forever are servers. And so certain things become possible, such as sharing externally these hash URLs. You can put this in your front end, for instance. So a problem that exists very often in web apps is that your front end, you deploy a new infrastructure and you deploy a new front end, but there's someone who's had their browser open for the past 24 hours or past week, and they have the old version of your front end. And so there's a mismatch. There's an old front end talking to the new infrastructure, and this causes problems because maybe the API changed, expectations changed. But you can't really force them to upgrade because they might lose state. If we allow everything to coexist, which we can now because names don't conflict anymore, we can allow this front end to keep talking to the old version. We can allow consumers of our API generally to keep talking to the old version. So we can upgrade versions fearlessly because our users, our clients can upgrade their version on demand by changing the hash URL whenever they're ready. But in order to get this to work, we kind of need persistence to actually be zero downtime, and moreover, allow multiple versions of different schemas to coexist. Because maybe you're changing the schema behind, and if that's the change that you made to the infrastructure, there's a problem here. And this is again zero downtime, multiple versions, persistence. This is not something we implemented yet, but this is something we've been looking into, and it's pretty cool. There's a lot of prior literature on this, but I won't have time to go exactly into how this works. But what I'm going to say is, I think this is. I think I mentioned sort of that we should be clear-eyed about what's happening here, right? And these things that maybe we pretend we don't care that much about. We like a lot of the advantages of Nix, and we maybe downplay to our coworkers who we need to convince or whatever the problems with it. And that's not really fair on them and on the truth itself. And I think, if we realize that these things, downtime, atomic upgrades, easy debuggability, if we realize that these things are important, we can do a really good job of converting people to using NixOS in production. And like, that's a world that I really want, right? Like a world where you can, without sacrificing, I don't know, salary, or without sacrificing interest in the product that the company makes, or interest in the coworkers, without sacrificing your morality, you just walk into a job and you know that you're going to be dealing with NixOS, right? That's cool. And moreover, the bigger the community gets, the more people will be contributing to it. And I think also from a sort of a self-interested perspective, these problems, even if we don't always think of them as problems, they are, and they make, deploying manually every time. We think of ourselves probably as a community very much as tinkerers, but if you don't have to manually deploy all the time, you can do so much more, right? Yeah, and I think that this is a really positive way of going about it. Anyhow, thank you.
Questions? Yes.
Thanks for the talk, and also thanks so much for Garnix. It's my favorite CI service I've ever used.
Thank you.
I was kind of curious, when you showed embedding the hash URLs in the configuration, does that make it harder to spin this cluster up, locally, or to self-host it, because now you're kind of hard coding these URLs, or could you maybe stub that out so that works locally?
Yeah, that's a very good question. So usually, the way in which we've been using it ourselves is we actually just put everything in the same machine, right? And then that works differently. But that is absolutely correct. And I feel like it was actually a bit unfair of me to say you don't need extra runtime support. You do need something that resolves these names into the right thing. But it's much easier to implement because it's a static mapping, right? But you do need support, yeah. So you either need to. By default, it will talk to the Garnix servers, right? But it should be relatively easy to fix, although we haven't.
And then one short follow-on. In this graph, and you described showing a tree of all of your services.
Yeah.
This is a DAG, and it would seemingly have to be a tree.
Yes.
But is there ever a situation where you actually do want cyclic dependencies between servers, and is that a problem in this?
Yeah, there definitely is. The problem, that's a very good point. And this is usually, whenever you're hashing something, you're going to have issues with cyclic dependencies. The solution, which right now we disallow cyclic dependency, these cyclic dependencies. It is something that you sometimes want. Often the way in which it manifests itself is actually as a callback or a webhook, in which case it's dynamic, which is kind of a different problem. But But in the case where you want it statically, the solution that I've seen, I think from Unison and a couple of other places, is whenever you detect a cycle, you sort of separate that out and you hash the cycle all together, and then you say like part 1 or part 2 of that, and you give that the name, right? So that's the solution that we sort of said, okay, once this problem becomes more serious and more urgent, we're somewhat confident that we have at least a conceptual solution here, right?
Cool. Thank you.
How do you handle knowing when a newly deployed server is ready? So if you have like some domain name pointing to the like root of your entry point to your stuff, how do you know when to flip that? Or conversely, how do you know when something in the middle, when the thing it depends on is ready?
The essential idea, and this is both true for spinning up and down, is we kind of the philosophy is somewhat like a systemd. Systemd is readiness probes, for instance. At least we move them towards systemd. So multi-user target means I'm ready. So you can decide manually this is when the server is ready. You use the same sort of techniques that you already most people are familiar with. Most people here are familiar with, which is systemd, and then for spinning down as well. Because one of the things I didn't mention is it's also figuring out when it is that you can safely shut down a server is actually a complicated problem as well. And we do CI, right? So this is actually, for a lot of people, this doesn't matter that much. Wait for 5 minutes and everything is fine. But we do CI, and it turns out that this is very helpful in that. But yeah, the answer tends to be systemd. Yeah.
So do you have systemd, like once it gets to multi-user target, does it like call out to something else to
just
say
in the same
update the CNAME or something to point to the hash URL?
No, just in the same SSH process. So like say when are you done? When are you done with multi-user?
Oh right, you deploy with SSH and then just wait for it to be done. Right.
Yeah.
Okay.
Yeah, but in terms, one part of the question that I didn't really answer is like, how do servers know that one another is ready? We don't do that, right? Like we kind of expect you, if you have a dependency, we notice that, and so we spin up your dependency. But we don't do any logic in terms of saying, hey, like now we can spin this other thing up. We kind of assume that somewhere in your startup scripts, you'll say, okay, my dependency is ready, therefore I'm ready, or I can take the next step. Yeah.
Maybe just a few more.
It sounds like you can do the same, but without running a new machines. Like apply this to the systemd services on the same machine. Like have them have different hashes in names and stuff, and that would make it faster, maybe.
Yeah. I think that's right. I have a lot of opinions on this, but I don't know if I'll get to express all of them as part of this answer. I think that's right. There is a lot of global, like ports, for instance, right? Like why is it that you can't aggregate like a monoid sum or something to servers? If you have two NixOS servers, will the behavior of the sort of union of them, the concatenation of them, or be the same as the two separate servers? And there's some cases, like for instance, ports where it's not the case, and so you need to do some logic there. And I personally feel like Nix would be nicer if you didn't have port literals, for instance. But this is kind of a rabbit hole, right?
Like Kubernetes, you could allocate ports.
What?
You could allocate ports dynamically.
Exactly. No one statically knows what their port is going to be. Yeah. Exactly.
And I have another question. The hash URL, the hash domain name that you have, is it global? So if two different users deploy the same thing, they get the same server that might have different.
It is. I mean, one version of that that's very natural is if you want to do load balancing, you do want to sort of have multiple servers under the same name. But it's very strange, and again, very Nixy, but very strange, that if someone has exactly the same source code as you and they deploy it, they're going to get the same hash URL. And you think this cannot be a good idea, right? But it turns out that if they do that, if they have the same hash URL, it means that they have the same secrets, that they have the same access to. We encrypt the secrets with SOPs and whatnot, and we have a system for that. They have access to the same database already, and so I believe this is actually a wonderful opportunity in some sense for a different type of more P2P edge computing or something, in the sense that. If we collectively decide that we want some service to exist here in this room, and that service is somewhat open source, then we can spin that up, and this sort of local. A lot of the sort of Anycast scenarios become very interesting. I'm being very hand wavy, and I think part of the reason is because I don't know exactly how this would work. But it feels like there's a way in which everyone can collaborate to hosting these things, right? And to get even more intense about this, what we could do is have multiple sort of service providers that put that are CAs for HTTPS certificates. And you put the TLS certificate in the server, and you sign it if you're one of these things. And then you can have sort of either multiple sources of trust or whatever, and then you can ask anyone, hey, who's running this type of server? And if you trust, if there's a sort of either web of trust or else a tree of trust, you can kind of talk to any of them, right? But again, these are kind of crazy ideas. We're kind of, for now, pretty solidly grounded in the practical use cases of your getting your NixOS server out there, but it's nice to think about these things.
Okay, let's give our speaker another round of applause.
Hey.
All right, our next talk is going to be fused with Nix. Let's welcome Aleksander and Artur.
Yep, hi guys. So it's us again, the corporate rats. We have came out from our hiding, and we just want to share our experience with using Fuse or solving the issue of using Nix somewhere else, somewhere where you cannot really use the root directory to host the store. And we'll take you through like a short journey of why it is an issue and what we were doing before and sort of what is the state of art that we have seen. So I will skip our bios. So what is the issue? So this is a very nice corporate statement of what is our issue. So the issue was that we wanted to have very small, thin containers that will have applications built with Nix, and then we want them to like move around quickly. So they really have to be tiny, tiny, tiny.
But for the record, it's something that we see as an issue and not necessarily the corporate.
Yeah, and this is the non-corporate slide. So essentially, every time when someone tells me to bake things into container, I clench my fist and I cannot, because like Nix solves the issue of container. Why are we putting it in a container? So this is our journey of solving that. So maybe as a brief explanation, the idea here that will be said later, we are forced to run on Kubernetes. I like Kubernetes, but the building block is a container. So ideally, we want this, and we want this manifest to be on the only information we provide to the cluster. I don't want this Nix store to be part of the container image. I don't want its dependencies inside. I don't want that because it gets big and unwieldy, and this is the only information we should ever need.
Yeah, and it's probably already stored in some remote cache.
Yeah, probably already built. So here is another shameless plug of our project called Starter Kit, and these are the base images that we are using. So as mentioned before, it is something that it's not even Linux compliant. It's nearly empty. Here is an example of something that contains BusyBox and LD cache because we did our job badly. It shouldn't be there. But it's just one thing. It weighs like below 200 kilobytes.
Yeah, and it has 100% efficiency score, whatever it means.
Yeah, so this is what we want to use instead of something big. And now I jumped the gun a little, so a bit more of explanation, right? We have a lot of Kubernetes clusters. They are not controlled by us. We cannot influence how they look. They have security policies. And there is this quirk of disk space. Disk space is limited. Cleaning up it is difficult. Reaching out to infra team is difficult. So ideally, we don't want to overflow the disk space. We don't want to push those images that contain the Nix store. Like it's not really something that should belong to the Kubernetes node, right?
It's just inefficient.
Yeah, that hurts. Here, I wanted just to give you the overview if you never used Kubernetes before. The big idea is that you just have a row of nodes. Each node has a container runtime, and it is being executed there. So if you, for example, if the cluster, for example, decides that it wants to run an application on all of the nodes, like the image will just get sent to every node, and yeah, you are pulling a lot of information, and it's duplicated. And then it's not cleaned up by default. So as stated, our issue is we have Nixstore, it is built, it is pushed, and then we are just duplicating it and building it again and tightly coupling it with manifest of YAML. Like you can automate it, but it's so unwieldy and heavy, and it's just a lot of busy work for no good reason.
Yeah, and also these images quickly become outdated.
Very quickly.
Yeah, you need to rebuild them.
All right, so that's our problem, that's our mission statement, right? We could do this to solve it. So we could shift everything runtime. So let's just download it on the node when it is being deployed, and then let's build it there. Yeah, this was one of the actual suggestions we have received as a solution, and I hope I don't have to convince you too hard that it's not a solution, because we are pushing build system onto the runtime, and then we are pushing not only the application, but its dependencies there. It's bedtime all around. Do you want to take this one?
Yeah, I mean, you sort of skipped the part about shuffling layers, and that apparently is a quite common thing to do, to find and optimize the placement of packages so that the caching is, or rather placement of layers in container images is as efficient as possible to avoid rebuilds and reuse as much as possible. And like going back to your point about building these things in the runtime, well, Nixery does that, like sort of both things. So it's like, for those of you who are not aware, I think all of you are, this thing is a container registry that builds Docker images on the fly as they are requested.
Yeah, and the name of the images were also the issue. If you need a lot, like the name is really, really funny. Then we could use tools like narserv, like to try to either pre-build the images before time, fetching the dependencies, but then we are building images again. Or we can do it the runtime again, so we have something baked into the image that goes to the registry. It is getting better, but then it's really hard for people who are not familiar with the tool to debug what's going on. Like if the file is not there, what happened, you have to be familiar with the application. And this is like the most obvious thing ever. Right?
Yeah, but then there is no evaluation on the lazy evaluation. It's just shared store, and it might be in some cases it might be actually a good solution, but then it's closely related to the placement of servers, like whether they are collocated or not.
Yeah.
And then also the version of NFS. If it's version 3, then it's like a bit harder.
Yeah, and as I mentioned, we live in hostile environment, so no NFS for us unless we bring it ourselves. We are not keen on hosting our own NFS. We could do this, like we accidentally re-implemented it before we discovered that Elko implemented the bound for Nixstore. Like it's a hanging commit at the moment, but it's also not very performant. It has issues. So there is a lot of things you can use. There is a spoiler warning for the solution that is out in the open, and we have
just discovered
it. So it sticks, and it just does the lazy evaluation and on-demand mounting of files. So just putting it out there. But then we are the wonderful Bazel boys, so we also have issues with remote execution. So that's the problem too. There is a hanging open issue in the rules Nixpkgs. It's 100, like it's been done forever. I will just speed a little.
Yeah, we already covered that partially during previous presentation. So that is the part that we are trying to solve with this hacky solution, where we used a or rather statically linked GCC, but then in reality, statically linked binaries are not so popular. So we need to somehow address the problem of fetching transitive dependencies of a specific package on the fly.
Yeah, the idea is here that we would like the Nix to somehow be either in the exec root or to magically appear somewhere. And this is just an overview to scare you into believing it. It's difficult, but the idea is that in the middle you have that empty dir, and it is populated on the run with all of the dependencies. And when this is happening, somehow Nix store also has to appear, either in there or somewhere adjacent. And it's not immediately obvious how to achieve that. So that's an idea how to do that. We have been considering it. There is a fork of rules Nixpkgs that is trying to push the Nix evaluation into the build context. But it's really unwieldy, and it has the big issue.
It runs without sandboxing.
Yes.
So yeah. And changing the default store path is obviously not a solution. Well, it might be if you have enough time and resources to rebuild everything.
Yeah. So what you can do is what Native Link is doing. So you are building your image on the fly locally and uploading it. I hope you see that it doesn't solve our issue. It just pushes it further. We can modify the executors. That's certainly an approach, but again, we are in a hostile environment. We are not allowed to touch too much. So for us, it's no-go. Do you want to take the...
Yeah, this project is actually, I think, one of the first inspirations for this fuse thingy that we developed. And this project actually tries to rewrite paths on the fly by essentially... that's a LD preload trick, I believe, that identifies whatever syscall that contains reference to Nix store and rewrites it to something else. But once again, it's not really applicable in all cases, especially for static binaries. Once again,
and it's quite error-prone overall
and slow.
And another inspiration was when Flux was introduced. Like we also seen, like there was some fuse happening behind scenes. Like I think it's still closed source. I don't know.
I can tell.
But this gave us the idea of how to approach it. And the idea is to use Fuse to on-demand, like lazily provide files. And although we cannot share our implementation, like we want to show you that it's not rocket science and you can do it quickly, and it is performant enough in many cases. So again, in this example, we will be using the Starker-JIT, which is like very minimal image that barely contains anything. Again, I will be showing this. And just the briefest overview of what is implemented in a hacky Python script you will see later is that literally the idea was we have the manifest that says what wants to be run, and there is a uniform sidecar that is attached to every pod. And this sidecar can act as this fuse provider. It can do caching. And there is this magic box up there. It's part that we won't be showing, but you can implement a lot of logic within that magic box. So there is nothing stopping you, for example, for even addressing the situation in which the user is asking for something that has not yet been built, but somehow it has been registered. So it's just up to your imagination what is possible and the point I'm trying to make is people were often saying that Fuse is not performant enough. Our Python hacky script seems to be good enough for like 70% of our use cases, right? It's not that difficult. And the code of the POC is available here. And now the demo time. So I will just shift it here, step aside.
Where am I? Oh, there it is. So yeah, the demo is pretty simple because we just simulate the setup where we have like one container, one sidecar, and this sidecar being, well, pretty much some random Ubuntu image with Python because the whole application is just a single Python file, but it doesn't really contain any like exotic modules. and we register it, or rather mount it as something called storefs, because we, after some time, realized that there is some other project that is called NixOS. So we had to change it a bit. Then obviously we need to pass this fuse device, and we mount this TMP directory, which is stored on the host, that is the shared part across two containers, into container under root/nix, and then we mark it as shared. So that's the server part, and on the right-hand side, we'll just run this starter kit image that contains almost nothing.
It's extremely dirty, but the idea is to show it.
Yeah. So what happens here, we just run it and use the same store path, but mounted under Nix. So where is that? There it is. So the TMP from host in the client container is mounted under /nix. And then all we need to do is just to access the store path that we want to be fetched.
Right.
And then on the left-hand side, after we access that store path, this application looks up the NAR that contains the specific store path and it's all of its transitive dependencies. But the transitive dependencies are not re-evaluated in any way. It's just that the binary that we fetched has some references to other store paths. So the whole thing repeats over and over again until all store paths are satisfied.
Can you perhaps show the script that we are running? Because one point I'm trying to make is I am doing a lot of self-depreciation with this Python script.
There you go.
But the point is, you have seen how quickly it worked. So it wasn't really nightmare. I know it has like 400 lines. So this is spaghetti. Imagine what you can get if you rewrite it in like a language that is statically compiled and you throw in like a proper concurrency. Like I highly doubt there are like many use cases in which it is not good enough.
Yeah. So this implementation is based on Fuse tool. So it's like it's a bit slow, especially for parallel access, but it has some caching mechanisms that verify whether a specific store path is already being resolved. So, say if we have this, I don't know, we want to access something from glibc store path that contains a bunch of files, then one thread, if there is one thread that already fetches and unpacks a specific NAR file, then for any other file that comes from the same store path, then these threads will be essentially put on hold, just to duplicate the work needed. And then there is also some in-memory caching, and obviously the state. I mean this mounted Nix store that we in here we share using this TMP directory on the host path. This thing is also persistent, so we can just run this thing again and reuse whatever's had been fetched previously.
Yeah. So the point is, like, we are making good on time, but the point I was trying to make is, like, don't be afraid of using the fuse, because I feel there is, like, plenty of information that it won't perform. It does actually pretty all right without any optimization in most cases. And that's it. Yeah.
Got a first question here.
Hey, thanks for the talk. Looks like a nice hacky solution. First of all, how do you get Fuse in your Kubernetes deployments?
Currently, I believe that's possible with the more recent versions of Kubernetes. Because previously that required elevated permissions, and I think with more recent versions there is already a driver in alpha that allows for unprivileged Fuse mounts.
But we have only heard of it. Like this was all like a POC work. Like the production grade is like we still are pre-rolling out, but we are feeling pretty good about it.
And did you look into Nix Snapshotter?
Nope. But after this question, I will. Thank you.
how do you deal with garbage collection? Because when you have like a typical setup, you can run this Nix GC, it tracks the dependencies from the root, whatever, and it removes all of the stuff that it's not needed anymore. But under this setup, I guess it would be difficult for it to find out what's actually used, since you actually sort of fetch it to the sidecar application. So I'm wondering if you do anything special about that, or maybe it's not a problem because I'm not seeing anything else.
That's a great question, and the answer is we don't do anything about that.
Fair enough.
Hi, great talk. I happen to work with the old version of the Phlox version of that. And there's other people who work at Phlox here who know a lot about it. But a couple comments. You can do a garbage collection because you can see who's using files and get rid of them when they're not being used. And also you can tell the kernel to cache files for you so that it becomes very fast reads. But yes, great work, and Fuse is very awesome.
Thank you.
More questions? Yes?
Just a remark, if you are regarding Fuse performances, the CERN gave a talk at the last kernel recipes where they are transferring a huge amount of data via Fuse. So I don't think you have to care about Fuse.
Perfect.
Wonderful.
We got time for more, if you want. I don't see anything. Are we good?
Yeah, we're good.
Yeah. All right. Let's thank our speakers again. I'd like to again advertise our lightning talk block, which is the last block of the day. If you have a talk, please send us your slides. You can also do a lightning talk without any slides. We might actually open up a few more slots. In any case, please come to the front area, like behind the glass door, before the lightning talk block, during the talk before. And we'll sort it all out, and yeah, see you then. All right, our next talk is integrating Nix and Bug2 for fun and profit. Let's welcome Claudio.
Yeah, hi everyone. My name is Claudio. I work at the Scalable Builds group at Twix, which is the OSPO of Modus Create. And today I'm going to talk about how we integrated Nix with Bug2. Since also yesterday there has been quite a few people that were interested in scalable build systems like Bazel, I thought maybe it would be a good idea to make this session a bit more interactive. So if you have any questions during the talk, just speak up. I try to remember to repeat the question and answer it. There will also be a demo session, so I'm trying to keep this a bit hands-on. All right. First, a bit of background for the motivation. we are working on a client project for Mercury, which is a company in the US that does provide banking services, basically. So they've got, we heard this yesterday already when you've seen that. They have a big monorepo with quite a large share of Haskell code, and they're currently hitting the limit of like the native build tool. When deploying stuff, it takes a long time. So yeah, developers have to wait for CI to complete, and they get a little bit unhappy. So we want to bring them back the happiness, right? So, for instance, when developers switch branches, the native tool, which is currently Cabal, is going to rebuild lots of stuff unnecessarily. It's not cached, and so we are trying to improve that situation, right? That kind of work is a collaboration. So we are working together with Mercury, obviously, with Ian, who is the lead of the whole operation, and we also have some colleagues at Twix that are from the compiler team, which are providing patches for the Haskell compiler that we need when integrating with the build tool. Then there is also Andreas and myself on the build team, and there are also some people from Valtype that are involved into this. About the code base, it's, as I said, it's quite large, over 1 million lines of Haskell code, and Haskell is quite succinct, so that's quite a lot. We've got a bit over 10,000 Haskell modules, and we do use Nix already in the project, so that's kind of the starting point. We are currently on an old version. We have that the GHC package, that GHC compiler is heavily patched. We have a few patches to fix memory problems, and we do also have a few patches to extract the dependency tree, for instance, of those Haskell modules, which we then are able to consume for the build tool in order to carry out build actions and actually produce artifacts. And they also use the Haskell libraries from Nixpkgs. They are not using Haskell.nix. And we are using Flakes already, so yeah, that's that. And there is some kind of code generation going on with some TypeScript code, so it's kind of a polyglot approach. You have some Python code and then TypeScript code in the repository as well. So we ask ourselves, or the question was, what kind of build system does cope with a kind of scale of the Mercury code base? There are a few hundred developers. I'm not sure how many exactly, but there are many people working on the code base. There's constant change, and we are going with Bug 2. So Bug 2 is a fairly new build system by Meta. Its punchline is fast, reliable, extensible. It's in the similar realm of Bazel. Basically, it's a successor of Bug 1, which was also kind of a Bazel clone. But this time, Bug 2 is a complete re-implementation in Rust. It is also using Starlark as a configuration or as a build language, which is kind of a Python-like language that has only a subset of the functionality of Python. For instance, usually you cannot just read files or something like that. So and you cannot do loops and you cannot do recursion. So that's kind of stripped-down version of Python. Bug2 also supports distributed builds. That means, like Bazel, it has support for remote execution. And internally, they use something else, but they also have support for the RBE protocol. That's the protocol that Bazel uses. So it's able, we are able to use any RBE services that are available. And it also supports distributed caching. So there's a cache that you can leverage for each developer. So, and this is where we are hoping to gain the most benefit from, because the project is built on CI, the cache is populated, and when a developer is starting his work, then they will find themselves, with all the new changes that have happened during the last couple of hours. And usually when they check out their code and something like at the bottom of the dependency tree changes, everything that depends on that needs to be rebuilt, right? So basically, with that many developers working on the project at the same time, that happens every other day, basically that you have to rebuild the whole world, right? So, and we want to avoid that. We want to have an up-to-date cache so that every developer can profit from the cache. So when they check out a new branch or rebase their work, they don't have to rebuild the world all at once, or like every developer that kind of, you can do the math, right? If there are 100 developers like waiting for 10 minutes or so, when needing to rebuild stuff, that's going to cost you quite some money, right? So yeah, that's kind of the reason for we are reaching for Bug2. A word of, I wouldn't say warning, but Bug2 is fairly new, as I said, and there's currently not a released version yet. So they are still working on it, and probably when Meta feels it's ready, then they will release it. They are currently releasing, they have a fixed release cycle, basically where they build just the tip of the master branch or the main branch, and put this out as a pre-release on GitHub, so you can download it and try it. And since that the build systems a la carte paper was mentioned a few times yesterday already, one of the authors that from that paper is actually working on the Bug2 build system. So that's Neil Mitchell. All right, so basically this is how we integrate Nix with Bug2. We have a few simple rules that we use. You can see that's kind of we are just calling the package rule from some Nix BZL file, and what this does is it calls Nix build. It uses the flake at the given path, and it creates a symlink. As a result, it just as the output, the default output is just the symlink to the Nix store, but it also wires up the run info for the binaries. That's kind of something that you can use in depending rules then in order to refer to those specific binaries. Relatedly, there is some prior work for Bazel, for instance. For Bazel, there's roots Nixpkgs, as we've heard, which is also maintained by Twix. And there is a rule set for Bug2, but unfortunately, we cannot use that. I just wanted to mention it because it was also a good source of inspiration for us, since this rule set first of all, it does not yet support flakes, but that wouldn't be a big problem. But it's also a replacement for the standard rule set that Bug2 provides. So you cannot combine those two. You have to replace the standard rule set with this one, and we cannot really do that because we rely on like the Haskell rules that are not implemented in those this Bug2 Nix repository. So yeah, with that out of the way, I just want to introduce a bit of terminology, or like the organization of a typical Bug2 project. Bug2 is organized in what they call cells. Like Bazel calls this repositories, but just want to mention that Bug2 does not have like something like repository rules or something like that. That's not possible. But you have these sort of cells that you can manage basically manually. You usually these correspond to directories in your project, except for the root. The root is the root cell is the root project. And then you have the prelude. That's the standard rule set that Bug2 provides. You can either use the bundled one, or you can vendor it into your project. Then there's the toolchain cell, which is important because whenever you need to build something that is like, say, you want to build a C++ library, that C++ library, or more concretely, the rule that implements that compilation implicitly needs a C++ toolchain, right? And how it's done in Bug2 is that it just refers to the toolchain cell and to a specific label or to a specific target in the toolchain cell, and you need to wire this up somehow. So you need to provide that toolchain, and also for the Haskell toolchain, you need to provide that toolchain. That also gives you some kind of customizability, because you can just exchange the toolchain, like in your configuration. Maybe you want to have different toolchains. You just switch the toolchain's cell. You can completely replace it with something else. Or you can alias them. So depending on the for cross-platform builds, maybe for instance, that would be a use case. You can use aliases in order to switch and select on like the platform or something to switch the tool chains. But eventually, these are just fixed names or fixed labels for that you need to provide. So when working with Nix in this regard, we want to provide those toolchains with Nix, of course. Our current project is using a separate toolchains flake. So we add a flake to the toolchains/Nix directory, and then we wire that up like we extract, or we use the GHC package from the toolchains Nix flake and expose it as basically inside of the toolchains Haskell target. Similarly for the other toolchains too. So, but toolchains are not the only one. At the end of the day, these are just binaries, right? So you need more than binaries. So we also need some packages, for instance, or especially Haskell packages, Haskell libraries. The usual function you could use from Nixpkgs is GHC with packages, which is usually provided by the Nix shell. This function, what this function does is it gives you a complete GHC environment where the global database, the package database, is provides basically all the packages that you want. It's kind of monolithic, right? Because if you want to add another package, you add it to the Nix expression, And then before you can do any builds with that, it has to be compiled, it has to be downloaded. So for us, this means, because we are, as I said, we have patches applied to GHC, and we change GHC quite often, I would say. We always need to rebuild all the packages, right? So if you would use GHC with packages, we would need to rebuild all of them before we can even start to call the compiler. And also this is out of control of Bug, so Bug has to just wait until that's done. So we actually reach for a different solution. We want to have it's laid out that so that Bug2 is in control of building the Nix Haskell packages individually. So that should give us some fine-grained control over our Haskell dependencies. So and this is per target basically. If you imagine as a developer just is working on a simple single component, he doesn't care about like dependencies of other components that are not in his dependency tree, right? So with this. This was our vision, and with this, it should be it should be possible to work on a component and just rebuild only those Haskell libraries that you need, nothing more, right? So, in order to do that, Bug2 has a nice feature that is called dynamic actions or dynamic dependencies. So, as is the same with Bazel. The dependency tree is static. So basically, Bug2 also loads like the information from all your build files into a tree. So one target depends on other targets, and you get those DHE, those DAGs basically. But when evaluating the target's rules are evaluated, and those rules are able to create many actions, right? So, for instance, if you're building a C library, those C library probably has some sources for every C source file is going to be compiled to an object file, and eventually those object files are linked to a library. So that these are many actions that need to be run. Then you have second, like say, binary target that depends on that library, that also has some source files which are also compiled to object files at first. This can be done in parallel, no problem, but eventually the linking step needs to wait until the action of the library rule is done, and then it can link. So that there's kind of a very fine-grained action graph that is produced by evaluating the rules. Now, in this case, there's something with Bug2 that it provides those dynamic actions. So inside of that dynamic, inside of the action graph, you can actually have special actions that are able to depend on an output of another action, and inside of the implementation function of that dynamic action, it is able to actually read the file, usually as a JSON artifact, or JSON as a JSON. Usually it's a JSON file, and it can inside of that implementation can create other actions. So that's kind of the dynamic part, right? So you read, for instance, a dependency file, and you know, okay, how your dependencies are laid out, and you create actions in order to, traversing that dependency information, and then you create new actions based on that information. Related to Bazel, this usually would use Gazelle in this case, basically, which would then also like understand your basically, it understands your language. There are different plugins, and with that information, it just actually changes your build files, right? It modifies your build, and that was something that Mercury did not want, because with Haskell and Haskell modules, they have a large package with a few hundred modules, and if you look at the bit file with Gazelle generated dependency, this is no fun. All right, so that's kind of the thing we were looking for. So in order to do that, however, we need to do some preparations. For instance, or in this case, we need to have, in order to be able to use the Haskell libraries that are provided by Nix, each of those Haskell libraries needs to have a proper package database. So we can pass that on to the GC invocation. And we are doing that in, apply this kind of overlay to all the Haskell packages in the Haskell packages set for the current compiler that we are using. So yeah, that's problem solved. Another thing that we need to do, and that's a bit more, I hope you can read that. We basically need to be able to not only refer to the packages that we depend on, but we also need all the package DBs of the libraries that that these Haskell packages have as dependencies. For instance, if you say you have like a servant OpenAPI 3 package that you're using, then this package depends on servant on OpenAPI 3 and on servant, and you don't want to like manually specify all those packages. So we need to compute the closure of all the Haskell packages that are libraries, and provide this as an kind of attribute in the packages. Flake. It's not clear if that's a good idea to put it in this place. If you have any suggestions, I would be welcome, because now you cannot really show this flake anymore because it's not valid, because like the flake expects does not expect a kind of it expects a derivation there, not something like this, right? So what we then do inside of, in order to gather all of these dependencies inside of the build system, we call NixEval, basically inside of buck2, right? So that's kind of gives us a list of Haskell library derivations, and yeah, that's not too bad, right? I would say. Then we are going to feed this into Nix derivation show command, which gives us an drv.json file, basically. So, and this is exactly the dynamic input for our action, for our dynamic action, and we are able to look into those dependencies and create actions in order to build all those different derivations that are needed for any of those top-level Haskell libraries that we depend on in our project. So yeah, that
Your
was.
time is more or less up.
Oh yeah, right. Really quick.
You can use the buffer time for your demo or for questions, however you like.
Yeah. Let's see. We have. Does it work? Yes. Let's build it. Okay. Typing is hard when you don't see it. Okay. Okay, now it's everything. Let's just have a look at the project a bit. You can look at the targets, there are quite a few. It's when I clean the project, the bug2 daemon is killed, so needs to start a new one. And usually that should be quite fast. Yes. We can also have a look at the dependency tree. So that's kind of it's just a small project for demo purposes. So we have like a few components, a few targets, and that's built like in order that you see that it works. Like let's just build the backend. And as you can see, there are lots of numbers fly by, basically some Nix build actions, and that's done. As you can see in the graph, the backend or the Spectre API depends on the Spectre generate target, and which in turn depends on the backend API. So that's kind of using the output of or the definition inside of the backend model to define an Spectre API schema, and that one is used by the command line interface, basically, right? So we can try to build like the Spectre generator, and as you see, hopefully there will be new Nix build commands that are run. Yeah, that was probably too fast, but we can see like log what ran. Quite a lot. Yeah, you can see it in the first line. There's the Nix build index pro functors and so on. So as I explained, this is this is exactly the property we were aiming for, to have really fine-grained control over the Haskell dependencies, and this is what we achieved. Just a few next things that we have to do is like we would like to publish our rule set at some point, make it open source. We are working on upstreaming our changes to the bug2 prelude, and we also need to face the challenge of remote execution with Nix, like with Bazel. Yeah, I hope that convinces you a bit that the combination of bug2 and Nix matches is a match. So only questions for like 20 seconds.
I'm not sure if we have time for questions. Maybe a very quick one, but.
If there's any, maybe.
Okay, there's one. So you're lucky number one.
So it seems like you worked a lot with different build systems, like of this type, like these cloud build systems, and I'm wondering what you would say, how compatible or incompatible are they? What's your experience with working with them and their interoperability? What would you say about that?
Good question, but I would say all these systems, like I've worked with Bazel a lot, and also with bug2 now since the beginning of the year, and I would say they are fairly comparable. I mean, the same concepts. Just bug2 feels a bit nicer, like they have a better UX, and also they feel a bit snappier, like the startup times, which is no wonder when they use Rust instead of Java. So yeah, other than that, there are many different, many similarities, I would say. Like from the internal structures, like also from the idea of an analysis phase and an execution phase, and yeah.
Okay, another round of applause for your speaker.
Is there some...
Que te las pase yo otras.
Okay, our next talk is Learning to Nix, our summer of Nix experience. Let's welcome Enric and Alberto.
Hi, so welcome to our talk. I'm Enric.
And I'm Alberto.
One day I was procrastinating, of course, and browsing the discourse forum as a newcomer to the Nix community. And one day I found a post that basically said that you could get to learn Nix, improve the software, free software ecosystem by improving their packaging situation on Nix, getting to know other Nix members, and getting paid for it. I mean, it's like a dream come true. What is it? Well, it's the Summer of Nix program. And it's a result of collaboration between the European Commission through the NCA program, the NLNet Foundation, and the NixOS Foundation. In this program, the NLNet funds projects. And these projects need to be packaged by Nix. Then the NixOS Foundation organizes mobs, which are teams that work more or less in a mob programming way, with the aim of teaching Nix for people through a mentorship program. Our team was mentored by Jack Lightcap, who unfortunately is not present here. Maybe Abdullah is, although he might have pretty severe jet lag because he came from New York yesterday. Roland over there, who gave a talk yesterday about poetry to Nix, Alberto, and yours truly.
So we want to talk about the different projects that we were working to learn about Nix during these days. First of all, we talk about lib25519. This one was a crypto library that it was to implement the curve to 5519. And in order to be able to packetize this project, we also need to packetize those libraries, like libRandomBytes to make random numbers, a libCPU cycle that it was mainly focused for benchmarking and stuff. This project was really, really interesting because we need to dig into the cross compilation, because one of the key aspects of this part, it was like it must be worked with different architectures as well. And they were working with assembly code that it was be sure that it was working as it was expected.
The next project that we worked on is IDEA. IDEA is a suite of platforms that aim to improve the situation of open hardware design through making it easy to share and reuse open hardware designs, and also to integrate with tools such as KiCad. In our involvement with the IDEA projects, we introduced Nix into the CI systems. And we also created flakes for every sub-project of the IDEA umbrella. It basically consisted of integrating Python and JavaScript building processes.
As well, we were working on Ice Studio, that it's a tool mainly for start working with FPGAs, with the ones that are open hardware. And the initial approach was because there was an app image. Actually, the first approach was applying that app image into the Nixpkgs, but while we were learning, we understand that the right way of doing it in Nix, it was doing it from source. So we, instead of using that app image, we were able to build from the source and integrate it into the Nixpkgs from the source.
And finally, one of the last projects involved NitroKey 3 firmware. In this project, we basically continued the work from previous Summer of Nix iterations. And we were, our task was getting Nix to build the NitroKey 3 firmware projects. They are built in Rust, so we had to use the Rust platform and the different cross-compilation facilities. Then the way that we inherited the project was from a repo with a flat.nix, but we wanted to make sure that the results of our work would live in Nixpkgs.
Yeah, so during these projects, we start learning a lot of experience. First of all, and one of the most important things is that we learn in Nix about other contributors. So we try to learn Nix in the way of the other users use Nix. That was using the Nix pattern that most of people use. Also, and one of key aspects is we try to choose some non-trivial projects that we consider, because at the end, the main goal is we need to learn how to use Nix, how to packetize Nix, and since we have someone that helps us to make it easier in that case, it was
something really interesting. Also, since these projects are not trivial, also they usually have a lot of contributors, a lot of people. So also during this summer, we were able to talk and communicate with other long-time contributors that were in the community, not just in Nix, but also in other open source projects. Also, we start gaining enough knowledge to try to understand and be responsible of new packages at the end, because we understand indeed what we did. So that is the main idea. And something really interesting for me is that we were using also open source tools to communicate between each other. For example, during the summer of Nix was the first time that I was started using Matrix or Jitsi for communication between us. So, and also different tools for developers. And we gained this experience not because the projects are not trivial, and that's make us find nice rabbit holes that we dig into it.
So one of the first rabbit holes that we fell into was cross-compilation. Specifically, for instance, for lib25519, a low-level library, it could kind of cleanly build on native ARM. But we wanted to make sure that it could also cross-compile, not only to try when you don't have an ARM machine ready, but also to speed up the building process too in some cases. So in the case of lib25519, we could learn about all the different options that you can pass a configure script, like configure platforms and so. For that, we had to study the building scripts of lib25519, which basically revolved around a Python script that actually didn't follow the auto source conventions. So we had to make accommodations to make it very easy to pass options to that script. Then also we could learn a lot about the different devs that are available in Nixpkgs, and also how cross-compilation interacts with them. For instance, we could try cross-compiling for ARM with LLVM or with GCC, and then built on RISC-V for ARM with LLVM. So we got to try all the different combinations and the different things that we needed to change in the Nix. I mean, in the derivations. For instance, the places where you list the dependencies, and some strange cases where we couldn't reproduce errors when we had OpenSSL defining both native build inputs and build inputs at the same time, which was a little bit unintuitive.
Yeah. So also there are different projects that we were working, not just libraries, but also GUI applications, ones that are web-based or they are in your system. For those tools, most of the time they were using some kind of tool for building like Poetry, Grand, or NPM. But instead of trying to do everything from scratch, we decided to use different tools that actually the community are in development stage. So we start using, for example, Poetry to Nix, or the derivation of NPM that is actually into Nixpkgs. For Poetry was really, really straightforward. It was really nice implemented. And also something that was really useful is that one of our colleagues was helping us a lot because he was working a lot with Poetry to Nix, and so as that in most of the cases, you just need to override the dependencies because maybe the version, it doesn't match actually what you need. In general, we can say that Poetry was really straightforward for that cases. Also, it was pretty similar to the NPM, like 90% of the errors were about dependency versions, and just by overriding, you have almost everything in your own. But the most problematic one was Grand, and it was because there were any tool actually implemented to using Grand into the Nix. In order to do that, we need to figure out what they are doing with the Grand tool, see that they actually were downloading dependencies while they are using, so we need to bypass this and do it previously. And let's say we are also very happy with the result because also the other contributions to the project were accepting our pull requests very fast, very easy, helping us if we have any problem. And also,
And another rabbit hole that was quite interesting, and particularly for me, was remote building. In my case, well, in mob programming, you are supposed to be on call when during the mob programming sessions. So you have to share the screen in a call. So I mean, you have a video for other people. You have to share what you are doing, and also sometimes you have to run the actual building of the packages, and that involves a lot of resource consumption. In my case, because I was developing on this laptop, I didn't have that many resources to spare, so I had to rely on remote building. I learned quickly about the builders option that you can pass to NixBuild, and I was very happy, and I'm very thankful for making such a seamless tool to work with different builders and having so many different options to control priorities for builders, and yeah, the different options that you have for seamlessly building remotely on other machines. That's like a sub-rabbit hole of this. You need to become familiar with a trusted users list, because when you want to use these facilities, you need to be in it. So then you need to also understand the security implications of being in that list. Otherwise, then you don't benefit of these substitutions. Then to actually provision the remote machines, I'm very thankful for NixOS Anywhere. I could learn a lot from it, and also I made working with remote builders a lot easier, because I could provision without almost no manual steps.
Okay, and one of the most interesting aspects for me was when we are dealing with optimization flags. And that's because when we are working with stuff like lib25519, that is a cryptographic library, do you expect that the developer knows a lot of which kind of optimization their software needs? And this is because in Nix in general, they have a really amazing flag optimization set by default, because they try to guarantee performance, and also they try to guarantee security. And that's very important. But in that kind of libraries, do you expect that maybe the developer already know that this kind of performance optimizations exist, and they don't choose for some reason? That's why we decide for something critical like cryptography, use the default ones. To be able to do that, we need to dig a little bit into how the Nix debug works to figure out why it wasn't taking the one that we want, and how to remove the other ones. Also, for that, we were using ObjectDump mainly because when we have the binary, we were able to just looking if all the flags were set successfully as we wanted. And the overall idea of how we do that, it was like taking all the flags by default, remove it from the actual flags, and just take it the one that they are useful, and also at the end the ones that the developer told that they are the important ones. Also, that gives us a chance to modify if we were using clan, for example, as this is devenv, to add additional flags that they say by default. And also, in order to be fast enough, we need to cache everything, because at the end, if some software takes at least 3 minutes per time to build, and we were like doing changes quite often, we need to not try to build that much. So we will start using caches to start cache most of the binaries, so we were able to swap between users and not need to wait as much as possible.
So in other words, we learn a lot of different aspects around building on Nix and for Nix. But some of expectations that we had before starting the program, and then the results after, these expectations were in some way broken, but not in the bad sense, of course. For instance, I was expecting a very strict mob format, like a strict mob programming way of working, where you have a very hectic schedule of turning to the next person just after 5 minutes and not getting enough time to soak in the information that you're having or to actually try different aspects when you're building these packages. So what we actually did was settle in a more relaxed mob format, actually. We worked around 30 minutes each person. And then after a while, then we exchanged places. And that guaranteed that everyone got a fair chance to learn about the problems that we were having, of reproducing the same problems. And also that guaranteeing that everyone was on the same page, especially if another day somebody couldn't make it to the call. Then one fear that I particularly had before starting the program was documentation. I had the false impression that the documentation in Nix was bad. What I learned is that there is a lot of documentation, and maybe what in some ways can be perceived as negative is a hard aspect to actually finding the documentation that you need when you need it. After our involvement in Summer of Nix, we actually gained a lot of experience with the documentation that is already present, and we know our way now to find the documentation where we need, and when there are gaps, now we know where to look for, so that we can be more helpful to the community too. Another expectation that I had before starting the project was that since all the projects were funded by NLNet and stuff, they would be super enthusiastic with our efforts of packaging them. However, it wasn't always the case. There were different levels of enthusiasm with upstream, and in some cases we got feedback within minutes. We would submit PRs to upstream, and they would be merged in no time, and with super positive involvement. In other cases, we were even asked for almost apologies because we didn't ask for permission to package the project. In another case, we wouldn't hear a response or we didn't have too much response to our PRs.
And also, as we mentioned earlier, I think one of the core aspects is that we're learning from others. At the end, we were people from different backgrounds, people that was more into hardware stuff, people who were more in software, but at the end, we were learning one of each other, and will be silly, but at the end, one was using Emacs, or Beam, another one using Elix. But that's helped you understand how other people's workflows works, how you improve your ones, and also understand a little bit things that maybe you think that you know it in some time, but seeing in a different way, do you see that maybe you are not right? And another aspect that we see is that at the beginning, since we were 5 persons, we say, okay, maybe packaged software will be really fast. There are a lot of people that is working currently, but that wasn't actually the case. I remember the first day say, yeah, maybe we can package this software in one day, this one in another day. But when you start finding those rabbit holes that we previously mentioned, we say that maybe that was not the case. It was also was the good part because it helped us to understand and dig into the Nix internal Nix aspects.
To finish our talk, we would like to give a couple of tips to the future Summer of Nix editions. One thing that I found lacking in this edition of Summer of Nix was actually getting to know the other members. In total, there were some dozens of participants, and we were just one of the teams. And we didn't get we were in a matrix room, but maybe I would have missed I wouldn't have missed a call with them to get to know them a little bit more personally. I would expect maybe future editions to have more communication between teams. And one of the things that I think could be achieved is to leverage the different teams to, for instance, to review the other team's PRs, or at least give like a preliminary review. And I think that would apport several benefits. For instance, reduce workload on Nix package maintainers, and also to improve the to get everyone on the same page, and also get to know what other teams are facing.
Also, to sum it up, we want to mention that the summer of Nix is not just we packetize 30 packets or something like that. The main idea we want to share about this is that's make new contributors being inside of the Nix community, people that want to keep improving the Nix ecosystem, be here in the community. So we want to say thank you for all the people that is organizing this kind of stuff and try to promote that following years keep doing that kind of stuff.
Yeah, I'd like to reiterate the thankfulness to everyone who organized it and everyone involved. And yeah, in summary, it wasn't just 30 packages created from our part. It was also 4 new Nix community members who gained a lot of experience. So thanks to everyone involved for all the help, to Valentin for organizing it, and Alnet Foundation. Yeah, so thanks everyone.
Do we have any questions? Okay, I think we're good. And well, let's thank our speakers again. All right, our next talk is about llama files plus RAG. Let's welcome Jose.
All right, so this talk is long, it's 45 minutes, and it's about multiple things at the same time. Normally, when you go to a talk, you want to know, what is this, and does it work? And hopefully I'm going to be able to answer those questions. But there is more to it. There is a little bit of a worldview intermixed in the talk, and that may be too much to ask in the time that we have, but I'm going to try to communicate the worldview at the same time as I communicate how I did what I did. All right, just to get a feeling. Oh, one important thing. I'm going to need your help. At some point in the talk, I'm going to show code, and I'm going to need people in the audience to talk on the microphone and tell me which code they prefer or whether the code works at all. Because I'm using LLMs to generate Nix code that may be totally nonsensical or maybe kind of okay. And we're going to compare the LLM that we train with the Nix documentation with a vanilla LLM that anybody can access on the web, like ChatGPT 4.0. So be ready for people with a microphone to approach you if you raise your hand, and then you can comment on which version of the Nix file you like better. Right? Okay, who here has already familiarity with implementing LLMs, open source LLMs? Oh, great. Okay, quite a bit of people. Right, and who here has done RAG? Okay, also quite a bit of people. Right, so then let's start, knowing what we know. Oh, what happened? Okay, one other important thing. If you want to follow the talk, and if you are going to read code, you better to follow the talk on your phone. There is a GitHub repo that is Quesada, my last name, /Quesada. This was supposed to be GitHub pages, but it didn't really work. Okay, now I'm getting some strange things here. Where did the presentation go? Interesting. So it's self-destructed. Okay. Right. So one core idea of this talk is that people don't read carefully or long things anymore. There is this gigantic growth of things like video, and not only video, but short video. Nowadays, if you ask somebody to read a book, they go like, are you kidding me? I'm not going to read a book. And this is people who ask you for help, like, how do I learn machine learning? You send them a book, and they go like, a book? What do you mean? This thing that I'm going to put on my hard drive and never open? So that's kind of the status quo, right? And that also happens to documentation. It happens to everybody. It happens to me. Often, you spend quite a bit of time fiddling with an LLM, trying to solve a configuration problem, only to realize that in the same time you could have read the entire documentation for the thing, right? So people don't read anymore, which is a problem. Who reads? Machines read. So basically, if you are writing long form nowadays, assume that the only thing or person that is going to read it cover to cover is going to be a machine, which is kind of interesting. And then this opens the door to LLMs. What are LLMs? Are machines that answer questions so that you don't have to read. But then you have to trust the machine. And that is kind of interesting, because very often they hallucinate and they have proven to you that they cannot be trusted. But still, we people do trust them, and increasingly more and more. Right, so just a bit of background about me. I run a company called Data Science Retreat that has been around for 10 years here in Berlin. We train people in machine learning, and companies too. We train the Volkswagen engineers that do the self-driving car. And to graduate, people have to present a project in public that they do solving a problem that somebody has with machine learning. So in a setting similar to this, people have to present a project that they have solved, right? Right, so what is this project? This is, yes, an LLM that is augmented with the documentation for Nix. And it's able to solve things like this. So this is a prompt, just asking it to configure Nginx. And given this, the reason that I mentioned that people don't read and so on, there are things to read in this talk, and this is why I gave you the link. So you can open index.html on your phone and scroll through it. Because sometimes you may want to actually spend more time one slide, and I keep going. So this is why. So given this prompt, the machine will produce something like this. And this is done on a machine that is local, that is not a monster server, and that doesn't have much hardware. So my original idea was to do it to run on this laptop, which is an ultra portable thingy, without the GPU. And I had quite a bit of trouble with that, so I ended up doing it with a desktop GPU, which is not very big, it's a normal GPU. But the idea is that you should be able to move the files here and then open them on your local machine that is offline. You could be in a tropical island, and you could still ask questions to the documentation and get exactly like we did here, right? So this is, what is this? Now, does it work? It's what we're going to see in the rest of the talk. And on top of that, I'm going to talk about something that is very important to me. The thing is, it's going hand in hand with the conversation that we're having about LLMs. And I think there is a tide change right now that is very beneficial for us individuals, and that I think we should pay attention to. Okay, so this is the attention span of humans looking at the screen. It's going downhill, as you can see. And this is one more reason why humans go to machines to get answers to questions instead of reading, because we cannot sustain our attention. And why is that? Because the companies, the big corporations behind the big LLMs are using them and everything else that they have, everything in the repertoire in machine learning, to capture your attention, to make you pay attention to things that you don't need to pay attention to, like ads. So ridiculous amount of compute power and brain power are invested in making this curve continuing going down and making you not able to concentrate and not able to focus. And this happens also when you write code. But there, something very interesting happens. There is more code now than ever. And I think that is a problem, because code simplicity is the one thing that helps us to have some guarantees to have secure code or to be productive. And I'm going to specify more about this. Why am I talking about security now? Because we're going to start a course on security, enhanced security retreat instead of data science retreat, but also because it goes hand in hand with the way we are going to think during this talk. The idea here is to come back to our origins and write code with less dependencies than before. And this idea of going to a remote island with a laptop offline and still being able to use an LLM is useful in that sense, in the way that you are going to disconnect. And having low compute power also forces you to think differently. And this is my belief, that a lot of what's going on in the security industry is not really being very helpful. So there is this conversation that, oh, now there is more code than ever, everything is big code, and this is hurting productivity, because you never understand everything, all the dependencies of the thing that you're building. And this is limiting what you can do. So here, the enemy is code that you don't understand, and code that you will never be able to understand, even if you had infinite time. Right now, when you're using servers, when you're using libraries, you're using millions of lines of code. So, story time. When I started learning programming, so I'm old, I started learning C, and C was the only language that there was, pretty much. And there were maybe a couple of books or 3 books. Then you took one out of the library and photocopied it, because I could not afford to buy it back then. And then you will go sequentially through all the chapters of the book, and that's how you learn a programming language. And that's not how we learn nowadays, right? First, there are 1 trillion different languages, all with a library that is ridiculously large. Then you have these things that nobody understands, which is GPUs with libraries to access the GPU that are closed source on top of it, but that are pretty complicated. And you start piling up complexity on top of complexity. And this is, you're never going to understand everything that you're writing. And this has consequences for security, because apparently every 1,000 lines of code there is a security bug, but also in terms of productivity. Because if you don't understand what you're building, then you're never going to be able to adapt to make a turn what you want to, because you're basically copy-pasting blind, right? Okay, back in the day when I was studying C, there was no Stack Overflow, there were not even books or other people to ask, or not even the internet. So everything you wrote, you understood. It may have been crap code, I'm sure it was, but you understood everything. And now you understand nothing. More so with LLMs. With LLMs, there's a level on top of Stack Overflow. In the 2010s, people will copy-paste from Stack Overflow. Now they copy-paste from LLMs. So long story short, you want code that fits in your head, you want code that you can understand, and you want to limit the number of libraries that you use to only a few. Here is an example. You need a cosine function. So the standard way to go, and this is also what ChatGPT does when you ask, okay, you need a cosine function. Import scikit-learn, 130K lines of code. Dependency, for example, NumPy, another 130,000 lines. That depends on some old Fortran code on BLAS, and so on and so forth, and much more. This is just for one function, and I'm sure you can already see what's coming next. This is the one function that you need. It's 6 lines. This is actually very verbose. This is what you needed. And you imported 1 million lines of code, right? And this is okay. Nobody blinks an eye nowadays if this happens. Right. So why do we do that? Sooner or later, you're going to be building on top of billions of lines of code, not millions. And then, of course, say goodbye to security, say goodbye to understanding what you're doing, say goodbye to productivity. So I'm going to talk here about people that I call simplicity heroes. Do you recognize anybody in those photos? I'm going to talk about them later, so don't worry if you don't. Okay, story time. NVIDIA in AI. These are Ian Goodfellow and Andrew Ng. Andrew News, how do you pronounce his last name? They are like super good guys in machine learning. So these guys were in a dorm in around 2010 playing video games and realized like, oh my God, things are moving so fast. Like the game industry has these cards that they use for accelerating 3D stuff. What if we use those for neural networks? They were neural networks researchers. They were working on their PhD around that time. Neural networks at that time were pathetic. They could recognize single digits on checkbooks in banks and so on. They could recognize faces, but they would get confused if there's a football next to the faces, and then the football is also a face. So pretty bad. Nobody cared about neural networks at that time, except one foundation in Canada, CIFAR, that gave money to these guys to keep doing their PhDs. Then these two guys said, well, what if we stop just playing whatever they were playing, maybe World of Warcraft or whatever was popular back then, and start trying to do the compute for the neural networks on the GPU. Okay, so they tried that, and then what happens is that the competition for object recognition at the time, this ImageNet, started becoming really good. This is when people started to pay attention to machine learning, or, well, the journalists will call it AI, of course. So they went from here, like a 25% error rate. This is the task is to classify 10,000 daily objects, like a cab, a car, a dog. So they went from 25% error rate to less than 2 or 3% error rate. That was like, whoa, right? This doesn't happen very often. And then everything changed in the field. Everybody started using deep learning. This was called deep learning. And this happened to NVIDIA evaluation, of course. Around that time, companies realized that there is money to be made here, and then started buying NVIDIA cards to the point where right now there's a shortage, and you can basically not buy them. There are entire countries that are in sanction, they cannot buy them because they are very valuable. Right, and this is what happened to ChatGPT in terms of compute power. So these are different versions of ChatGPT, and this is how many petaflops per second and days of compute, right? We are talking about 100,000 days running a machine of 1 petaflop. And you may say, well, what is a petaflop? I don't even have, doesn't fit in my brain, right? So this is a machine that gives you 1 petaflop more or less. It's 8 NVIDIA 4080 cards, and it costs around 40K. And this is the cheapest that you can get. Before that, you could not get a petaflop easily. So this is kind of scary because imagine 100,000 days of this thing running. Of course, people who run these things at scale, they have multiple of them. But it's something that you cannot do as an individual, and that's very important. So imagine a situation where everything that is interesting to do with computers is done in monster farms of these things, and you cannot afford them. You cannot use them. You cannot, well, you can use them as a user, but you cannot create the thing that they are running. This is pretty sad, right? We don't want that to happen. And on top of that, everything is running on the product of one company, NVIDIA CUDA, that has a terrible reputation in the open source world because they basically ship binary blobs that basically nobody can get to work with their kernel, and that has been live forever, right? And there are even memes about this. Right. So, yeah, you don't want to use CUDA, right? And it's not only because of this, because it's hard to install and because it's closed source and so on. It's just because it's a trillion lines of code. Who knows how many lines of code is that you don't control, that you don't know. So you put that into your machine. It could be writing letters to Kim Jong-un. Who knows? I mean, you don't know what it's doing, right? So you don't want that. Okay, so this is the realization that was dawning down on me that machine learning has become a game where you cannot play as an individual. And this is a terrible feeling to have. This was around 2018, 19. Let me show you one of the projects. This is my son, Leander. I took him to our office, and one of the guys there was working on this. This is a toy self-driving car that picks up cigarette butts. So it's basically a robot. So this was one Raspberry Pi running a very simple machine learning algorithm that detects the cigarette butts on the floor, and it will go and stop them. Okay, so this is a robot. So for a boy, maybe 8 years old at this time, this was amazing. This is his face when he's realizing, like, my dad builds robots. Like, wait until I tell my friends in the school, right? So at that time, I brought him there because I wanted to infect him with my enthusiasm of what it is to build things, and to build things that are this cool. It was like having superpowers. Like, I'm going to build a toy self-driving car that picks up cigarette butts. That sounds like ridiculously cool. And he could get it as a child, right? And that feeling of I can build things, and things that were completely impossible even 2 or 3 years ago, was kind of dissipating under the realization that now to do state-of-the-art machine learning, you need to have these monster things. And I don't have them. I will never be able to afford that, perhaps. So then all this idea of playing and building things like this, only corporations can do now, or people working for them. And often it will be closed source, and you will not even know what it does. So you will just sit there and consume what they feed you, which is a terrible thought, right? So this is, when I said at the beginning that I was going to communicate a worldview, this is it, right? This was my feeling like, oh, this is not looking good around that time. But things turned around. Apparently, other corporations didn't like that one corporation, not to be named, made so much progress with AI, and then they thought, well, let's do something similar and put it in the open domain, the open source world, and then people will iterate on it and will make it better. And that company was surprisingly Facebook, and they did. They did put something out that was kind of comparable to the closed source things that people are using and getting amazed, and that CEOs all over the place are now using and thinking, how can I fire people and replace them with this? So the interesting thing about these models is that they are very big, they are very hard to compute, but once the computation is done, they are just a bunch of weights. They are a bunch of floats that somebody can give you, and then you can put them in your neural network, and then you have the model. This is a first. So it's similar to the idea of open source for source code for programming languages, but in this case, you only get weights. And there are some people, Karpathy, who I didn't put in the photo of Simplicity Kings, but maybe deserving to be there, who says that programming now is done by altering weights. It's no longer done writing any kind of programming language. It's just weights the machine, and the machine learns those weights. So you program the setup so the machine can learn, and that's the program. The output is weights. Weights in a neural network like this. That is very interesting. Also, because you can publish those weights, and now there is a race, and all big companies that have the compute power are publishing things and trying to beat the other companies on benchmarks so that you think, oh, this company is doing a really good job. I'm going to buy their shares or whatever. For some reason, they are publishing weights now. Perhaps because they don't want one single company to run with it and then leave everybody else in the dust and have a monopoly. And those are companies that understand monopolies. Like most of them are monopolists, right? So they don't want that to happen. So there is a company called Hugging Face that does a lot of things, but one of the things they do is that they host these big models for anybody to download. So every time that, I don't know, Google comes up with a new fantastic model, it's there. And you can wget it and download it and have it on your machine. Which leads us to Llama. So you may have heard this word now a few times. It's just a model made by Meta that is doing quite well, and you've seen how many times it's been downloaded. It does better in some benchmarks than in others. But this was kind of the first time that an open source model was like good enough to look comparable to the closed source models that are probably optimized like hell. The companies that train them probably pay humans to correct their mistakes by hand for probably years of labor compressed into the shortest time possible. Plus, those big closed source models, they get your feedback. When you don't like something they do, you thumbs down or whatever it is that you use for that, and they learn from that, which open source models cannot do because they don't have that interface to the general public. Or if they do, you only get the updates when they release a new version of the model, which is slower. Okay. So now things have changed, and all this feeling that I had, like, this is not looking good. So this story that I wanted to tell my son that you can build things was kind of getting ruined. Now it's getting back because you can do things with a off-the-shelf GPU. This is a Radeon 7900 XTX that has 24 gigs of VRAM. With that, you can run pretty significant models and replicate the experience that you get from ChatGPT. And this is amazing that we can do that. This costs 1,000 euro. So it's kind of affordable enough. You could potentially get one in every home. This thing, it's 8 times this, and it's 40,000K. It's also running on NVIDIA. The guy who's making those is having a version with AMD and a version with NVIDIA. I pre-ordered the version with AMD, but then he had a lot of problems, and basically he doesn't recommend AMD anymore. But AMD is kind of a sleeper. If they put together what they have and they play this game to win, they could do well, because their cards are better in price-performance ratio than NVIDIA cards. The only problem is that the software is not great. So yeah. So basically, in running the thing that I'm presenting here, I waited for 2 days to just see segmentation fault, and I think it was because of the crap drivers that this thing has. But anyway. So yeah, very stressful times, like, oh, I have a talk and this thing is not running. Okay. Okay, let's start going through the people that I put in the first slides, right? Georgy Gergnanov. This is a monster programmer that wrote in C++ something that is doing the computation from the weights that you get from all these websites that I mentioned without using CUDA. So this is a few thousand lines of code, probably 10,000, I don't know, compared to CUDA, which is like a ridiculous, a very large number, right, that you will never know either. And ROCm is the same thing for Radeon cards, AMD. So this man, one man, could replicate the work of 2 monster corporations that have been working on the code for dozens of years. And of course, what happened is that this is the start history of GPT-3, which, as you can imagine, it's an important thing to look at as a benchmark. And this is what happened when he published his Llama C++, right? So red is Llama CPP, and blue is the actual Llama model from Facebook. So it grew past the model from Facebook. And the interesting thing is you can load any model. It doesn't have, the name is Llama CPP because it was designed for Llama, but now you can run any models. So the one that I've been playing with is actually from Google. It's Gemma something. So the interesting thing is that one man wrote code that fit in his head, really doesn't fit in my head, and did something that everybody thought was impossible at that time. And once you get that, you get other people that are demonstrating that this approach is possible. That this idea that only corporations can play this game may not be true, because of some people who are really good at what they're doing and they're taking this as their playground. GeoHot, this guy, he is writing a library that is much simpler than PyTorch and does the same. It's in alpha right now. He says that he's going to release it when it's twice as fast as PyTorch on the same hardware. He tried to get AMD on PerfML. There is a competition for performance in ML. And he, at some point, was facing the same problems that I face as well, that the software is not great. And I started bitching. I don't remember if it was on YouTube or on Twitter, probably on both. And then the CEO of AMD got in touch with him and said, okay, what do you need? We're going to make it happen. Just speak. And then they really started pushing this ROCm thing to a point that it now is starting to get interesting. He had a company called Coma AI that does self-driving car drivers on your phone. So you put your phone on, I think, on the back of the rear mirror, facing the road, and it can do self-driving for any car that doesn't have self-driving car functionality. on a phone. Then and not happy with that, he started a computer company selling computers that are 1 petaflop that you can buy. And this is the image that I showed you before. That's called a tiny box. Fabrice Bellard, you may know him. He's probably the closest thing to a god that you can be as a programmer. He wrote a C compiler in 2,000 lines of code, has rewritten JavaScript, and made it have a type system that is sound. Like incredible things. QEMU, FMPG, a lot of stuff like that. Also, a C programmer, low level, writing very simple things in 2,000 lines of code. This is the way, this is proving the point that you don't need to be a monster corporation with millions of lines of code to solve problems. Justine Taney, spelling error. Okay, so she took Llama CPP and improved on it, on the kernels that do the computation, and made it even more efficient, which nobody thought was possible. But this is also a demi-goddess of programming. She wrote something called Cosmopolitan, which is a glibc equivalent library that lets you run your code on any operating system and bare metal. So basically, you ship an exe file, and you can run it on every platform. So basically, things that you would think are impossible, or you can run it without an operating system, which is kind of ridiculous. So this proves that you can do much more than you think. You're an individual. What are you going to do against Google? Well, Fabrice Bellard rewrote the crown jewel of Google, V8, like the JavaScript engine, perhaps, and did it better with a sound type system. One man. This woman is doing things that everybody thought were impossible. And then this Llama CPP inside Llama files, you can send somebody an executable, they double-click it, and they get a chat talking to a model, because one of the other things she wrote is a Red Bean server. It's a server. So everything goes inside one zip file, and off you go. Compare that with the jokes that we had about installing NVIDIA and all the complexity of CUDA and so on. Just one executable, that's it. So this is what I use for the thing that I'm going to show you next, right? So this is just to set up the stage. So what is retrieval augmented generation? When you download one of these files with 4 gigabytes of weights, it's a general model. It doesn't know anything about your topic. In our case, we want it to understand Nix documentation. For that, you want to download the Nix documentation and train the model on it. Problem is, you cannot train it because you don't want to run the computation again that got this 4 billion, or no, in this case, 8 billion weights. 8 billion weights, so 8 billion floats. You will need to recompute to represent the new knowledge. We only care about Nix. No, you cannot do that. But there is a method that lets you do the same without having to retrain the model. And this is called RAG. So you basically take your documents, cut them into small pieces, and how small, that's a parameter in the model, and then represent them as vectors. This is called embeddings. How? You run them through the LLM, and then you get a vector. Let's say that in the wiki for Nix, it says something like, Nix makes trivial to share development and build environments. I mind that this is cut. This is cut and passed through the LLM, and then you get an embedding, and then you put that into a database. This database is then going to be used to run nearest neighbors on the space of those vectors, using the cosine similarity measure that we saw in 6 lines of code in C, to produce a context that you're going to feed to the LLM. So now you, the user, type a question that is, is Nix good to share development environments? Imagine that the general model doesn't know anything about Nix. Doing RAG, this chunk of information that is coming from the Nix wiki gets added to the question, and a few other chunks that are the most similar to the question using these nearest neighbors using cosine similarity. So then the question gets augmented with all these other chunks of knowledge. And then that prompt produces an answer that is more precise than the answer that you will get otherwise. That's the whole point of using RAG. So what I did was to scrape all these sources. I actually didn't add one. There's also a book, NixOS in Production, that I really like by Gabriela. It doesn't matter. I added that too, and that's a fantastic book. I recommend it. I have this on GitHub, but I'm not going to make it public until I remove that book because I don't want to put into the open domain something that is a paid book, right? So whenever I figure out how to do that, it will be public. So this was a total of 150 megabytes of text. To get the text, I ran everything through a terminal browser, Lynx, and then when Lynx minus dump, you get the text version. And it's much easier than doing beautiful soup or whatever it is that people do nowadays to remove HTML. So for a model, I use this Mistral 7 billion parameters. And that's a 4 gigabyte file that you can get from this company called Hugging Face. So you do wget huggingface blah blah blah.com Mistral 7b instruct, and then you download 4 gigs of a zip file that is a llama file, and you can already execute that and get a prompt, and you can talk to the model. How amazing is that? Now there's an indexing step that you saw. So the database is called Files, it's also by Facebook. And you normalize the embedding, so you pass the text. So you cut all the text in all these wikis and all these books and so on, cut them into small chunks, get vectors, normalize the vector. Embedding, when you see embedding, that's a vector. You normalize them and then add to the index. Then you have a database of vectors, and this database is designed to do approximate nearest neighbors, which is a very fast operation. Right, so benchmark, this is where I need your help. So can we pass the microphone around? I'm going to show code on the screen, and I'm going to show the prompt, and also the answer that NixDoc produced, that's the model that I trained, and the answer that ChatGPT produced. So I want somebody in the audience who can read Nix better than me to tell me if they are getting anywhere close to correct or not. So who wants to do first? So who wants to get the microphone and comment on the code, the solution that this machine produced? Nobody? I'm sure everybody in this room writes better Nix code than me, so I'm not going to do it. Okay, so we have a problem. Right. So first of all, does this code make sense?
Let's see. Typically, the URL wouldn't be just a single file, and you would need a. Yeah, but I guess it would work. It's not a fixed derivation, fixed output derivation. You have to specify. Yeah, it probably wouldn't work.
It probably wouldn't.
But URL needs a arc attr set, I think. And
right. But it's something fixable.
Well, you wouldn't put it as a builder. It would be that would be handled by the make derivation.
Okay, let's see what ChatGPT says. It writes more.
Right. This is This is better.
Okay. Okay, so ChatGPT 1, NixTalk 0. Okay, this is better. So this may actually even work, right?
Yeah. Like
Okay, this is benchmark 1. So 1 for ChatGPT, 0 for NixTalk. Let's try this one.
override a package from. Okay, to use a specific. Yep, we do that a lot.
Yeah, so let you read it.
I read the title.
Okay. So you don't need to read the rest, right? Okay.
It would take me ages.
So this is NixTalk.
Oh. No, there is no override atters.
It makes no sense. Okay.
Yeah.
How about ChatGPT?
Yeah, that's it. It does. I would override the name too, because otherwise the name won't appear in the. When you build it, it will not have the correct version in it. But it would do the trick, yeah.
It will work. Okay, so then 2.0. Let's keep going. Benchmark 3. Python 3.8 with NumPy, Pandas, and Matplotlib.
Create a reproducible. Okay, yeah.
NixTalk. I don't think we even have 3.8 anymore in the packages, but
yeah, a bit old, but no. The list of Python. The top thing is like that. That's not how you build a Python PyEnv, but it kind of gets close. And you would just need a really build env like this is no.
Okay, let's see ChatGPT.
Make shell, yeah.
This works. Okay,
that is
3.0. So far it's not doing great. But remember, ChatGPT is probably billions of money invested, and this is basically running on a desktop or a laptop. This is kind of amazing that it gets anywhere this close, right?
Yeah.
So it's good to know 3.0. Let's not keep going. I have 10 more benchmarks. Let's assume that ChatGPT does better. But I would love to know if at any point the one that I trained does better, because it will be kind of a miracle. But okay. So that's not great. I would have liked to have a model, made a model that somehow does comparatively with ChatGPT, but probably not. So what have we learned? That you can create a model with weights that are floating out there on the net. You don't need petabytes of computation. You can run the model locally, even potentially on an ultra-portable laptop. And this idea implies that you don't need to be a corporation to do things with LLMs, and individuals can play. So back to my son, right? So children nowadays, they have been born in a place that is full of machines that know a lot, and they know very little. They don't read. They don't know what files are. They only know apps. So they outsource their thinking to influencers and to LLMs that run in the cloud that they don't own, that they don't understand, and they have no power over it. This was my fear. Now I see a way out, which is code as simple as possible with fewer dependencies, code that fits in your head, learn how to think, distrust anything that you don't understand, and run your own LLMs locally, trained on a gold standard that you trust. And this is all I have for you. Thank you.
All right, we got a little bit of time for questions. I see a question here.
Amazing talk, thank you. Just a small comment, like you showed the computer box, which is basically a tiny box, and the real hero of this presentation was a GeoHot, aka George Hotz. Because he is building these things for 15K, it's not 40K. 40K is actually the big server.
Exactly,
So if anyone is interested in really, like the GeoHot is really trying to make you run these things at home. And he tried to do with the AMD, and then he failed. And of course, he went to NVIDIA for now. But he's like a really guy who is like has to be.
So I went for the NVIDIA one because it's 1 petaflop. The AMD card is not 1 petaflop.
It's a little bit not much, but anyway,
But I like the AMD better. I mean, I have an AMD at home, so
Thanks.
Yeah.
Just one comment, maybe if in the library of RAG elements, apart from the documentation, if you included Nixpkgs, your model will know much more about how to build Nix derivations. So that would be, I think, a next step for improving the model.
Sorry, I couldn't hear.
Yeah, so instead of not only adding documentation for your model, but also giving it the whole Nixpkgs.
Yeah.
So that includes, a lot of Nix definitions, Nix derivations that your model would rely on. So that would, I think, improve performance.
And Nix configs are on GitHub, all that. I was planning to add all of this, but I didn't have time, honestly. So it's a miracle that I got this far. So, yeah.
Yeah, I was just gonna pretty much build off of that, because from what I could tell from the RAG model, it tends to do something it tends to do it really verbosely, right? It the ChatGPT one was definitely cleaner code. It also had that problem of really arcane code that Nix beginners find really hard to understand. Whereas that one was really spelled out. Even though I got something wrong, I could totally see myself writing that code when I was starting out with Nix. I think if you were to put in more code and put in better documentation, which is obviously something that Nix has always struggled with, I think that one has a lot more promise than ChatGPT. I think it's just right now the inputs aren't there.
Yeah, and there's one more thing that I just realized. The prompts were generated with ChatGPT. So I asked it, can you generate example prompts? So no wonder it did better, Yeah. So we could do the other way around. We could ask NixDoc to generate the prompts for ChatGPT. Yeah.
All right, one last quick question.
I really like that you have hope in these times that we can do this locally, but isn't this hope a little bit flawed by the fact that the actual weights you're downloading still had to be generated with these huge? First of all, the servers generating these weights had to run CUDA. Just the inference locally doesn't use this, and also the open source model is not really super open source because actually the sources used are not open, and also the license has some interesting legal stuff in there. So, what do you make out of these restrictions and that the sources are not really open?
Yeah, thank you for the question. Very good question, very good point. It's absolutely correct that the people generating the weights are not telling you how they do it. And there is some magic voodoo there that nobody knows what they are doing. We don't know that, so we cannot really fully replicate it. In a way, we don't understand it. So the whole point of this is understand what you are using, right? We don't. But this is opening the door to open source LLMs. At some point, some other company will go we go full open source with everything. Because there is a competition now in the open to make these things work with open source philosophy. And that was huge, because before you didn't have that. And then when people start playing with these things and say, well, I'm going to try one of these 8 billion parameter things on a Raspberry Pi that I'm going to stick to a camera that I put next to my son who is sleeping, then things start happening, right? And I think this is overall a good thing. Of course, it would be much better if everything would be completely open source from beginning to end. We are not there yet. Yeah.
All right, let's thank our speaker again. To everyone who has a lightning talk, we'll meet in front of at the entrance soon. Please be there. We'll discuss all of the details about how the lightning talk block is going to work. Before the lightning talk block, at least 10 minutes before, please meet me out there. We can start. Okay, our next talk is monitoring your system using NixOS. Let's welcome João.
And hello everyone, and today I will talk about monitoring your system using NixOS. Let's go to the next slide. And I will talk about Node Exporter. It is a tool to export system metrics like CPU and RAM about your system, your computer. Next, I will talk about Prometheus and how you set up that on NixOS after Grafana. And in the last is how you can use that to monitor an application. Is a sample application. And introducing myself, I'm João Tales. I am an Elixir developer. I use Nix on my computer and for other personal projects. And I am Brazilian. Let's go. Starting with Node Exporter, here is the code example that you need to put in your Nix configuration. And it will expose in the port 90,000, or you can change the port. And here is a print screen about the result. I will show the code here and opening the result in a browser. Okay. Okay, here is the example in the code. And I am using the same example that yesterday is a Bitcoin node. Okay. So let's see it in action. So here's the example. So every time I update, I had some different data. Okay. And I am exposing it to internet for like during the presentation, maybe 1 hour later. And the code to expose, I use Tailscale to expose it to internet. The code is here. And that's it. Let's go back. Okay, next I will go to Prometheus. And Prometheus is a tool that gets the metrics that I exported here and the metrics that I will export on my application. And that is the code, the Nix code that I need to scrap from my Node Exporter. And I will show that too. Okay. Here is the code, the live. So I can get all the metrics starting with Node. And here I have a description. What is that metric? And okay, I can execute. Okay, now I will go to Grafana. Okay, Grafana is a place to see the graphics, like you can create a dashboard, import a dashboard, and go around. And here is the code example. And here I am pointing for Prometheus, but you can use Grafana with other tools. Okay, I will show Grafana. Okay, here is a dashboard of my node exporter. There are a lot of data. I imported that from the internet. There is a place, there are a lot of dashboards that you can import. It's very easy. About the import, I did it manually, but you can use Nix for that. It's possible. There are some examples at GitHub. And I think it's that. Okay, I will show here the code. And here is the code that is pointing to get data from Prometheus using the Grafana. So if you had other tool, you can put here, and it will be on Grafana too. And for example, you can have more than one Prometheus. And for example, this one is working on that machine, but you can have a Prometheus running on other server. So it will point for that. And yeah, you can have multiple Grafanas. And imagine you usually only need one Prometheus. For example, I have one Prometheus here, and I have the node exporter on the same machine. But if I have 10 machines, I will have 10 node exporters, but I only need one Prometheus, and each Prometheus will do a get in the route that return the data, and we will scrap it. Okay. Going to the next. Okay, the last one is how we can get data from a real application, because the example before is getting data from my computer. So this is the code that I added to my Nix configuration to get the data. I will show in the code. Okay, here is the example. So it's getting from, in the Prometheus configuration, it's getting from the Python application. So if I have all the application, I only need to add here and put the URL and port. And I will show the code that I'm running. Okay, so that is the code. It's a very simple code that uses the Prometheus client, and it is exposing on port 80,000. So if I go here and run that, I get the data. It's not exposed to internet. And here I'm running the application in python.app. And here I created a small shell to run the Python. It was my first time using Nix for Python. And okay, go back to slides. Okay, and for the last, I will show a dashboard with Python. I searched for a Python dashboard with all data like node export, but I didn't find, so I created a small example. I can update it with getting some data from the Python application. And that is it. And the code is on GitHub. You can check the latest commits. That is it, everyone. Yeah.
All right. Do we have any questions?
So the node exporter and the Prometheus are running on your macOS machine right now?
No, they are running on a server in Brazil. I'm using Tvix to access it. And I use it crops to deploy the code. So the code is on my machine, but yeah.
Yeah, okay. That was my question, because I was asking myself,
yeah,
what? He's running the Prometheus.
It's not easy to run.
Yeah,
yeah, that is a good question. That is something that I like to show that I was experimenting. Yeah, I created this shell.nix to run on my machine, on macOS. For now, the node export is working, but the Prometheus is not working. I need to create a configuration file So I need to figure out how to use the Nix code for that. So if someone have more experience in Nix, I think it's cool to run on my machine. For example, if I comment that, it's possible to run Nix shell, and I will have the node exporter running on my machine using Nix. Okay, and that is it.
Hey, thanks for the awesome talk. I saw your amazing talk yesterday as well on everything related to Bitcoin. And I was wondering if you use these two together in any which way, any amount of like Grafana dashboards linked in with any of the things that you're running through your Bitcoin node.
Yeah, for now, it was something that I want to do. There is a issue open for more than 1 year about monitoring in the Nix Bitcoin repo. So I think with that, maybe tomorrow I can finish that issue. So I need to fix things, but
cool.
In the way.
Thanks.
Hi, very cool. I don't remember exactly what you said. Was there some resource you found for Grafana dashboards, or did you just Google grep GitHub to find examples?
Yes, I think I can. Yeah, here is the search. I searched for Python, and I don't find a Python example, but.
So basically, Grafana themselves has the search board you're using to find.
Yes, this is the place that you can search for dashboards. For example, if you search for exported, there are a bunch of examples from Kubernetes, black box exporter.
Thank you.
Welcome.
We've got time for a few more questions.
So I was wondering, have you tried monitoring NixOS applications that run in NixOS containers at all?
No, for now I didn't test it, but I think it's something cool to do. I need to search more about it.
Right, because why I haven't really embraced NixOS containers is because every container is basically a small NixOS node with systemd and etc. And basically, you end up having a bunch of node exporters or service exporters. And I was looking at various sort of ways to aggregate that and not scrape each container. But yeah, I haven't found an ideal solution yet.
Yeah, if you have the port to open, I think you can connect. I connected for the application that I'm running. But if not, it's more dynamic. I don't know how to do.
Thank you.
Welcome.
Okay. If there are no more questions, I'd ask you to give another round of applause for our speaker.
Thank you.
Okay, our next and last talk before the lightning talk block is common GitOps for NixOS machines. Let's welcome Leo.
Hello, so I'm Leo, Nix contributor since several years now, and I'm here to talk about common, so GitOps for NixOS machine. I will start by apologize because there is now one more deployment tool in our NixOS ecosystem, so sorry about this. First of all, a few words about what GitOps is. There is no Wikipedia pages. I did not find any formal definition, but I found this website, gitops.tech. They propose a definition, and I will translate it in NixOS terms. So the core idea of GitOps is having a Git repository that contains all configuration, NixOS configuration file for all NixOS machines, and an automated process that ensures that all these NixOS configuration files are deployed on NixOS on your NixOS machine. I also note this kind of punchline. Someone is saying GitOps is a versioned CI/CD on top of declarative infrastructure. And they said, stop scripting and start shipping. How did I come to GitOps? Of course, with a shell script. So 5 years ago, with some friends, we deployed a NixOS server to host a Nextcloud instance. And it was running, and then we wanted to have something to automatically deploy our change to this instance, to this NixOS server. And we did not want to rely on CI/CD and stuff like this because we wanted to be autonomous. So we started to write a shell script that would be executed every 5 minutes. And what this shell script is doing is it checks out new commit from a repository, it verifies Git commit signature, and run NixOS rebuild switch if everything is okay if everything is okay. From the user point of view, to deploy a change, a user has just to push a commit to the main branch, and that's all. Of course, there is a review process and stuff like this, but the advantages is so autonomy. We don't have any dependency to a forge, and also simplicity. It's easy to set up, especially because you don't have any deployment secrets. This has been working really well for several years. And then I started to think if I could use this paradigm for all my machines, including laptops. But on my laptops, I don't want to have to wait for 5 minutes. I don't want to have to push to master to test a change. And this is why I started to work on common. So common is a NixOS deployment tool operating in pull mode. So it pulls the configuration file and apply it. It's pretty similar to the shell script I described it before. It's currently hosted on GitHub. I started it 2 years ago. And please note that the V1 has not been released yet, but I'm using it since more than a year on 6 or 7 of my own machine. So about the common feature, the first big differences between common and the shell script is common is able to check out code from several branches, especially for 2 branches, 2 different kinds of branches. It can check out commit from the main branch. In this case, only fast forward is allowed. This means a user cannot push force commit to this branch. When common check out a commit from the main branch, then it will run a NixOS rebuild switch. If you want to test a change, you can push your commit to a testing branch, and this testing branch has to be on top of the main branch. And in this case, NixOS rebuild, common will run a NixOS rebuild test. This allows you if this configuration is failing, you can still reboot your machine, and then you will go back on the previous version. It's also important to note that it's possible to push forward to the testing branch. Another feature is Comin is able to poll from multiple Git remotes. The first objective was to avoid a single point of failure. If one repository is not responding anymore, then Comin can fall back to another one. And there is a nice side effect, is that you can declare a local remote on your local file system. And in this case, Comin is able to check out commit every 2 seconds because it's really cheap to run a Git checkout on your local file system. So this allows to have fast iteration because you just have to commit locally, and then Comin will check out this commit. Some other feature is Comin support machine migration. Suppose you want to migrate an existing configuration from one machine to another machine, then Comin is able to do this with because he will check the machine ID before applying the configuration file, and there is more detail about this in the project README. It also exposes Prometheus metrics. It manages system profiles for you. Basically, currently, it will keep the 10 last deployed generation and remove all GC and remove the GC root for older generation. This allows you to run automatic garbage, an automatic garbage collector, and preserve your Nix store, especially on your servers. And finally, there is a Comin status command, and this command basically provides you some information about the commit which is deployed, when the last check occurred, and yeah, such kind of internal Comin information. There are a lot of planned features. So the first one is I would like to add the git commit signature checks, as it is done by the shell script. Some users are also asking for non-flake support. Currently, Comin is able to detect if a reboot is required, but it will not do anything. And it would be nice if Comin, if you could configure Comin to let it reboot the machine if it is required. For instance, when your kernel when you deploy a new kernel. When a deployment fails, currently Comin just do anything, and it would be nice to try to retry the deployment one more time, because sometimes the second time it can work. So, and then there is 2 other commands that could be interesting. The first is a Comin pause to stop deployments. For instance, now I would like to be able to run Comin pause in order to avoid the deployment during my talk. And another one is the Comin fetch to manually fetch a remote, and this could be interesting on a server. Suppose you want to test a change. Currently, I have to wait for 1 minute, something like this, to get to wait for the next checkout. And if I could run Comin fetch to immediately fetch the remote, it would be really nice. And I also started to work on integrating webhooks to let a forge triggering a remote fetch. Another last point is I'm also experimenting and thinking about a kind of centralized web UI to see the status of all my machine. And there's also some nice features that could come with this global view, but it's out of the scope of this presentation. So as a conclusion, now one really nice property is that I'm sure that all my own machines are always on top of the main branch. And this is something that I did not have with the previous tools that I was using. It's really easy to deploy a change on one machine or to all of my machines. Basically, I just have to write the change, git commit, and git push, and that's all. I have to confess it's fun to write, and that's also a good reason. The drawback is, it's slower to try a change. So because you have to commit, you have to push, you have to wait for the poller. But this is something I'm continuing to address with the planet feature. By the way, I'm still using the shell script on our community server, and I would like to replace it by coming in the next future. Thanks for your attention, and feel free to ask any question.
Any questions?
Thanks for the talk. So if I push the change to the server and then don't want to wait 5 minutes and then log into the server and, push the change to the Git repo and then log into the server and do a rebuild switch myself, what does comin do? Is there any, if it sees the server's already rebuild switching, how does it handle it?
No, comin will not. Currently, comin will not detect it. So you will have to wait. So if you push another change to the repository, then comin 5 minutes later, comin will check out the repository and run the switch to configuration.
Okay.
And this is actually what you are a bit you are a bit talking about reconciliation, and this is something that some GitOps tools are trying to address, detecting if there is a change on the system, trying to reapply the configuration. But currently, comin is not doing anything regarding this topic.
One more question. During the development, have you seen any similar tools doing the same, and what were their drawbacks in comparison to yours?
There is one tool which is pretty similar in the NixOS module list, which is called, I think it's auto upgrade. Basically, they are also doing, they are polling, now I think they are able to poll a flake, but before they were, I think every day, they were, I don't even remember how we use channel, but they were upgrading the channel and switching to a configuration, to the new configuration. But it's not exactly the same, because here you are pulling the whole configuration, and you also have testing branch and stuff like this.
Thank you. Another question? Sorry, I was late before.
No problem.
Awesome talk, awesome tool. My question would be, what is if I understood correctly, comin would run on the machine that is needing the upgrade and stuff like that? What is the setup process for me to, I have 5 machines, what would my steps be to get comin running?
Yes, so I can show you in the no, it's not a good screen. Is it better? Inception. So let's do it like this. So basically, you have to write this thing in your configuration. And what you're saying, you enable the comin service, and then here you have to declare a remote by using a name, a URL. And by default, comin will use an NixOS configuration that has the same name that your host name. So this is what you add this in your configuration, and then it will do everything under the hood. And then there is much more configuration, because I did not talk about it, but it supports authentication to Git repository, because maybe you don't want to make your configuration public.
Okay, cool. Thank you.
You're welcome.
Another question?
So a double question, if I may. My neighbor here asked about pull-based tools. The only other one I've heard of is called Bento, I think. Have you heard of it? And do you have a comparison?
Yeah, I heard about it, but I prefer to not talk about it. I'm not sure. I'm really not sure. I think Bento is taking a pre-built stuff. I don't think Bento is building the configuration on the machine itself. And I think Bento, you also need a FTP server or something like this. But yeah, I'm not. I never used it, and there is a lot of NixOS deployment tool. It's pretty difficult to know what they are doing.
Yeah, and the second question is, why haven't you replaced your Bear script with Comin just yet? Did you just not get around to it, or is something
No, because Git signature are not yet supported. If the forge is corrupted, then an attacker could inject what he wants in the server, and it's why we did not do it yet.
Thank you.
All right, let's thank our speaker again.
Thank you.
So now we have the last event, which is the lightning talk block. We might start a bit delayed. I'm gonna, yeah. Yes, I'm gonna ask the lightning talk people to come here. We'll sort it out, and after that we'll have our, well, just our closing. What do you call it? Closing talk, keynote, whatever. Whatever. Hä? Was ist vorbei? Was ist vorbei? Ja, aber wir haben noch mehr Zeit bis 20:30 Uhr. Okay. Okay. I think we can start. Yep. All right, this is our final block. I'm sorry for the delay and all the stress. I'm not going to introduce the speakers because I screwed that one up yesterday. You could just introduce yourself. Try to do it before I press play on the timer. Okay, I hope you're all ready. Don't get irritated by me snapping my fingers. That's their 1-minute warning. I hope you're all ready.
Does this work?
It works. It does. So, let's go.
Cool. Hi, I'm Nate, and I'm going to be talking about sprints. A sprint is a group of free software / open source people getting together to hack on something for a few days. They're very easy to organize. Basically, you book an office or a co-working space, and you post and choose a date when you want to do it, and then post online and invite people to come. That's like the basics of a sprint. You can also book a cellar, it doesn't have to be an office. And you can limit the amount of people to only a few, like maybe 10 is a good starting point, or you can make a bigger sprint. It's up to you, you're the one organizing it. Again, you just provide the desk and a good internet connection, and then people will come and hack on something. It's great if you can provide some food so people don't have to think about bodily functions and bodily needs. They can just focus on the code. And the NixOS Foundation actually has a budget for this. So if you're organizing a sprint, you can ask the NixOS Foundation to give you some money for food, to feed people. Oh yeah, and coffee. Do not forget about coffee. We need that. There are actually 2 Nix sprints coming up shortly. The first one is Tiger Sprint in Chiang Mai in Thailand. You can see the URL right there, tigersprint.org, accepting applications. And the second one is Ocean Sprint. This is the one that I'm organizing. I've been doing sprints for 15 years, so Ocean Sprint might be a bit over-engineered, slightly. The venue is a private villa on Canary Islands by the Atlantic Ocean, perfect climate, pool, lots of shade. We start the days off with a sunrise swim just to wake up. Then we rant about stuck pull requests during breakfast, which is catered, so you don't have to think about breakfast. You just come to the sprint venue and eat and rant. We pair up on issues. That's the main thing about a sprint, is that you don't work alone on something, because you can do that back home. You either convince someone to work on something with you, or you join someone to work on something. And that's kind of the best part about the sprint, is that you get to work with people and you learn from them. On Ocean Sprint, we get food delivered at the venue every day, so we can really focus on coding and not other things. And we usually hack way into the darkness. Sometimes we submit pull requests. Sometimes we push from a boat. We hack when we go to a restaurant, and we keep our laptops open even after dessert. So yeah, it's intense, it's super productive, it's fun, it's Ocean Sprint, applications are open. Everybody that was ever on a sprint, hands up, please. So everybody else, these are the people you can ask how it is to go to a sprint, do it, ask them. It's a really amazing experience. I still have 30 seconds, right? More, easy. So Ocean Sprint is a bit, like I said, I've been doing sprints for 15 years, so it's a bit over the top. Sprints can be super easy. If you have an office, if you work at a company and you have an office, or you can rent an office, just do that. Rent an office for a week or reserve an office for a week, post it online on the forums and on Matrix, and say, like, we're going to do a sprint in our town, our city, in our office, from that date to that date, who's going to come. And I'm sure people will show up, and then you're going to have an amazing week hacking on Nix. Now I'm done.
Wow, thank you very much. It's nice to have someone be on time.
Does it sound? Yeah. You hear me? Okay, cool.
Don't start yet.
Extra time.
Okay, I'm going to count down.
All right.
3, 2, 1, go.
Right. Hi, everybody. My name is Hugo. I care about security, and I really like to use containers for that, and I want to share this with you. So this is probably the most important folders on your laptop. If you look a bit at what you have there, and if the animations work, you have a lot of cookies, like session cookies, and these session cookies authenticate you to maybe the cloud console you're using with all the machines of your work, your webmail that allows you to get recovery passwords for all the software that you're using. Maybe you're logged into your Forge. Maybe you're logged in on your GitHub with access to commit access to Nixpkgs. Maybe you have a web-based password manager, and you're logged in on all of this. And it's not just Firefox. A lot of apps store secrets on your laptop. I encourage people not to do that and to use YubiKeys so you can ignore the SSH and GNU-PG folders. But still, you have a lot of secrets on your machine. And these can be accessed by a lot of commands that you might run. Pip install, NPI, all the supply chain attacks are very well known to be a big issue. It also works with Nix. And so it's not just for like development environments, it's also for an issue for servers. Many services that are packaged in Nixpkgs can have remote code execution issues, for example. This one. So NixOS containers can really help there. It allows you to isolate processes, but it's really easy to do, and that's what I really like with NixOS containers. You can compare them to virtual machines. Virtual machines provide a bit stronger isolation, but that's also a disadvantage because when it's in a container, you can share devices directly. You can share the host networking, so you don't need to worry about NAT and stuff like this. Everything is still on a local host, but cannot access all of your files. And you don't have to worry too much about allocation, like how much RAM do I need to give this container. And so one of the uses is development sandbox. So you can decide to only provide access to the code repositories that you're working on and not to the rest of your file system. You still have all the files accessible from the host, so you can just use all the apps you commonly use to access the files, but also have them in the development sandbox. And you can have all of your developer tools available both in the sandbox and outside. And so what's very important is that it just feels like home. In terms of Nix code, it looks a bit like this. So in this case, for my sandbox, I just don't start it automatically at boot. I don't have a private network. I share the networking of the host, so I don't have to worry when I'm on some Wi-Fi. And then I bind mount just my Git repositories. And this helps with a command not found on Git when you type a command. And it says not found. Well, if you mount this, it will not bother you with that and will tell you what package you're missing. With Flakes, it's useful to add these special args to pass the inputs to be able to use Home Manager if you want to use Home Manager inside the sandbox, which I find pretty convenient because that allows me to just re-import all my shell configuration, ID configuration, development configuration. I can just import everything in my sandbox, and I can feel the same on my host, on my sandbox, and it's all synchronized because it's just the same Nix files at the end. You can have whatever packages you want. And so Home Manager works in it. That's really nice to configure a lot of apps and have a reproducible development environment that you can also share with other people. If you want to, it runs as, you need to be root to access many of these tools. So these are like the pseudo configuration, so you don't have to type your password all the time. And you can have some shortcuts as well that make things very convenient. You just type send and you're in the sandbox. On servers, so it's a bit, the goals might be a bit different. What's important, what I like is that you can do easy backup and migrations with containers. You can isolate the containers network, so you can just give them a private local IPv6 address that's only accessible from the host. They cannot send data somewhere else on the internet. And then you can just run a shitload of stuff inside containers and see exactly how much data they are using. And you just need to back up this directory to back up all of the state to migrate it to another server. So isolate all the things. Thank you.
Nice.
Testing, 1, 2.
Let me get my timer.
Sure.
All right, you ready?
Yep.
3, 2, 1, go.
Hi, I'm Edgar. I'm bringing another container-related talk. And today I'll be introducing a new way of producing Nix images, Nix container images. So I'm going to first give a quick primer on existing Nix tooling for Docker images. The first one is from Docker Tools, build image. Basically all it does is it takes all the Nix store paths and put it in a single layer. You have build layered image, stream layered image, Nix2 container, and all those kind of related projects. They put store paths into more layers, but because of a kernel limitation, they're limited to at most around 100 layers. They all use some kind of heuristic in order to group store paths together so that there is better chance for dedupe, but they all suffer from kind of the same fundamental issue of the kernel limit. Even more so, you have all these perfectly good Nix packages already in your Nix store, and it's kind of a waste to translate them into a slightly different format just so that the Docker runtime understands it. And you also can't leverage any existing infrastructure like the Nix binary cache. So I want to introduce Nix Snapshotter. The goal of the project is to get the container runtime to natively understand Nix packages. A secondary goal, and equally important one, is to stay conformant with the existing OCI spec and the existing container runtime implementations. So we want to get this working today and have it work with stock Docker, Containerd, Kubernetes. The API is basically the same as what you see before with Docker tools, name tag, config. The closure of the Nix package gets slurped into the Nix container image. And what we do leverage to make it work is this annotations field inside the image manifests under each layer. And we essentially use the key value kind of dictionary to put all the Nix store paths and not inside the layer itself. So you end up with basically tiny layers. And if you have a Nix closure already, and that's, say, let's upload it already to a Nix binary cache, container build and push basically becomes a constant overhead and it's basically instantaneous. Just to speak about how it works, the container ecosystem actually has quite a good modular system, kind of like Twix. The Kubernetes talks to Containerd. Containerd has this like gRPC plugin system. You can replace subsystems of it with external gRPC speaking services. So the snapshotter is replaced by Nix Snapshotter, which understands Nix. Some of you may have heard about Nix Snapshotter already, so I want to just take it a bit further with a feature that you might not know about. So assuming using Nix Snapshotter, you can create an image, and you're managing the image and the pod in Nix, and then you have to push it to a registry so that Kubernetes can pull it. If you want an immutable reference, you want to pull by digest, you go ahead to digest and put it in the image name, and then apply it to Kubernetes. Nix Snapshotter I'm simplifying here, but would pull from the Docker registry and then do bind mounts for the Nix store to prepare the container root file system. The image from Nix Snapshotter, when you build it, the out path is actually an OCI tarball. And if you add this magic prefix, Nix:0, now is a legal image name, a little bit cursed, but Kubernetes would accept it, which means now you could essentially string interpolate the value of build image into the image name of Redis pod, apply it directly to Kubernetes, and then Nix Snapshotter will resolve the image and do the bind mounts all entirely from the Nix store. And for the first time, you have a completely self-contained, no external state way of deploying a pod. So it's open source. It works today. There's NixOS modules, home manager modules. Notably, it works with all existing images that are not even produced by Nix Snapshotter from Docker Hub. You can even interleave normal layers with Nix Snapshotter layers, and it's tested end to end.
All right, 10 seconds to go. Thank you very much. You're next, right? Correct? You need the microphone.
Check, check. Am I holding this right?
Are you ready?
Sure.
Then I'm going to say 3, 2, 1, go.
All right. Hello, I'm Summon Surge, and this is news with CUDA packages. The first one, I've chosen the news arbitrarily. The first one is that people used to say you can't access special hardware in derivations. Of course, you can. Now in Nixpkgs, there is upstreamed infrastructure to run derivations, which can request access, for example, to GPUs, and in general, request an additional host configuration. This is a snippet written yesterday, I think downstairs by PBSDS, which uses PyTorch 3D, which we are about to merge into Nixpkgs, to generate a bunch of random rotation matrices allocated on a GPU using CUDA. That results in a tensor, which is also allocated on a CUDA. It's converted into a Euler angles representation, and here's the result. You build this magic GPU check thingy, and you see that in the logs of the derivation, you're actually allocating a tensor on a GPU device. We're using this for a couple of tests in Nixpkgs already. It's upstream. It's not run in any CI in any systematic way yet, but you can use it. You can use it to also run like real workflow, render pictures and derivations. The way you configure the host is you set system features with some arbitrary string used to distinguish the special derivations, and then you enable a Nix pre-build hook, which is going to mount the device nodes and drivers into the derivations sandbox when it's requested. Somebody said pre-built hook is an ugly hack. It totally is, but I think the interface that you use in a derivation is kind of okay, which is you have a derivation, you have required system features, you put a flag. If you have a remote builder that doesn't have this CUDA feature enabled, that signals that it wasn't configured probably doesn't have CUDA devices, it wasn't configured to expose CUDA devices, and then the job does not get scheduled to that machine. So yeah, you can use it. You can use it for other stuff. For example, if your derivation expects that it can write into /var/cache/ccache, you can also signal it that way and set up the appropriate configuration. And you could even go further. And for example, you could make internet access a system feature and fix this situation. You're offline on a plane or on a ferry, and you try to build a package, and then Nix tells you that it's trying to build a .tar.bz2 package, which is probably something you could have rejected if we provided Nix with any idea that this is not just buildable, you need internet access. In other news, thanks to Jonas and Mick92 and Zowok, and thanks to the Nix community project, there is now a CUDA cache. It's unofficial. It has nothing to do with the NixOS Foundation's official NixOS cache. It's separate. All the legal issues are separate. There are none. I'm not a lawyer. You can use it. It builds CUDA packages with the default parameters and CUDA support true. And yeah, you can find more online. And in yet more arbitrarily chosen news, the situation with using CUDA in Docker and Podman containers on NixOS now sucks less because Ereslieber implemented a CDI integration module in NixOS that you just enable and it works. And he's even updated the documentation, which tells you how exactly to use that in a Docker compose file and in a command line. I wish more contributions were like that. It's beautiful because it works. There's a lot of stuff that is missing. You can ask about it later, maybe on a hack day. Regardless, I think I'll just cut it here. Thanks.
All right, thank you very much. Our next speakers do not have slides, so you can look at the KDE screen if you want. Is that okay as a background?
Perfect.
Are you ready?
We are.
Then 3, 2, 1, go!
Hi, my GitHub nick is AFH.
And my GitHub nick is DWT.
Recently, we came across a pull request that removed a single maintainer from a bunch of packages, effectively orphaning them. That sparked our curiosity, and if our possibly too simplistic Nix eval expression is correct, we found about 27,500 packages without maintainer. So we also dug a little bit further, talked to a bunch of people, and found there's RFC 180, which proposes a process to remove unmaintained packages from the Nixpkgs store. And that came, or we had the idea of possibly creating a bunch of folks and teams to create awareness about unmaintained packages, calling it the Nix orphanage. And one of the, what we're trying to do today is start a conversation. Do people already have something in the works where effectively for these orphan packages, a greater awareness is being created and raised so that possibly through tooling, GitHub labels could effectively show which packages aren't maintained. One of the later goals in the future could be for that team or the Nix orphanage to find and onboard new maintainers. And what would you think if an event like this today would have a 2-hour or 3-hour workshop of adopt a package? So, you know, you can adopt your personal package and become a maintainer from these. Potentially, one of the responsibilities for the Nix orphanage team could also be to do very minimal maintenance, but the main objective should be to raise awareness about these orphan packages.
Maybe I'll take the last one. So to start, we'd like to get some dinner, some ramen maybe, after this. And I would love for you to join us and have a talk about ideas, what efforts are actually underway already, and how we can maybe work together and get this started.
Or find us tomorrow during the hackathon. Thanks so much.
Thank you very much. Come on stage, come on.
All right,
Don't be shy. This is yours, right?
Yeah, thank you. Let me know.
Are you ready?
I'm ready.
All right, 3, 2, 1, go.
All right. Hi, I'm Jonas Chevalier or Zimbatiem. And I thought, this is last minute, but I thought I was present to the Nix community project. It's something I started a while ago, before the NixOS Foundation really was a thing. And I wanted a place where we could get things done, and that was low overhead. At the time, it was hard to make projects official. So I wanted a place where we could just put some repos and share them. So yeah, we are a small team. We're with Make92, Adis Blades, Rantium, me and Zoak. And nowadays, it's mostly Zoak taking care of the infrastructure. So thank you, Zoak, who's not here. And just so you know what we provide, so we have like this GitHub repo with a lot of repos in it already. And you can propose your repository if you want them to be co-maintained with other people. It makes it easier if the location of the repo doesn't change. We also provide the shared build infrastructure with Arch64 Darwin, Linux, x86-64. We're also running build.nix that you heard about recently. And we also have community builders. So those are big machines where you can get access to. That's useful if you want to have big rebuilds, you don't have the compute power, or you want to test things on maybe macOS and you're also just on Linux. And yeah, you can just request access. You might have seen also this bot doing some things. This is also maintained by us. And yeah, someone just announced it, but now we're building the CUDA packages and also unfree redistributable packages. And yeah, that's it. It's just a sister project to the NixOS organization. I think eventually it's going to be merged in once we figure out of the community assembly things. And yeah, if you want something to be done, just reach out to us and we can provide you compute or anything. That's it.
All right, thank you very much. Wow, this is great. It's like I was thinking like chess time, like under 5 minutes is blitz or lightning. So this would be bullet, like bullet chess, except it doesn't make sense because bullets are slower than lightning, I think. So next speaker. Yeah, come up. Is yours going to be a lightning talk? No, that's not yours? Okay, which, this one?
This one, I guess.
That one. Okay, then we'll do a different order.
All right, I guess I might as well start. So,
Wait. Let me start the timer. God damn it. Yeah? You want to be a cheater, yeah?
Well, here I want my 5 minutes, 5 seconds, I don't know.
Okay, I'm going to say 3, 2, 1, go.
All right. Hello, everyone. I'm Gytis Ivaškevičius, and I'll be presenting Nix Toolbox, or at least part of it. Arrow keys don't work. Brilliant. Yeah, I don't think your computer works very well. No.
Let me give you some extra time.
No.
What do you need? Oh, you need the mouse?
I will need a mouse.
You don't know how to use the clip mouse?
I'll need a scroll.
This, come on. Like.
Oh, it works.
Okay, I'll give you 20 seconds more, okay?
All right.
It's your fault for not knowing how to use the clip mouse.
All right, so as of right now, Nix Toolbox has 2 integrations. One of them is Helm, which is what I'll be presenting. It's mostly based on KubeNix and OCI. OCI might get merged into Nix2Container repository fairly soon, but we'll see. So main features of Helm integration are that resources can be defined as either Nix or YAML expressions. This is mostly used for migrating to Nix. It provides structure like other tools, including Helm, which requires additional package Helm file. And since it's based on module system, we can do kind of CRDs, basically map one attribute set into, I don't know, 10 resources or something. And yeah, this is an example script. it's an entry point of the whole deployment. Now, only if I could figure out how to scroll.
The middle button, yeah, or like that.
Oh, brilliant. So at the top here, we have defaults block and targets block. One target defines one environment. In this case, we have prod environment and dev. At work, we also have, depending on cryptocurrency, like network or region as well. So there are a lot of cases for us. If you guys notice, this is a recursive attribute set. It has like final keyword. And I don't know, at the top, we define the defaults, and we override it at the bottom. Right here, we have an example of overriding just partial deployment resources. And the deployment itself is defined here. We have some issue with formatting. Brilliant. Yeah. Let's take a quick look at the CLI. We can build it and just see what it templates. Plan just diff. Maybe I could scroll it or not. Yeah. Apply is the same thing, only it gives us a nice field. We have concept of target groups, so you can define whatever you want in a target group. For instance, we do one for live deployments, one for dev deployments, just to speed it up. All right. That's a second deployment, and yeah. And it's worth mentioning that we have YAML to Nix utility. It's in a different repository as of right now. I haven't migrated it since, yeah, I want to do a slight rewrite. But yeah, it's used to convert YAML definitions to Nix expressions. Oh, that's even wrong. I don't like your laptop. I don't know.
I'm sorry.
Anyways, thanks for listening. Yeah, that's the last slide. As I said, the repository is Nix Toolbox under Dev Palace organization. That name was created by ChatGPT. Thanks a lot to it. And yeah, that's it. Thank you.
All right. All right. Thank you very much. Sorry for my computer. It's a shame that you don't like the X220.
Okay. Hello again.
All right. Are you ready? I guess. Yeah? Okay. 3, 2, 1, go.
All right. So I recently mentored a Google Summer project for the NixOS Foundation. Thanks to Yannick Hag for organizing that. That was a lot of fun. I proposed a project about sort of a scheduling Nix builds. The situation is as follows. You maybe have a flake. You have a derivation A. And you also have a derivation like a.override Qt support true. And the latter one depends on a Qt version of PyTorch, Qt version of OpenCV, and NVCC, NCCL, MPI, and yada yada. So maybe you have OpenCV CPU cached locally in the store. Maybe you have glibc in the store. Maybe you can download PyTorch from cache nixos.org, but you can't download TorchQt because you've updated the Nix packages, and now it's a mass rebuild. So say you want to build those A and AQ to test them in a GitHub action, and then you just time out because of the mass rebuild. Is there a good solution to this? Probably not to use GitHub actions in that way. The low-tech solution that came to my mind is that just tell Nix that it can't build more than 100 derivations, and then it has to choose only some, and then generate a report that, okay, I didn't test that because I couldn't, it's out of budget. How could you do that? Well, say you're in the whole your closure of A and A CUDA, you've got n derivations. You number them. You can mark the ones that you actually wanna build with ones. So you generate a vector of values, 0 for the transitive dependencies, 1 for what you wanna build. Depending on whether the thing is cached or is substitutable, you can choose a different cost. And then you want to find the vector x, 0 or 1, whether you actually do realize the thing in the store. What do you want to do? You want to maximize the value, the total sum of values that you've chosen. You want to constrain the total cost. And you want to make sure that if you build x and x depends on y, then you also build y. That's just an inequality. And TLDR, it's just a linear program, an integer linear program. During the GSOC, we've implemented the proof of concept. Sin and Mohd implemented it in C using an off-the-shelf iterative solver for mixed integer linear programs. There's still a lot to do, but it's a proof of concept. And you can run it, for example, on mentioned earlier Llama CPP repo, and you tell it build 4 things, and it'll say, okay, I won't build CUDA and I won't build Windows because that requires a lot of stuff, but everything else I can get the dependencies from NixOS cache and start building directly. We have integration tests. We've implemented a small DSL where you can describe a NixOS test with 2 machines, a builder, and a remote substitutor, which has some of the derivations in the store, some of the outputs in the store. And then you say, okay, here's the graph of dependencies. These things are cached, these aren't cached. And here are the constraints. Make sure that when you run this program, the generated plan is actually as we expected. We tried to do more. We didn't have time to actually implement the whole thing, but instead of like binary costs, like whether the thing is cached or not, you could implement something smarter. And for example, you could just come up with some scheme to estimate what would be or should be the price of a particular build of a particular derivation, and then just constrain the estimated total build time of your closure. So can you do that? Can you do that well? I don't know. Is there an obvious approximation scheme? Yeah, kind of. So what we tried is we have a new derivation. We're going to look at its input DRVs. We're going to take its P names because probably all derivations have P names. We'll lose the hash. We'll lose the version. And then we'll just say, OK, here are all the P names that, for example, NixOS Hydra knows. Here are all the builds that it knows. We'll just, for each build, of a particular derivation, we'll put a 1 if it has this P name in the closure and 0s elsewhere. So we use this thing to regress the build times. We get something probably not very good, but it's something we can train on and infer on, and then later with the same interface
10.
we can come up with a better approximation scheme, I guess.
5.
Yeah. Let's chat about it later, maybe.
You're gone. Okay. Thank you very much.
Sure.
Let me get my timer ready. Are you ready?
I think so.
Great. 3, 2, 1, go!
Hi, I'm Sandro. You've probably seen me on the Nixpkgs repository. I want to deploy a custom NixOS search for the longest time, like search.nixos.org, but it always kind of threw me off that it required an Elasticsearch. And I haven't set up like an Elasticsearch before myself, and it's pretty big, and it requires lots of RAM, so I've always pushed it in front of me and like never actually did it. And a couple of weeks or months ago, I talked to a friend, Marcel, and we kind of kicked off NixOS Search, which solves like some core problems the official search has. For once, it's compiled to like a static website, so you can just deploy it on GitHub Pages without any backend. and it's like really easy to run. And probably every project on GitHub can just deploy it within like half an hour at most. And the second one, the official NixOS search has like that Flakes experimental tab. I haven't really used it, and if you try to use it, it has like some accessibility and obvious flaws. So it's like the experimental label is like warranted. For example, the links to the source repository are always in NixOS, Nixpkgs, and like not the real repository. So you get 100% of the time a 404, which is pointless. And yeah, so we built the NixOS search. It's based on an Angular front end, and recently we switched the search algorithm to a Rust-based one, which is then compiled to Wasm and integrated into the Angular build. Also, the Rust backend builds like a custom index file. We choose that way because we want to be like really, really fast and really tiny. We have good support for custom flags. How you could already see on the introduction slide. We have Home Manager, for example, Nixpkgs or Nixvim, all in one. And it's not interactive, but under scope, you can like choose between the different flags and like limit it to like, I only want to search in that flag or in that flag. It's licensed under MIT because why should we care about the license? Just do what you want with it. We have a deployment under search.NixOS.de with and without the U because not everyone has that on his keyboard. And there are already 2 community deployments I know of. Nixvim is using it because they have like a shit ton of options, and only looking into the documentation is like, you don't really know what you're searching for. So we talked them into like, or we suggested to them that they may use our search, and they were like, yeah, cool. And also TechSpace, I'm from, the C3T2 in Dresden, has like also our own search so that we can search in our, I think, 40 flag imports and like find anything. And yeah, that was basically it. You can find it under that orange link. And yeah, I hope some people are inspired to maybe build it into their own custom flags, custom modules, custom repositories, so that everyone can like search in the options more easily, and it's like easier to get started with things, and you don't need to like read the module source code. So thanks.
Thank you. All right. Yes. Das war's. Okay, this should be our last one. Are you ready? Are your microphones working?
Test. Test. Yeah.
Very good.
Nice.
You ready?
Yeah.
Try not to stand on that thing. There's snakes underneath. Okay, 3, 2, 1, go.
Hello, we are Ali and Lexi, and today we want to present a flaw we found in Nixpkgs that would have allowed us to pawn pretty much the entire Nix ecosystem. And it only took us about a day to start searching, to reporting it today, and actually getting it fixed. Where was it? The vulnerability, it was in GitHub Actions, of course. GitHub Actions can do a lot of things, pretty much everything, and they are an easy target for attackers because if you have a problem, you can just commit code and then you have an without authorization, and then you have a supply chain attack.
And it's also entirely in YAML. So short primer on GitHub Actions, an action runs if a trigger triggers it, and there are a couple ones like pushes or commits or pull requests. There's a special one though called pull request target. It has a few differences from pull request and crucially has read, write, and secrets access by default. It sounds vulnerable, it itself is not vulnerable, but we can just look if it's in Nixpkgs. It indeed is. So this, for example, is actually a secure thing. It does use pull request target, but the secret is just passed to another action that is completely secure. That's no problem. But
there is an action called editor config. Here's a simplified version of it. At the top, it just creates a file called changed files, which is just a list of files, file names that have been changed in a pull request that has been opened by anyone. And then it just checks out the pull request. And with the pull request, it cats the changed files via xargs to editor config checker. And you might think, what's the problem? But if you know xargs and have read the man pages, you can see it is not possible for xargs to be used securely. Yeah, there are quite a few ways to attack these with xargs. For this example, you could just create a file with a parameter for editor config, for example, help, and then yeah, editor config will be called with the help. And yeah, you would need to audit editor config to find something to actually execute code, which we haven't done yet because it was a Go program and would have taken a bit of time. But it is most likely possible to do anything and execute code.
And then we looked at the code owner's workflow. It basically checks out your code. Builds from the actual base repository the code owners validator tool, then runs that on the new code owners file. And the fun thing is, we can just shove stuff in there because it's in the pull request, and it helpfully tells us, yeah, that content of that file is not correct. So we just put in a symlink to the runner.credentials, and we have a read-write token on Nixpkgs from GitHub Actions. This basically allows us to write into Nixpkgs however we want.
Also read all the secrets that
Yeah.
Nixpkgs uses, so cache token and stuff like that. Then I will talk about the fix. Yeah, basically you shouldn't mix user input with secrets, and if you do, you should be very careful. That's because if you have a workflow with secrets, and user input gets handled in it, then you can pretty much always extract the secret, be it the secret is written in some shell script that's stored anywhere, and yeah, you should limit all permissions and read the docs. You can do this if you think your organization has yeah, any vulnerable GitHub actions before anything happens, and this is how it was fixed in Nixpkgs. We basically first disabled the vulnerable actions on all branches, and then pushed fixed ones to yeah, to affected branches. And yeah.
Some thanks to some people. First of all, to Intrigus and everyone else at KidsATF. Intrigus held a talk about exactly this issue and other things, and basically taught us how this works. And shout out to Infinizil for literally fixing this today from arriving here to getting the talk done. And some further resources. The slides are also online, probably soon. The blog post from GitHub is very good if you want to read more up on it. It's
3 seconds.
Nice.
All right. Thank you. Okay, we're finally done. Not because like I wanted this to be over, but because yeah, we're finally done with NixCon before well, but before our last event, or I don't know if we could call it an event. I want to ask all of the Orga people to come here. Please stay here and yeah, just hold tight. Well, actually, wait. Let's thank all speakers again. Like everyone gets a round of applause, and they got a round of applause. But now another round of applause for everyone. This was great. This was a great block. Pink shirts, come on. Can you change the background to something more pleasant?
Maybe not ideal.
Like, how about the animation thingy? Yeah. All right. No. Oh, you can only no. That's good. No music. Yeah, that's perfect. Okay. So let's just go up. I mean, some people said it was cringe. They don't want to come up. So everyone who wants to embrace the cringe, yeah, don't step on the death trap. Exactly. Come up, Ron. You too. So we're not all of the organization team, but most, I think. Right? So yeah, I'm really happy the way it went. It's been a really stressful time. Like these last few days were really cool though. And first of all, I want to thank all of you because I think you also made this event be really, really great. So let's give everyone in this room a big round of applause. So I don't want to name any names because I'm going to forget some people. So I'm just going to shout out all of the teams that helped us. First of all, the initial organization team of just, saying, yes, we want to do this. We want to do this in Berlin. Thanks for them. Round of applause. Yeah, initiative. Thanks for the audio and video team. They were a big help. I'm going to try and get out my list. I wrote some stuff down. Okay. So thanks also to the CFP team, to the people who took care of like gathering all the talks and everything and doing the schedule. Thanks to them. Thanks for people who took care of the merch and the logo and the branding. I thought it was really cool, the stuff that they came up with this time. I like pink, yeah? Aside from just the audio-video team, also anyone who helped get the stream and all, just providing us with nice streaming stuff, gear, that got some really awesome shit here. So thanks for that. Also, thanks to everyone who helped with anything like here in the venue, like the doors, the door shift and stuff, like, and like what else do we have? Yeah, that, thanks. Front desk, yeah, that's what I mean, the front desk, yeah. I'm struggling to find my words. Thank you to the awareness team. Really important. Of course, we got to thank people in advance for helping us clean up tomorrow. Yeah. So now is where the cringe begins or continues. Like, did I forget anyone? Does anyone want to say anything? Look, come on.
Right. So, hands down, I mean. Have you seen a pick-me-up like this? You haven't. That
was actually not what I was waiting for. I actually almost thought of like doing that first to get it out of the way, but yeah, thanks. Thank you, of course. I forgot that, yeah. And who wants to give any other shout-outs? Maybe to the community? Like, okay, shout-out to the community, right? Online, offline, everywhere. Does anyone want to say anything? Come on, you're so shy. Only Ron wants to say something. Come on. That's it.
I mean, do you want me to say something?
Yeah, come on, say something. I mean, you called your speech the State of the Union. That makes you the president, right?
Yeah, State of the Onion. Who told me that? Someone told me that next time I should come with an onion and just like was it you? For some reason I expected like that would be something that you would say. Anyways, everybody here, I mean, This is like our third of like NixCon after coming back from a long break in COVID. It's insane to see the energy in the room, to see everybody. I think this is like a super unique community. I don't know if everyone kind of stops for a moment and recognizes that. Like, I don't know if there's another community that goes to a sauna after this, like questionable, but it's like, we really have a thing going on here. We're really like, you know, it's amazing. So thank you all for making it happen. It's the energy in the room. It's the benefit of the doubt. It's like these open conversations and really having a good time. And I can't say enough that I won't swear, I would still not swear on stage. I did very little, very, very little, I was gonna say a swear word, compared to the gang up here and to everyone around. So it's just incredible, like what you put in. And I do hope that folks here will at some point organize a NixCon and be like, damn. So again, like huge round of applause to you guys. And yeah, NixCon next year, let's do it.
All right, I'm guessing I'm just gonna end this. So, yeah, let's. Well, we need to go soonish, right? But we can, like you said, we can grab some beers later. That's what you said. Also, since it's now legal, I can say we can smoke some boo-butts together. And yeah, do we want to have another Carlos Matos? Nah, too cringe.
You asked the right person. Lassulus is like,
come on. Okay, come on.
Let's do
one more. Okay. The world is not anymore the way it used to be. No. What's up? NixOS! All right. Thank you, everyone. Hey guys, by the way, I forgot. Tomorrow's another day, right? Tomorrow is Hack Day, yeah? Or that's what it's called, right? Yeah, Hack Day. Like, but I'm gonna sleep a bit, yeah?